of that curvature?
What kind of direct measurement?
Well, with the tools that we use for surveying, like we point out when we measure across the surface of the Earth. Like those tools are applicable, theodolites, lasers, other signal propagation. So surveying.
Okay, well, there are tests done with those that do show a globe.
Okay, can you give it to me? Which type of test? Which type of test is it?
What, the light ones?
Yeah, specifically which one?
I don't know specifically, but I know that there are.
But you said
ones.
there were loads. So which one? You said there are loads, so I'm asking for one. You said you don't know now. I'm confused.
I mean, I know of them. I just don't know of.
Okay, so which ones do you know of?
Again, I don't know of a specific one. I'll find one if you want.
Okay. You don't know of a specific one, but you'll go and find one that you've seen before or one that you hope is out there.
How do you know? Like, okay, let me write. I wrote this down. He knows of them, but doesn't know of them. How is that? Okay? My head hurts.
Yeah, no, this is why my head is in my hands. Like what?
As in, you can know something exists, but not know of a specific example. Like,
so I can know something exists
because you've got a vague recollection of something maybe that you saw in a documentary, maybe with Sir David Attenborough or something, maybe about 9:15 before you fell asleep. What?
I mean, if I did, then that would still be.
Are we just dealing with your vague recollections of shit?
He just said that's proof by falling asleep to that guy. Yeah, he said that's proof.
You said it's been measured with tools. I'm asking you specifically who, what, when, how. Like any of the details, and like you're foggy and cloudy. Interesting though, right? Can you back up your claim with any type of, recollection of what even happened, where it happened, who it was, what instrument was used, the distance, anything at all? You understand why we get so fucking frustrated, don't you? Like, surely.
Is the gentleman who mentioned oh my god, the eclipse thing, the Selenelion eclipse, is that gentleman?
Yeah, we're all here.
Who did mention that? Was that Eli?
So, from what I understand, the clash that you're asserting here is that during a lunar eclipse, according to the globe model, the three bodies are arranged in a syzygy. And during a Selenian lunar eclipse, both the moon and the sun are visible above the horizon, and therefore that cannot be possible if
that's not
during
all.
because a lunar eclipse requires a syzygy.
That's not all, bro.
No, that's not what I said. What I said was the explanation is an unfalsifiable claim. No, I just wanted to say that because we already getting off to a bad start. I said the explanation is an unfalsifiable claim. That's what I said.
And if you look in the text chat, you can see I posted a screen grab of a Selenelian eclipse, and what happens is what you believe is Earth's shadow comes onto the moon from above.
What do you mean by above?
Just look at the image.
The Trace AI one.
Yeah.
There's no AI images. The image where it's all shiny on the bottom of the moon, that's the light on the bottom of the moon, and the top is supposed to be your Earth shadow. How does that happen if the sun is up in the sky and the moon is in the sky at the same time?
Okay, first of all, lower your microphone input, please. And his name is Drace AI. His username. I wasn't claiming that it's AI.
Do you see the problem when he speaks about the shadow, though?
Okay, Sorry, give me one moment.
No worries. It's a geometric issue with the shadow.
Sorry, I'm back now.
No worries.
All right.
So you see the observation, right, where we've got the shadow on the top of the moon. I mean, I know it's only a still shot. I've seen this myself. The shadow can either come downwards from the top to the bottom or across the top of the moon, let's say from the left to the right, not touching the bottom. Do you want me to explain the problem?
Oh, just give me a sec to go through these slides. All right.
Okay, no worries.
All right.
I just want you to understand it clearly, dude.
Oh, okay. And this guy, he says, once you're done destroying the fundamentals of science to uphold your scientism,
I'm not interested. Just want you to look at the pictures,
I know. I want to look at them too. All right. What you saw, what should have been. Impossible upside down eclipse. Okay, here's a GIF. Okay, so the impossible aspect of this is that the shadow is on top.
Yeah. Okay. So we've got the impossible aspect of we don't actually have a true syzygy here. There's definitely an angle in the sky, like we pointed out, but the shadow's in the wrong place. Whether this is at sunset or sunrise. Okay. Now we've got, say, the moon coming out from behind the Earth. That would mean that as the moon rises, as it comes out, that means that the shadow would be at the bottom. The moon would be slowly illuminated from the top, and you would slowly see more of the moon and the shadow at the bottom. But what we've got is the shadow at the top. Now that's a geometric impossibility, dude. For example, if
look, so
okay,
so I mean to like properly like sort of like discuss this, we have to like build like a 3D model. I don't have like a Blender software at my, you know what I mean? So like to like prove that, you know what I mean?
Yeah.
So, but what I can see from this picture, okay, so like I'm talking about the mountain range picture. So we have okay, so I'm imagining like okay, I'm on the surface and then there's mountains in front of me and then the moon is setting. So I guess the top picture is the most recent one. Is it setting or rising?
I think it's setting.
Okay. So the moon is set. So the bottom one is the most recent one, which means the Earth is rotating away. It's like rotating through the day-night cycle. So in this picture, you are rotating towards the sun.
Yeah, ever so very slightly. Dude, this is probably only going to take about an hour.
Well,
it's only going to take about an hour and a half.
Yeah. So if you have the shadow of the so you have the sun, and then there's going to be a cone of shadow coming out of the Earth. And then
now it's a cone of shadow.
Well, yeah,
that's fine. That's fine. Every single time he dips the moon into the shadow, he'll reach the same conclusion. The bottom of the moon for the observer should be in shadow, but it's not. Keep doing the 3D model, dude. The only way that you can do this is say that we're on the top of the Earth and somehow the moon is being bent around the Earth and you're seeing it on the opposite side of the Earth. But this would absolutely falsify the model in every which way that you could go for it. But ultimately, just try to, in your model, in that cone of shadow, keep entering and taking that moon out. Then put yourself on the Earth, try to observe that, and notice the shadow should be on the bottom of the moon from your observer position.
Okay, so my task, as you've laid it out, is to draw some kind of diagram, some geometrically valid diagram, where the sun is, so where the Earth's shadow is intersecting the moon like this, and find some point of perspective on the surface of the Earth where if I looked at the moon, I would see this orientation of the shadow being on top. Right? Like, and that's what you're asking. Okay.
Yeah. Both sides of the moon have got to be above you. That means that the moon can't be on the other side of the Earth underneath you.
And if you're good at drawing, this will be great because then once you debunk us, I'm gonna throw all my computers away.
And then,
so at least I understand now what the contention point is, because from what my research was, that the flat Earth contention is that you can't see both in a syzygy. But I was going to bring back refraction, but I guess you're one step ahead of me on that.
Yeah, it's a little bit more complicated than this.
Okay.
It's kind of a threefold argument, right? One, you can bring the syzygy aspect into it, and all right, you can maybe play around, but this isn't a true syzygy. Even within the model, it's not going to be.
Wait. Are we sure that this picture is of a Selenelian eclipse and not just a partial?
Yes, you can see the shadow getting bigger and the white part getting smaller.
Yeah.
Well, it's also moving further away from us, right?
I have seen a Selenelian eclipse myself in 2019. Literally scared the freaking life out of me, dude. The moon was full, and then when I looked out the window about an hour later, the moon was smiling at me like a Cheshire cat because the shadow went across the top of the moon. It was a partial Selenelian, but the shadow being on the top of the moon was that geometric impossibility. Because every single time you play around with this, if you're on the surface that's beneath you causing that shadow, and that object is coming out from that shadow as it comes up from the horizon, you're going to see the illuminated part first, right? As I stand up from behind my hiding position behind my sofa, you're going to see my face first, aren't you? Not my feet. Same in this instance. It's illuminated the wrong way round for the Earth to be causing that shadow.
I posted illustrations to support what you said, Jedi.
Thank you, sir. So like I said, we've got three problems. One, the syzygy issue. Two, where the bloody shadow is. And three, the claim that that's the curvature of the Earth and the Moon.
Wait, but I thought you said that the syzygy thing wasn't an issue because it's explained by refraction.
But yeah, it's an issue that you have to explain, right?
Well, and it's been explained by refraction.
I know, but it's an issue you need to explain away. Now, I don't know whether your explanation is true, whether that's actually the sun or the moon, but we're now starting to refract shadows all of a sudden. It's really weird.
Not only that, though, then you can't. Not only that, once you start refracting moons and suns, you can no longer shoot rockets and land on them because they're not really there anymore. So you either take refraction and you can't fire rockets at it, or you don't take refraction and you explain how you got a shadow up on top.
But you guys love refraction. That's how you explain, like the horizon.
No, that's how you explain it.
By small deviations, and if we're talking about things in the sky, we're dealing with arc seconds, dude. Not the whole fucking moon or sun projected into places where they fucking shouldn't be. Like I said, it's a geometric issue that you need to explain away. So there is an issue there. Thanks for to explain it away. So, dude, please, I told you that there's three arguments, and I still only said the two. Twice.
I think we're playing word games again. Just give me one moment.
No worries, dude. You're fine.
I'm trying to draw this thing out.
That's fine. That's fine. We've all been there trying to draw it out.
So do you accept refraction as an explanation for the syzygy contradiction or
not? No.
Okay.
I like it when you like to throw it out there.
Well, no,
because it's primarily, if we look back into the historical arguments about the Selenelian eclipse, we'll find out that refraction is probably the first time we hear it really used to explain the phenomena away. In this variance, the horizon and boats and shit that comes later, but I think this goes back maybe 400 years to how they explain
so you
this.
do accept refraction as an explanation as to
I did
sometimes, but not other times?
Dude. Okay. Refraction requires certain conditions, doesn't it?
Refraction, yeah, specifically.
Yeah, good. So I will accept refraction if those certain conditions are met. How about that?
Well, under both the proposed flat Earth and globe Earth models, there is a gradient of optical density, which is density near the surface. And so,
yeah, that's nice. There's also a temperature gradient as well, right?
Yes, in both models. That's
okay,
right.
So which way does light deviate, towards the denser or less dense medium?
Well, if light strikes a boundary between two different.
Now, just towards the dense or less dense medium, which one is it?
Well, it depends on which one it starts in. So if it starts in the denser medium and it strikes the angle and it strikes the interface, and it will deviate towards the more dense region.
Yeah, it deviates towards the more dense region. Yeah, that's what I asked.
Yeah,
Where's the more dense region?
I took optics. That's right.
Where's the more dense region?
On the surface of the Earth, it would be towards the surface.
Yeah, but not on the surface.
Not on the surface? Oh, just
like
above the surface?
temperature deals with density of gases, right?
Yeah,
what happens to temperature as gases rise?
Well, the density is also affected by the.
What happens to density as gases? Sorry, what happens to temperature as gases rise?
What happens to temperature as gases rise?
Yeah.
Rise?
Like cool.
Physically go up?
Yeah, as gas goes up, what happens to the temperature?
Well,
it cools, dude. Come on.
Well, no. Well, that's the thing because
yeah. Well, sorry, where's the energy coming from then?
Well, no, because because the reason I'm kind of thinking it through is because I do know that there's like some very high altitude
yeah, but we're talking on the surface, dude, aren't we?
That are very low density, but the individual molecules of that gas have a high individual.
Yeah, but we're talking about on the surface, though, aren't we? And we're talking about the gradient of temperature and density on the surface. And I'm trying to point out to you that the relationship between temperature is very much secure to density. Now, as the temperature of I'm going to go to bed.
So the definition of temperature is the average kinetic energy of the individual particles. And so,
sorry, are you now trying to educate me on the point I'm trying to raise to you?
Well, what I'm saying is,
like, forgive me for being frustrated.
If the density
I was talking. It's like you keep interrupting me, thinking that I'm not going to bring shit up.
All right, go ahead.
Like, for fuck's sake, dude. Are you reading my tea leaves or something? You've got some tarot cards out. What is it? How do you define my thoughts? Because you're shit at doing it. Stop. All I'm trying to point out to you is, like, you keep trying to witter on, like, something to say it, is light, as yes or no, does it or doesn't it, goes towards the denser medium, doesn't it? And the denser medium is where the cooler gas is, not where the warmer gas is. Gases reduce in temperature as they rise, don't they?
Not necessarily, because temperature is
okay, so there are different refraction. Okay, so what we're going to conclude is, I will agree to refraction as long as the conditions are met. That's the conclusion, dude. You just arbitrarily saying stuff isn't really going to change that fact, as long as the conditions are met.
But you are arbitrarily saying that the conditions are not met during a syzygy of the Earth.
Sorry, what condition? Sorry, hold on. What conditions? This has been predicted for thousands of years. Did they know the weather then?
No. I'm talking about the visibility above the horizon problem with the syzygy.
Yeah, of the moon. And where it's going to appear. Well, that's going to change, isn't it?
No, I'm talking about
depending on what's in the atmosphere on that fucking day and how the light's going to deviate for it.
No, I'm talking about the specific issue.
Well, what causes the refraction then?
The gradient in optical density as you go up that.
Which changes?
Yes, it's higher. It's
higher near the bottom. But these things have been predicted for thousands of years.
No, but you're talking. Yeah. We're talking about two different things.
Yeah. So within these predictions of thousands of years, did they know the fucking weather?
We're talking about two different things.
This is what I mean about the conditions being met.
But it's relevant to the original point.
You're just making. But this is embedded within the claim of what will explain that it's not in a fucking syzygy then. Refraction is move the object into a place where it shouldn't be. Now, I would agree with you that light can deviate, but we're talking about something that's been predicted for thousands of years.
So I don't understand what your contention is, because it feels like we're jumping back and forth between two distinct points. So you're the whole thing about predicted thousands of years, that's to discuss like
where the moon's going to be and how it's going to appear.
Okay, yeah, but
okay, but you're saying that it's in a refracted position.
No.
No, it's not in a refracted position. So why are we talking about refraction in regards to where the sun and moon appear in the sky? Because it doesn't appear to be in a syzygy.
What you're talking about is the timing of the lunar eclipse itself.
What
I'm talking about is the visibility of the Earth and the sun above the horizon during the syzygy event.
Oh, God.
Anyway, this is really painful to hear this Glober just deny. He's a science denier.
Yeah, so you're claiming... No, stop for a second, relax. So you're claiming optical density as your cause. So which of these three things dominates the optical density difference? Pressure, temperature, or humidity?
Well, I got to tell you, it's been a couple of years since I last took a statistical mechanics course. So the answer to that question is I would have to write out the equations, and then it probably depends on, I don't know, because you might have some dominant terms that in a low temperature regime, the pressure will dominate, and then the high temperature regime, the humidity will dominate. I don't know, right? So yeah, I mean, I think that's as good as that answer as any. But what we can say...
No, what you're actually confusing there is, it's very well accepted and understood within these fields, is that temperature dominates, and you're actually correct there in that the hotter the temperature, the more humidity comes into play. However, what you're not accounting for is the temperature gradient, or hot air, is actually less optically dense than cold air. So that works against you and causes light to refract upwards. Humid air is less dense than dry air, so the humidity gradient also causes light to go upwards. So
we can directly measure the optical density gradient by shining a laser from an airplane.
Say that again?
No. Why is it saying here? The bottom line is obviously the temp. Hold on.
Whoever's speaking, your microphone is really poor. I'm sorry.
No, it's all right. Well, I'm gonna mute you now, so mute you up after that. Look better.
Again, the temperature of the sunrise and the sunset is going to be vastly different, right?
Yes, correct.
Oh, okay. Awesome.
All right, that's it, guys. We can't go to the moon because when we look at the sun or the moon, they're not actually there. They're somewhere else. So they've been wrong this whole time. We're not seeing anything as it is, according to Globers now. You show them one eclipse and existence goes away.
Yeah, for example, here's a study that confirms that upward refraction, negative K, is a standard occurrence during daylight hours rather than an anomaly. And so if we have instances where light is standard refracting up, and then instances where it is not refracting as much up, then we should be able to detect the geometric horizon that all of you claim is being hidden by downward refraction, which you cannot detect apparently, and lack the conditions to do or make it refract that way. Sounds like your excuse just left the building.
Why was I muted?
You were muted?
You weren't. Your mic was blinking on and off, on and off.
No.
Yes.
Hey, don't gaslight
I
me.
was watching
Somebody
it.
server muted me.
On the
Come
live stream.
on. Own up. Who was it?
You weren't server muted. Don't lie. Don't be delusional. Everybody
Here
can
we
see
go
it
with
on
the
the stream.
gaslight.
Listen, he doesn't know what's going on anymore. He just got confused by 3 balls lining up and making shadows upside down in the wrong place. That usually turns people into mush.
Hey, can you blame me? I'm only used to having 2 line up in front of my face. Having 3?
Of
Jesus.
course, because that's how Globers are. That's all they think about.
Yep, just balls all day long.
Yeah, all they care about is balls, thrusting shafts, and black holes. We all know this.
Balls all the way down, my friend.
I guess he doesn't care now. You were muted.
Yeah, so I'm currently drawing out the diagram of the selenium eclipse, and I'm pretty sure I solved your little paradox.
So can we get NASA on the line, because they've been trying to solve it for a long time and they can't solve it?
No, they were having that's not the case. Sorry. All right.
Why is it impossible then?
It's not. I just did it. I'm drawing it out as we speak.
Wow, this is going to be good.
Oh fuck! I have to start over there. I didn't use enough space.
Oh yeah, start over. You got to draw the shadow upside down. Remember?
No, I just need enough space to see everything. Okay. Is it okay if I don't include the sun, so I can just zoom in on the Earth and Moon?
No, you have to include the sun. What
Why?
are you talking about?
I can just draw the Earth in its shadow cone. No.
No. We have to see how the sun works. Remember? That's part of your problem. You can't say, well, that's part of my problem. I'm not going to use that one part of my problem to solve this.
Dude, I just don't have a big enough paper. God, get off my ass. All right, I'll include the sun just for you. Here's the sun. Here comes the sun.
Also, make sure that sun matches what we see from the ground. So when I post the sun with diverging sun rays, you'll say, oh, yeah, I didn't get that part.
Are you talking about corpuscular rays?
Yeah, make sure it's drawn like that so we know how this works.
Corpuscular rays appear to converge because their origin point is much further away than the body.
Oh, so where is their origin point at?
The sky.
Oh, so that's a distance? Do you see how arbitrary you guys are?
Up. A direction, up.
Up. Okay. Oh, now it all makes sense. Earth is a ball.
Hey, how about this? The origin point of the sun's light rays is the sun.
Fine, draw a ball the size of the moon, just like we see it, and us standing on Earth, and make that happen. I'm waiting for the solution so I can smash all my computers and go back to being a glober. Then I'm going to buy a curved screen TV. I had one, but I got rid of it because the earth is flat. So now I don't have that. The curved screen is in the basement up against the wall. I'm just going to get curved screens again if you can prove that we live on a ball, but with this drawing.
Observer orientation.
You just draw like a half a ball. You put a person on top.
Hey,
you put
you told me
a
to
sun
include
in
the
one
sun.
sky in one part,
You told me
a
to include
moon
the
in the
sun
sky in the
relative.
other part. You shine the sun down on the earth, and you shine the shadow up to the moon, upside down, and then you tell us how that works.
Shadow orientation and sightline. And then I'm going to throw in a little geometric horizon just for you, bud. Geometric.
So you're saying that there's a distance to that horizon?
You're not gonna sidetrack me. All right, I'm gonna take a picture, and then I guess I'll have to like DM somebody the picture for them to post in the chat.
This is the sound of 3 greyhounds staring at me. It's very scary when they do that.
You have greyhounds, says?
If one of them moves, they'll all move, and then they'll rest for about 2 more hours. That's their life.
Okay, so Triangle, I'm gonna have to like DM you the photo so you can post it in chat.
Somebody else.
Okay, okay, somebody volunteer. I did all the hard work, guys.
Grace said send it to him.
Grace, okay.
Where's the dark one's bed?
Actually, the tan one is in the dark one's bed, and the tan one doesn't like beds normally. The tan one normally sits on the couch where you see that paw prints. He guards the front door. The other ones don't care about the front door.
Oh, cool. Is he the youngest or the oldest one that guards?
He is the youngest. That's the tan one. That's Jimmy. Is the tan one. The lighter brindle is Seymour. And the darker one with his head by my legs with the eyes staring at me, it's Boogie. Boogie was a winning race dog. Seymour was a winning race dog. And Jimmy wouldn't chase anything. And at 1 year old, they got rid of him. And that's how we got him as a puppy, basically.
Are they kind of high strung? Like do they have like, I heard that their hearts beat a lot quicker than normal dogs.
Let's see, high strung. They're high strung if I get them wound up. Otherwise, that picture I sent, that's as high strung as greyhounds get.
Yeah, I've always been interested in greyhounds. I've always had German shepherds. I've probably owned about 20 of them in my life, but I've never. It's one I've always wanted to look into.
Greyhounds, you kind of have to have a group of them. It's easier for the dogs, and they get along easier if they're other greyhounds. I don't know why, they just do. It's not like a normal where you can put a mastiff with a poodle and they don't really give a shit. These dogs do care.
All right, so Drace posted the illustration. So as we all know, in the globe model, the direction of gravity is determined by your position on the surface, and it always points towards the center, and therefore your orientation or your direction of down also changes with the position on the surface. So if we basically, as long as our direction of down lines up with the direction that the lighted portion is, then it makes perfect sense to see that site that the photo took.
What is the direction of my cock facing? Tell me right now.
Did that guy join in just to say that? Very nice.
Yeah, he left. Well, that's most Globers. That's what they think about. That's all they think about all day long.
Yeah, you already repeated that joke, and it was funnier the first time.
It's not a joke. If you're in here long enough, you'll see that it's all the time. That's all they think about.
All right, please respond to my diagram.
There you go. You got an X. You've got an F.
Okay, explain what's wrong about it.
Do it in 3D modeling and let's see that work. Do it in SolidWorks. That way we know that it'll be accurate.
I'm poor.
You can get a free version.
Why don't? I'm sorry. Okay, explain to me what about this 2D diagram will not translate to 3D?
You need to make that shadow go upside down for me standing on top of that ball, because that's where I'm standing, on top of the ball, because I see the sun to my left and the moon to my right, and I'm standing on top of the ball. I look one way, there's the sun. I stand on top of the ball, I look the other way, there's the moon, because they're both the same size, remember?
In this diagram, you can see both the sun and the moon at the same time.
And where are you standing? On top, right?
Oh, you see where that arrow where it says observer orientation? Where that arrow meets the surface, that's where you're standing.
So I'm standing on top. Okay.
Well, not perfectly on top, but yeah.
How do you? Well, how would you know? So if you stand on top, is it different looking?
What I'm saying is, if you draw a line from your feet to the center of the Earth and then to the center of the sun, that line will not make a 90-degree angle. That's what I mean by on top.
Okay, great. Anyway, yeah. So you don't have a center, but I'll pretend you do. Okay, now I see. You don't have a center because you don't have a curve to measure.
Okay,
so we'll pretend you do.
I know this is. I'm saying within the globe model, this is how the globe model explains the view of the selenial. Okay.
How come on your drawing the sun and the moon are down below by Australia?
What do you mean by that?
On the bottom part of Earth, not on the top. Move them both up about on your paper. Move the sun up 2 inches and move the moon up 3 inches, and then make sure all your shadows line up, and then you'll be on top. Or move your whole Earth down where you say Earth. Put the center of that Earth that you have where the A is in the word Earth, and then you'll see if that lines up. What? You can't change your lining up to make it fit. You have to draw what you see when you're standing there in real life. So you draw yourself on top of the ball. You draw a moon up in the sky. You draw a sun up in the sky. You make a shadow appear upside down on the moon. Go. That's what's wrong. You totally wrong, dude. I was a glober. You're not even drawing it right.
No, listen. So, first of all, the moon doesn't orbit exactly coplanar with the Earth and sun, right? So if you
you lost me at orbit anyway, besides that.
Okay, so here's the thing, right? Here's the thing. If you guys ask me, hey, how does your globe model account for the view of the solar, right? And then if I use the globe model to draw a diagram, and then you say, oh, that diagram is incorrect because the Earth is round in that diagram. Like, do you see the problem with that?
No, you have it in the wrong location.
You need to
not on a scale.
Create a triangle. The sun, moon, and Earth are not lined up. You need to make a triangle between the sun, moon, and the Earth.
Ball. Move the ball down where you have the word Earth, and put the ball right. Put the ball circle around the word Earth, and that'll be close enough for me.
The sun was not. The shadow was not completely covering the moon in the picture. Drace, can you repost
okay.
the
Only 90.
picture?
Okay, only 90% of it was being covered. You're right. Only 90%. So make sure you do it with 90% being covered, not half.
Okay, but dude, you're just being pedantic. Look,
No, I'm not. You're trying to get away with drawing shit where it's not, where we don't see it.
All 100% was covered by the end. Okay. Oh my God. You guys are not actually responding to the diagram. Okay. So based on the diagram,
I did respond to it. I asked you if you're on top of it. Okay, in your diagram, you should have you should draw a little half ball on the bottom and put a little guy on top of it on the bottom of your paper. Then up from that about 20 degrees to the right, draw a moon, and then up about 20 degrees to your left, draw a sun. And then you're on top of the Earth that's on the bottom of the paper, just the top curve we're going to look at, and you're standing on top. You need to draw sun rays hitting down on the Earth, bouncing up to the moon, flipping over, and making a shadow upside down on the moon.
All right, so if we define the shadowed side of the moon to be up, okay? And then we draw a vector. That's what that line is, that arrow is. It's an arrow pointing towards the direction up, right? You can see that our direction of up matches the direction of up on the moon if you're standing at this point on the surface of the Earth.
Yeah, but I can tell you what's wrong with that diagram. You've got sunlight illuminated moon surface inside the umbra or penumbra.
The penumbra. Okay. So
yeah, your shadow that you've got there is encompassing the umbra and the penumbra, right? Yeah, because you haven't detailed where they separate, but
I think it would be
but it's completely in that diagram. Your moon is completely within the shadow of the Earth, completely.
At the end, but all that means is that when the first picture was taken, it was entering the shadow, and then when the final picture was taken, it was fully in the shadow. And at the same time, the Earth is rotating.
To that observer, the shaded part will still not be on the top. It will be on the bottom.
It will be on to the observer that I drew, where they're standing.
It'll be on the bottom. It'll be on the bottom because you lift that up to outside the shadow, so it's fully illuminated by the sun, and then bring it back down, so it's starting to enter the shadow. It's going to appear to enter bottom up to that observer. It'd have to go all the way down to the other side, so that your sun where it is, right, is still casting that shadow.
So the sun, so the position of the Earth and the sun, that's what determines the position of the shadow cone, and that's established already, right? And then we have the moon moving independently to those two, and it's moving from outside of the shadow cone into the shadow cone. And we can see that from the diagram, half of the moon is covered, right? And if we define
for that observer to see that, it would have to be on the underside of that shadow on your page, not the top side.
That's not accurate. That's not accurate, because if you were to take that,
that's your shadow. That's going to determine which side the shadow appears on the moon for that observer. If you move that up, it's going to be the bottom. But if you move it down, it'll be on the top.
So I guess I have to draw a little man standing right here. So if this man is standing where I drew the arrow coming out of the surface of the planet, no, that's just incorrect. Old dude is saying that so old dude, that orientation.
Old dude drew it exactly the way I described it, and I want you to make it work on old dude's drawing. He drew it exactly the way I described you to draw it out, the way we see it from standing on Earth.
Incorrect.
Prove it.
So we do see that in this diagram, dude. Look, this guy has sight lines to the sun, and he has sight lines to the moon. And during a solstice, both of them are visible above the horizon due to refraction, which you guys love to invoke, except I guess when it works against you.
Are you invoking that it's refracted, that it's not really there, we're seeing something else? Say yes.
Fix your diagram.
Image that reaches your eyes is refracted as it passes.
So it's not really there. We don't actually know where the moon and the sun are at, right? When we're looking at them in reality.
I drew his imaginary giant guy. Thank you, Trace. And where his horizon would be actually when
he ignored me. He just completely ignored me.
Dude, so look at what Trace. Look, Trace is just proving my point right now. He's trying to refract it without the mechanic to refract it. Who is I said the mechanic is the gradient in optical density in the air due to
Where's it flipping over? Where's it flipping over at in the air? What part flips it over? Is it by the moon or is it by your eyes?
You are making an arbitrary demand that the light flip over, and when I can't
No, we
produce
see it's flipped over. We see it's flipped over. We see the sun to our left and then we see the moon to our right and go, huh, if we're standing on the shadow part of it, why is the shadow upside down on the moon? Huh, I don't know. I'm gonna go back. I'm gonna go back to watching NASA videos.
What do you mean by standing on the shadow part of it? The shadow part of what?
Okay, can the 9th or 10th person in line explain to him what a shadow is?
No, what are you saying? Like, what is the issue? You're not making any sense. If you look at that man right there, if he looks to his left, he sees the sun. If he looks to the right, he sees the moon. Now, this is an exaggerated scale, of course.
How come he's not looking up and you got him looking down around Australia for it from Alaska?
Hey, in that picture that you sent, he's looking at the horizon. My guy is looking at the horizon.
So your horizon is a geometric measurement?
In the globe model, it is. Yes, that's
okay. Beautiful. So how come every time we present stuff to you, you don't have a reason for why we can see too far?
Refraction, dude.
So now it's everything's refraction. Everything is everything is refraction and gravity. No. Do you believe that? Do you believe that everything is refraction and gravity?
He's claiming it's refraction. What's the K factor you used?
Oh, here we go. Oh, you're claiming that this scientific mechanism. Tell me this hyper specific detail about it, or otherwise your whole argument is invalid. I don't even know what.
Yeah, you don't understand your actual claim. You're claiming optical density gradient is causing the refraction. You don't understand the required K would be very positive. But I just showed you a study that the average is negative because you're inverting the optical gradient because you're assuming that pressure gradient means optical gradient. Density gradient does not equate to optical density gradient. Those are two separate things.
Is the optical density of a gas affected by its pressure? Yes or no?
Yes, but it's less than temperature and humidity.
Okay. Do we detect decreasing pressure as we go up to higher altitudes? or elevation.
Yes, and we detect less humidity and temperature.
Okay, yes. And like I said, it's been a few years since I took statistical mechanics, but is that change in environment not, does that not correlate with a decreasing optical density? That change in all three of those parameters, do they correlate to a decreasing optical density?
Yes. When you get
Okay, so
really
then,
high up, it
yeah,
starts decreasing in optical density, but when you get closer to the ground where we live,
yes.
it doesn't. It's actually inverted to that schematic because
Wait,
temperature and humidity
what are you saying?
actually do not bend the light down like you want.
No,
They
what
actually
is
cause the
inverted?
light
What
to
is
go
inverted?
upwards. And so you have competing mechanics and you're not accounting for them.
So what is inverted? Because you said that the optical density.
I already told you this earlier. Dry air is more optically dense than humid air. Hot air is less optically dense than cold air.
So 99%, in the globe model, 99% of the atmosphere's mass is under 100 kilometers.
Yeah, and that also, because of the low optical density effects of the higher atmosphere, it has almost no effect. And so you're appealing to something that has no effect. And so you can't actually validate your imaginations, and the Earth is measured flat because we can show that with the refractive effects on the ground.
If you're saying that a pressure gradient in the atmospheric column with a change in elevation is my imagination.
No, that's not. Now you're strawmanning my position because you cannot address it.
What are you saying that is my imagination? The decrease in optical density from the ground?
What I'm saying is your imagination is that the optical density gradient is causing the light to bend in a curve over the horizon or around your ball to allow you to be able to see it. That requires very specific conditions, and those conditions don't exist in reality. Simple.
The conditions exist, and the condition is that you have a higher optical density near the surface than you do higher out into space. That is the condition.
Yeah, bro, when you have the difference between zero, like air, for instance, is not very refractive. I don't know if you know this, but there's not much difference in refraction of air. It's 1.003, and the variation is within those decimals. When it comes to very, very low pressures, it's very close to just 1. You don't see any difference in the refraction when it's not having any effect.
I don't see it because I'm a macroscopic human, but I'm sure a photon of light will know the difference. And even
now he's talking about photons and how big humans are to something he can't prove that it's the size of.
No. Okay, so he himself admitted that here at surface level, the difference is 0.003, right? But it's not like it jumped from no difference in space to having that difference. There is a change that happens.
No,
the change
bro,
is small.
Zero refraction is 1. Do you understand that?
Yeah, I do. And even if it's
so, how are you bending it around your globe?
Because even small deviations from a straight line path add up over thousands of miles.
Yeah, that's your visual thinking.
My visual thinking?
Wishful thinking.
It's geometry.
No, it's your
not
wishful
geometry.
thinking.
Mr. Geometry, go ahead and draw that out for me.
He's begging the question. He's begging the question because he wants the globe to be so true that if the globe is like this, then it would bend maybe a tiny bit down, but it would then start counteracting as soon as it starts hitting the temperature gradient inversion, and because as you can see with how they if you look at I'll find the graph.
Well, how come everybody
It's the
sees that?
temperature.
How come everybody that can see it sees the same thing? It's that obviously it's not the temperature, or it's the temperature of the moon causing it. Is it the moon temperature? Because it's not the same temperature where everybody stands.
What do you mean by everybody who can see it? Everyone who can see what? The specific
that eclipse. Yeah, that eclipse. Just not only that guy only sees it.
So the specific thing that they see is, number one, they see the moon on their left above the horizon and the sun on their right above the horizon. And the second thing that they see is, number two, relative to like from their perspective, the top side of the moon is in shadow and the bottom side of the moon is lit.
Okay, the moon is going down, moon is going down, sun is coming up, and the shadow's getting bigger. Go ahead and animate that for us. I'll be so happy when you do it. I'm gonna dress up like a furry and run around.
So now I have to download an animation program?
No, they wouldn't see it. They wouldn't see it. They wouldn't see it. It's geometrically impossible.
It's not
he doesn't know that. He's claiming it's geometrically possible, T-Dub.
No, not for the reasons that everyone's thinking. It's impossible, right? Because the way I understand the concept, right? And at first I misunderstood your diagram. Now I see it and I understand it, right? Yeah, that is impossible. That moon position would be way below that observer's horizon. Right, that scaling is a is allowing for.
So I was right. It would be over your house, right, T-Dub? I was right. He drew it over Australia.
Way.
Yeah, he drew it over Australia, standing in Alaska. That's what he drew.
Exactly.
Okay, saying that
no amount of refraction that can lift it up into your field of view from that position. No way. That's not that would be impossible even by astronomers' standards.
I mean, it would be equal to me saying the celestial sphere looks like a sphere because of refraction.
Celestial sphere. Well, look, I can draw I can use a black pen and then a blue pen, and then draw a diagram where the initial positions are in blue and then the final positions are in black, showing the Earth rotating towards the sun while the moon moves into the shadow.
No, listen, bro. Your apparent sun and moon positions are above your tangent plane, not below it. You have to do it so that they appear to be above your tangent plane. Both of them.
That's what I was trying to explain to him. Old dude's drawing is correct. Draw a line on top of old dude's Earth straight across, and that's your plane that you can see.
Drace, I sent you an image link if you could post it in the chat, please.
He will ignore that. He won't use old dude's drawing.
What? You don't even know what the drawing is.
He's actually posting something we posted earlier. Yeah. But instead of the original, yeah, I'm doing it. Right. We posted a legitimate link. He's posting a flat Earth salad, anti-flat earther link.
That's classic. So right there means we can't go to the moon. Thank you.
Nope.
Because you don't know when you're seeing it. You just never know. Everything in the sky, everything in the sky isn't there anymore. You guys are just in a panic mode now.
Triangle, you're in a catch-22. Either it's impossible to see it, or we can't go to the moon. Pick one.
Oh, it's what you're seeing is not a 3D balls in space flying around. So you don't get any choices. You live on a flat Earth, not a curved Earth. You started with a curved Earth in your picture. Now you have to make that flat and then make that work and make no ball standing on no ball and then make that eclipse happen. and then you'll have debunked me.
I love how they have to make like a giant standing outside of the air and then just magically bend the balls to his face. It's insane.
Okay, so look at the arrows, right? You see those arrows kind of curving off? That's not saying that that's where the image is. That's saying that's where the light rays are coming from. You can see they're bending down. If you
I
extend
know.
that, if you extend that to its true position,
I
then
know. I was
that
not
is compatible
bro,
with the
stop
diagram I drew.
misrepresenting our position with your idiocracy.
You guys have been misrepresenting
okay?
me and everyone
We're
else.
not saying that the arrow is like the arrow is where you think it's being bent from. Okay, that's your imaginary refraction that you have no evidence for. Okay. That's just your claim, okay?
Oh, so refraction is imaginary? You guys were invoking it all the time.
Did I say that? No. I can explain Fermat's principle. I can go over Snell's law for you. I know what refraction is.
I already passed those classes.
I know what refraction is. You create here an out-of-scale image with a giant and bending rays that you have no evidence for.
Okay, so you're telling me
and not only
I
that,
can draw a 2-scale image,
and not only that, it's begging the question of the globe in the first place.
Okay, demonstrating how the globe model explains a phenomenon is not begging the question.
When you're here trying to prove your globe is real, and we have shown you evidence that it lacks curvature, which is requirement for it being a globe, then you trying to use the globe as proof that as evidence that this refraction is possible, which, by the way, it isn't, but you just believe it's possible because of globe, okay? And refraction, your globe refraction, that doesn't change the fact that the Earth is still measured flat. And so the Selenian eclipse doesn't work unless you start imagining stuff. Like light is refracting without actually accounting for the optical density of the medium it's going through, but rather just imagining it would be bending to match the observation. That's an ad hoc rescue.
But it's not imagining if we can actually calculate what that light curvature would be based on the atmospheric conditions, which we can measure and calculate what the optical density gradient would be. So it's not imagining and it's not guessing. We are
do that.
Calculating.
Show me those calculations so that I can go over them, because I've never seen any glober do anything of the sort. Anytime we try to account for the actual optical gradient, none of these ideas work, okay?
I was talking about the horizon dip angle measurements yesterday, and Al-Biruni, who did that, and there's literally a corrected version of Al-Biruni's formula that takes into account the what I just talked about, the atmospheric parameter.
Yeah, no, that's also an ad hoc rescue. That's not. You don't understand how these things work. And so you read the headline, you read the summary, and because it's affirming your beliefs, you just auto accept it.
So I see you have to resort to ad hominem character assassination. Thank you.
No, that's just no. You're claiming something. You haven't provided any evidence of this. All of your claims so far have fallen flat, and you have no evidence.
So first of all, the production of the diagram was not intended. It wasn't provided as a proof of the globe. The whole reason it came about was because somebody said, "Hey, this perspective, this picture would not be possible to take on a globe Earth, and the existence of this picture disproved the globe Earth." Now, the fact that I can draw
and it was impossible. You showed impossible ray paths.
They're not impossible. No, it's just the scale is off because
prove they're possible.
See you.
Okay, well, let me finish my statement. All right. So what I was saying is,
so you're not going to prove they're possible, then, okay?
let me finish my statement, okay? So the whole point of this diagram wasn't to prove that globe Earth is correct. It's to demonstrate that the existence of that photo does not disprove globe Earth, and that the globe Earth model is consistent with the photo that was sent.
No, in order to do that, you would be able to demonstrate your proof of those bending ray paths. Can you do that?
What would you accept as proof? Atmospheric measurements?
Well, atmospheric measurements are data points. How do you map those measurements into your proof?
What temperature does the sky have to be then? And how high does that work at? I would like to see inverted airplanes, like planes that are flying, but then when I look at them, they look like they're actually just going backwards because it's like hot and they just inverted.
That's funny. Like upside down passenger airplanes over our head due to refraction.
Well, they would just be flying backwards. The tail would be going first because of refraction. It's actually flying normally for the people, but we're seeing it backwards because it got flipped around. It's the only way you can make upside down shadows is you have to flip the image upside down or reverse it.
Yeah, just like when we're seeing way too far beyond the so-called geometric curve, and they claim the rays are all bending to us, making the Earth look flat. Things at a distance, you would actually be seeing the rays from the top of the thing, not from the side. So everything would start to tilt. We don't see that.
Wait, are you saying that under the globe Earth model, with an atmospheric column of decreasing optical density as you go up,
That's not uniform, bro. Bro, you're assuming it's uniform that way. It's not.
Question. You're answering a question.
Yeah, you know,
I didn't even finish.
your premise is flawed.
You don't even
okay?
know what I'm going to ask.
No,
yes, dude,
your starting premise
wrong.
is flawed.
You said
there's not a uniform pressure gradient.
You said column on a globe, and you started off wrong. So rephrase everything for us.
There's not a uniform optical density gradient going from more dense to less dense up. That's just not how the air works, okay? The air is inhomogeneous and isotropic, which means it's not uniform. Okay?
Let me ask my question. I don't even know. You don't even know what I was going to say.
Can you acknowledge that the air is not uniform? Can you stop treating it as homogeneous and isotropic?
When the fuck did I even say that? You're putting words in my mouth, dude. Who said that you should be able to see
You said the optical
tops
gradient
of
was.
objects?
You said we have to agree that the optical gradient is going from less dense to more dense, right?
Who said the whole point of that was a setup to a question? Just let me ask the question.
Yeah, that was the setup to the question, which was no. I don't agree to that. Why would I agree to that? That's violating basic principles of how the air works.
Who said that you should be able to see the tops of distant objects?
The globers, they tell me the light is bending and curving around the globe to make it appear flat.
And then what you said is that a logical extension of that would be that you can see the tops of distant objects, and the fact that you don't see those tops proves that yada yada yada, right? That
no,
your position?
I didn't say proves. I said we didn't see that. I've never seen the angle to something change so that I can see on top of it due to light refraction. Have you?
Okay, so what I would respond to that would be that refraction is extremely angle dependent.
I know.
And therefore, if you
and
imagine the light rays,
is that conducive with your moon? No.
If you imagine the light rays coming out of the top of a object, they won't be going obliquely enough through the atmosphere to be refracted effectively to eventually reach your eye. But they are being refracted, but they just end up not on a trajectory that reaches your eye because their angle was too steep. That's it.
No, I'm not saying directly on top. I'm not saying like, oh, you're so retarded, bro.
Well, I mean, you can demonstrate this yourself. If you put a laser pointer inside, like underneath the surface of water, and then you rotate the laser pointer, when it's vertical, all the light goes straight through. And then there will be a critical angle
I
when all the
know,
light is
bro.
reflected internally.
Bro, you're not teaching anyone anything here.
Well, I might be teaching
What you're talking about is basic Snell's law and the fact that if I'm looking through two mediums and there's no angle to the surface, then of course there's not going to be any refraction. There's no the angle of incidence is 0, so there's no angle of refraction. Okay?
Wait. Angle of incidence is 0, so there's no angle of refraction.
Yes, basic Snell's law.
Okay, and that you are referring in that case to what? Light rays that are moving parallel to the surface?
No, that's when light is moving from one medium to another.
Yeah, and so when you're normal to the interface,
which is the description of what 0. You were talking about earlier.
Exactly. Yeah. So then.
Yeah. So what's so confusing here? You don't have the angle conducive to allow your moon to be refracted around the globe to allow you to see it.
Oh,
you just admitted
that's
that.
What we're talking
okay,
about.
That's fine.
Yeah, we are. Yeah, you do. Even in the diagram. Yeah, it's fine. Yeah.
No, it doesn't work. You just admitted that. You can't see the tops of the heads of the people, right?
If you draw the light rays coming from the moon towards the Earth, they enter the atmosphere at an oblique angle that is conducive to refraction.
Where is it entering at an oblique angle and giving you all this? And through that optical density gradient, which is variant with height, and so once you hit the temperature near the surface, which rises as you go down, and the humidity gradient, which rises as you go down, oops, your optical gradient just got inverted. And so you cannot curve it down around the globe anymore. Oops.
We can talk about the contributing parameters all day long, but at the end of the day, they're all going to add up to give you
No, you're just ignoring
reality,
the contributing parameters because of wishful thinking.
What I'm saying is we don't need to know those specific parameters. We can directly measure the optical density of the atmosphere.
Now you're just admitting that you don't know the specific parameters, and you're just admitting to wishful thinking. Okay, buddy?
We can directly measure the optical density using LiDAR.
Yes, we can directly measure the optical density, and we find that the optical density is not conducive to bend the light around the ball to make it appear flat, and so we measure it flat.
When we do measure the optical density of the atmosphere, we find that it decreases as height increases. That's it. That is the condition.
That is dependent on the conditions. Yeah.
Yes, but the thing is, regardless of like temperature fluctuations and local humidity, whatever like that, a major contributing factor is just going to be the amount of air that there is. And under the carbon
it's not. It does not override. You're misunderstanding and not comprehending how refraction works. Does not actually validate your imaginations.
Stop
with
the character and ad hominem,
no.
Dude.
Stop lying to the audience. Just Google it, bro. This isn't hard to understand. You don't need to be here trying to argue with me about basic science. You don't need to argue with basic science. Just go learn about this, come back and talk to us.
So
it's not difficult.
So your position is the optical density gradient exists, refraction exists. It's theoretically possible for refraction to account for the things that we see, except it doesn't. Why doesn't it? Because it's impossible.
No.
Okay, then clarify.
No. My position is your globe has been completely falsified.
That's
Any attempt to try to reify it into existence by assuming refraction despite the actual optical gradient and the conditions, like for instance, we have upward refraction or negative K near the surface where we live, where you look at the moon from.
Well, you see, my position is that you have been completely proven wrong. That's not an argument.
Yeah, that's just saying nah.
Exactly. That's exactly what you just said, dude. You just say.
No, I didn't say
like,
that.
Basically, you're saying.
That's what
okay.
you just said. And now you're saying no, you. This is so childish. If somebody else wants to talk to him, they can. I'm not going to engage that.
He was so sure of himself too that he had it. He'd solved the mystery, like Scooby Doo. Oh my! Is that how we were singing songs? They're all three going to start doing that, and they'll start howling in a second. You guys look bored.
killed the chat. Did the chat die? No, it's in cryo sleep, waiting to get to Alpha Centauri Prime to start our new life, terraforming a distant land in space. Where do I sign up? The fiction section at the library. I've been getting a lot of videos in my feed about Einstein gravity getting debunked by some chick, some physics chick with some like quantum gravity, something or other. It's crazy how they can just like, they could have like the truth and then all of a sudden it's not the truth anymore. It's kind of weird.
Hey, am I interrupting? Is anybody here?
You came at the perfect time.
Oh, I'm not interrupting, right?
Nope.
Okay, sweet. So you're a flat earther?
Potentially.
Okay. Do you realize there was an experiment done where the flat earthers, I don't remember exactly what happened, but they set up like a camera, like they set something up to where they went a far distance, and it said if the Earth is flat, it should be straight, right? There shouldn't be curvature, and it turns out there was a curvature. It was if you held the camera up here and then you went down, what should be considered down, right, on the globe, and you hold the camera in the same spot, it should be the exact same, and it wasn't. So
Well, you're missing a lot of details.
do you at least know what I'm talking about?
No, I'm not aware of that experiment.
So what happened was two guys, they set this thing up. So I'm pretty sure what happened was they put a camera up on one end, right? So they put it up. They put it like, let's say for example, they put it 15 feet in the air, right? Nothing crazy. Then they went a long distance, straight vertically from the camera, and or horizontally, I guess, like right, and put another camera
Hold
up,
on a
the
sec.
exact 15 feet up,
You're
right?
talking about Behind the Curve, correct? The Netflix documentary.
I think so.
Is that the one you seen it on Netflix?
I did not. I saw it on a different platform, but it probably came from Netflix. Could have.
Was the guy's name Jaron?
I have no idea what the guy's name was. I forgot a lot of it.
Okay, I think that's the one you're trying to
If you're
describe.
talking about Jaron Campanella, yeah, he's not a flat earther. He's a true earther.
But like basically what I'm saying is, they disprove themselves because like on one, right, there was a huge mile distance, but on one end the camera was higher than the other, and the same feet, right? So both had 15 feet. So, yikes.
Yeah, that whole experiment wasn't even an experiment. What they did is they were supposed to do a laser test, and they melted the laser, so they tried to shine a flashlight through some cardboard holes. And if the Earth was a globe, he would have to be like 19 feet tall to see the light. So it didn't debunk any flat Earth, and it didn't debunk any globe Earth. It was a null. Both sides said it was retarded, and they didn't want to do it. So
yeah, and not a very good idea in the first place to do it. So.
Wait, so you guys actually think the Earth is flat?
And
we know it's flat.
So you think like the Earth is just like flat, and like if you went to reach the edge, you just fall off?
No.
The edge. What edge?
The Earth can't be flat if there's no edge.
So a table that's my kitchen table, because it has an edge, is the only reason it's flat.
If something's flat, right? Then the only other way would be the Earth just expands infinitely, or the ice wall. But with the ice wall theory, it's completely invalid because you can fly from Japan to South Korea without going through an ice wall, like the long way, like going around America, around Europe.
You're floundering a little bit. You're going around all these different ideas you think we have. So let me ask you this: if the ground lacks the curvature required to be a sphere of the size they tell us, is it that size?
Yeah. Well, no. Hold on. What do you mean?
Yes and no.
Yeah, I'm asking you just a basic hypothetical. See if you can think.
Yeah, I'm very confused by the question.
We can ask it a different way. If we measure the ground to be flat over a distance that is greater than would be required to show curvature on the sphere you're claimed to live on, if it's measured flat, then it's not a ball, right?
Okay, but it's not, right?
I'm just asking you a hypothetical.
In a hypothetical, if the government said it was not, it was ball, and they measured it.
No, it's not about who
and
said
they,
something. It's not. No, you're missing the hypothetical. It's not about who said something. It's just about if the Earth measures flat, then it is, right?
Yeah.
Oh, perfect. I just wanted to see if you could accept that. Most globers can't. I'm kind of busy. If somebody else wants to walk him through it.
Well, the first thing is no one has gone beyond Antarctica, and the reason why they haven't gone beyond there, because the temperatures are fatal, like instantly fatal. So if someone has even attempted, they're dead. We don't make machinery that can run at minus 100 degrees or whatever.
That's not true. Look at the moon rover and all that equipment, and Mars rover, and the spacesuits. So you should be able to wear a spacesuit in Antarctica.
Come on, the spacesuits don't even protect against radiation.
It depends on what kind you have. If you have the ones that look like motorcycle outfits, those don't do radiation. If you have the gigantic bubble head ones, those do.
You guys forget about the kid?
I think he's gone.
Maybe he went searching for the edge.
I don't think he was expecting real flat earthers tonight.
Yeah, I'm going to bed. I didn't have time to go over the things. I'm actually logging off right now. I'll see you guys tomorrow.
See you, Trace.
Where's Donald? You not back yet? Damn it.
No, fortunately.
Yeah, I really wanted to highlight his circular reasoning earlier, but it was too chaotic. I mean, essentially, it boils down to this, right? Mass of Earth because rate of fall because mass of Earth. And there's pretty much, is it Digbert? Digbert, you know the cartoon Digbert, the comic strip? I'm pretty
Dilbert?
sure it's Dilbert, that's it. Yeah, I've got one of their strips that pretty much says that. I'll see if I can find it.
So somebody posted online about how little money NASA budgets are given to combat flat earthism. And if you take the total NASA's budget since 1958, adjusted for inflation, it now reaches $2 million. If you had $2 million today, you could only build 5 million homes with that money. What's more valuable to mankind, 5 million homes or fancy space pictures?
Fancy space pictures, of course. Yeah, but there's the comic strip. I don't know which one's which, but the guy's saying to the dog, and we know mass creates gravity because dense planets have more gravity. And the dog says, how do we know which planets are more dense? He says, they have more gravity. The dog says, that's circular reasoning. And the man says, I prefer to think of it as having no loose ends.
Yeah, see, mass attracts mass, except when it comes to the asteroid belt.
Oh, Neil's here to save us if you just undeafen.
What up?
Hey, you got some TikTok excitement for us or what? I understand if you've got a life and that, but
Oh, I missed that. Sorry. What was that?
I said, have you got some TikTok excitement for us? I said, I understand if you've got a life and all that, but
I've got actually a really good one right now. Me and Lats are on TikTok. Should I put him on?
Oh, sweet. Yeah. Hook us up.
Okay. Let me intro. Give me a minute to do it. And this guy's actually they're like really cordial and like they're not retards. So it's been really good. I've been priming it.
But so you're the medium, but AI Overlord is the receiver.
Too good.
I'm busy.
Okay. We'll see.
All right, here you go. Take it away. You guys introduce yourselves and go for it.
Guys, I go by 8 inches per mile square on TikTok. You could call me Mike. My main channel is Mike Snow, but this is my flat Earth channel. And kind of dedicated to my flat Earth friends here. We go out and we actually take measurements and we get visuals with our P1000. He had a P900 that's got an infrared mod. We just go out and we test flat Earth claims. We're getting different results, right? But we like to engage with flat Earthers and just hang out, right? So here we are.
Oh, awesome, man.
Can you specify what you mean by different results, just in case anyone's confused?
Well, we're hitting globe results, right? With our measurements, with some of these areas that we're. Yeah, sure, the horizon does look flat, right? I will totally be the first to admit that. But we could start taking measurements, and I could show that the horizon dip angle is easily measurable and predictable, right? Based on globe. So yeah, you know, that's what makes it fun, right? Things look flat from a lower elevation, but you know, when you start zooming in on stuff, you see for yourself that, you know, boats are obstructed, building.
Uh-oh. I lost them.
What's he using to?
Right.
So, I'm back.
What's he using to measure with?
Okay, they're asking a question. Oh shit.
A little too intoxicated. I don't think I can responsibly run a live.
Yes, you're good. I got kicked out. I was probably going to start with that pretty soon, but
Oh, really? Damn. Never mind.
If you hop out of here and start.
I was just curious what he's measuring with. He's saying he's getting a dip angle and stuff. So is he using a theodolite? What distance is he using this theodolite at? I mean, I think for just a general theodolite, it's what 300 to 600 yards is the max you can go with them.
All right, we're back. So they're asking for the measurement. Like, what did you use to measure? Could you repeat yourself? Sorry, I just disconnected.
Yeah, we used a wild T2 theodolite. Let's see if he's got that.
I do think if you can't find it on TikTok, MC2, and I'm pretty sure has all of the data, including pictures of his notebook.
Oh my goodness. Okay. Yeah. So we're the 24/7 Flat Earth Discord crew. It's pretty quiet here at the moment, but there's a couple of people around that might want to engage. My name's T-Dub. We got Johnny Law with some questions regarding your measurements and your equipment. Yeah, I'm curious as to exactly what sort of like distances and things you've got, not besides angles, like whether you had some distance demarcation points for which to gauge distance to the horizon, etc.
You know, to be honest, I typically use Google Earth to figure out my distances. There's a mountain that's near me called Mount Diablo. It's approximately 30 miles away. I've driven to the top of it. You know, Google Earth, the distances are pretty accurate from my experience. So I feel pretty comfortable using that as an indication of how far I am from my targets. Now, when it comes to the horizon, we could calculate that. That's typically how I go about doing my horizon dip angles. Yeah, and then with like the targets, I use mountains. I use because I feel pretty confident that we do know the heights of mountains and that they're fairly accurate. Buildings, we can typically find the heights of buildings. And if you're really good at using your equipment, you could just measure the angle and use the distance and figure it out that way, right? But I haven't done it that way yet. But most of the buildings that I'm measuring, which not that many, we pretty much know the heights of them, right? So, yeah, I hope that didn't confuse you, because
no, that's all right. Just with your angles, your dip angles, is that to the horizon or is that to like the top of a mountain, or what are we talking?
Well, so I measured a dip angle to Sears Tower from the Warren Dunes. So Sears Tower is in Chicago. It's also known as the Willis Tower, and I did measure an angle looking down on that tower that was a lot higher than me, right? I've got a little picture that I drew, and then I could show you video and measurements of that one, right? So I was approximately 188 feet on the Warren Dunes above Lake Michigan, and Willis Tower is approximately 1,729 feet, and it sits approximately 15 feet above the lake.
on the foundation. So you know, it's a lot taller than where I was, but I measured an angle looking down. I was looking down to the top of that tower, right?
So wait, the tower's 127 feet, did you say? And 15 feet above the lake surface.
I was 188 feet above the lake, give or take.
Right.
You know, several feet.
Right.
And
188 feet. Yep. What about then the tower's height?
It's 2,000 feet high, right above the lake.
It's 2,000 feet high above the lake.
So I made some.
Did you say 2,000 feet high?
It's about 1,729 feet. I think when you look it up, right? I think it's 1,450. The Sears Tower, you said? Well, that's the top rung of the tower is about 1,450, but what the end fair enough. It's 1,729, but I measured to that, and I think I got the measurement to the top of that too, but it was kind of hard to see from 53 miles away. I didn't have the best. You see it from 53 miles? I didn't have the best day, but it wasn't the worst day. Right? I was so happy that I was able to see it because, you know, so many times you go out there, you do the thing, and then it's gets skunked, right? Mother Nature has its way with you, right, and has a different idea of your idea. So, yeah, I could share.
Right. And you said you got a negative angle. Sorry, go on, John.
Yeah, I got an angle looking down, right? Instead of looking up, as you would expect if the Earth is flat, right? I measured an angle looking down.
Yeah, we understand. We understand what you're saying. You understand that theodolites they have like a max distance that you can use them to where they're accurate. Correct? You know this, right? You know the specs on your theodolite.
Well, so how accurate, right? And what's stopping you from getting the accuracy? So,
well, let's say a half an arc second at 200 yards. That's going to be what times 6 at 50 miles. I mean, that's quite a distance and deviation.
Let's figure out how much an arc second is at 60 miles. How about that? So 0, 0, 0, 1.
Well, we're just throwing around random numbers that don't really mean nothing right there. We'd have to sit down and figure out, you know, what the arc seconds would be at that distance and stuff. Otherwise, we're just throwing out numbers that don't mean anything.
Yeah, I haven't even gotten the numbers yet, but let's just take the 1 arc second, right? So let's go 1 arc second. We turn it to decimal. We tangent that. We times it by 60 miles, and then we times that by 5280 feet. 1 arc second is 0.0004 feet. So 1 arc second at 60 miles is very, very, very little, right? It's not even an inch. So
why would the manuals give you a max distance of, let's say, like 300 yards or 600 yards? Why would they even put that in the manual then?
Well, so surveyors usually have an order of tolerance that's required when they're doing critical measurements, right?
Right.
But for the shape of the Earth, either the drop is there or it's not, right? It's a crazy number at 50 miles, let's say, right? So if I just were to look up what distance can a T3 wild theodolite measure, right? A wild T3 precision theodolite is an optical instrument, and it can measure angles between targets at distances ranging from a few meters to up to 20 to 60 miles, right? I have that theodolite.
Yeah, I call bullshit on that.
You kind of mentioned it before. You have to understand where the error comes from past those distances.
it's going to be atmospheric refraction.
That may be a contributing factor. Agreed.
Itself. You have to take those things into account. So it does exist.
And angular size change?
But it's not impossible to account for. You just have to understand the numbers you're working with.
Well, and we can look it up in the surveying books. It'll show you and back up what I'm saying, right? And then we could even get so bold as to where I can predict what a measurement is that you're going to measure, right? If you were to get one.
Well, what angle did you get? Did you get an angle that fits your expectations of globe geometry, with or without refraction?
With refraction, I think I was about 6 feet away from my prediction, and without, you're talking quite a bit, right? You're talking about 1/7 of the drop. So
and you understand that there's angular size change with distance, right?
Oh yeah, absolutely. You have to take that into consideration, right? So you just take,
right,
the opposite side of the triangle and the adjacent side, and that'll tell you what angle, that should be measured, right?
So how do you know which refraction to deal with?
Well, my experience has helped me out with that. Now we could go with like a basic standard of 1/7 of the drop rate, which is in many surveying textbooks. But we all know that refraction varies a little bit, right? So 1/7, right? 1 divided by 7 is about 0.142, right? So we could call that like a standard. Here in California, it's about 0.17, and over large bodies of water, I go with a 0.17, right? Which is not much more, but I find a lot more accuracy with 0.17.
So that's going to cause a looming effect?
Looming? No, that's just the K value of an effect of objects going up a little bit, right? From what we would expect with no atmosphere.
Right.
You're just solving for the coefficient based on the temperature gradient, pretty much.
So have you heard of looming? Have you heard of sinking refraction?
Sinking, so stuff that's going lower, appearing lower?
Yes.
Lat, by the way, I see you commenting. You're welcome to talk in the chat. Like, you don't have to stay muted. If you got something to say, feel free.
I think I've heard it from flat earthers, but I'm not really familiar with exact like concave. No, concave people say it goes way up, right? What do they say?
Yeah, they think that instead of a horizon drop, you're going to get it to increase above your eye level, versus the inverse for a convex Earth, it drops away from your eye level.
I'm not talking.
Okay.
I'm just referencing sinking refraction in general. Like, it is a phenomenon, right?
You're just solving for the coefficient itself based on the temperature gradient. You're talking about the way
were those things measured?
Like, for example, when you're talking about looming, or even I can't remember the other one where you get like the floating ship effect. Sorry, by the way, I'm the other guy. The one went to the bathroom.
That's fine. I'm just wondering if those things were measured.
Types of refraction, but they're all going to be based off the coefficient.
Were they measured? So were the conditions required for those effects assumed or measured?
I mean, you can measure it. It's just the temperature gradient. But typically, when we're assuming standard, it's based off of no measurement of the gradient. You can control for refraction by taking an observation, let's say at noon, when the sun is highest up, rather than getting that steep angle of the light where more refraction is possible. So,
this is begging the question, though, right? This is giving the globe the benefit of the doubt in the first instance, right?
Not Exactly. If I'm being completely honest, if you knew what you were doing, you could use refraction in favor of a flat Earth. It just depends on if you're witty, I suppose, good with your words. By the way, Mike is back. Mike is the one you were originally talking to with the actual observation.
Yeah, sorry, I'm back. I'm just trying to. Yeah.
I don't mean to interrupt, but can you say your whole like contact info and handle and stuff again?
Mike or me?
The guy who made the theodolite measurements.
Oh yeah, you can find me on TikTok, 8 inches per mile square.
Yeah, it's cool. He's like an actually original.
I was wondering.
Yeah, we're a dime a dozen.
I looked at that wild theodolite, and it says that yes, it can sight up to 20 to 60 miles, but to make measurements, it's not accurate. It's to stay within 200 to 500 yards.
Oh,
he doesn't need to measure his own distance to the tower.
So it's a geodetic instrument, right? And that the accuracy of that theodolite is probably better than anything you can find on the market today. And it's a classic. It's an old theodolite. They started making them in what, the 40s, 1940s, I think.
Yeah, I looked it up on the internet. I looked up your model.
Yeah, how accurate is the wild T3 theodolite?
And again, this comes down to what errors you're willing to, or not willing, but capable of correcting for, such as refraction or the curvature of the Earth, both of which you can correct for, and it's kind of required for the job.
Only if you know the conditions necessary to produce the observation. Otherwise, you're just backwards engineering. You're saying, I made this observation, so there must have been this amount of refraction based on my ideology and my geometry of the sphere, particularly its radius value, right?
Well, it depends if you're determining a refraction coefficient or not. If you want to find that accurately, you'll need a temperature gradient measurement. That's not.
That's still going to involve a radius value. So at this point, we may as well just give you the globe, and that there is no refutation from any observation, because you can explain it with whatever is necessary with light bending.
You may not have been here at the beginning, but that was kind of where we started. The hypothesis is the shape of the Earth. We're trying to determine what our predictions match. If we predict a certain amount to be hidden based on a flat Earth with refractive coefficient K being whatever versus a globe with refractive coefficient being the same.
That's begging the question.
Towards the reality. We're more so
That's
testing.
going to be circular reasoning, sir. Sorry to interrupt you. It's going to be circular reasoning, sir.
Sorry,
forming a hypothesis and testing isn't circular reasoning.
I'd like to address that. So I typed in how accurate is the wild T3 theodolite. The wild T3 theodolite is a high precision geodetic instrument capable of first and second order triangulation, featuring a circle reading accuracy of 0.2 to 0.5 arc seconds. Gentlemen, you're not going to find a better instrument on the market today that does that, right? Now, if you want to say that, we're using circular reasoning, we're assuming a globe, I'm okay with that. But don't forget, we're also assuming that the Earth is flat, and I'm able to make predictions, right, on what these angles are going to be at long distances. And when I do that, when I do the prediction, right, I assume that the Earth is flat, right, and so we have a target that we know the elevation.
With what kind of refraction effect? With what kind of refraction effect are you assuming it's? Because if you're going to assume it's a globe with a refractive effect, you have to. When you assume it's flat, you have to assume it's flat with a refractive effect, or are you just assuming no refraction when it comes to assuming flat?
So what would it? So if it's flat and that refractive effect equals, I could use the 8 inches per mile square equation to calculate the drop of angle, right? The lower that target's going to be at like 30 to 50 miles or even more, then I guess the refraction equation has something to do with that 8 inches per mile square, right? Which is a lot, which I hear from flat earthers is impossible.
No, I can just invent any refraction needed to explain the observation, just like you'll be doing to explain it for the globe, and make it match.
So what I would encourage you to do is to go out and demonstrate that.
Oh, we have over and over, multiple times.
With precision equipment?
With lasers, yeah, and like you guys with P900s and powerful zoom cameras from as up, high up as commercial aircraft down to the surface.
But those aren't precision instruments. Those are cameras and lasers.
Yeah, so unfortunately, gentlemen, the difference will always be we're using instruments that's made to measure the Earth with, and you guys are using cameras.
Not over those distances reliably, as has been discussed already.
But again, you're not measuring distances. You're measuring angles. When you're using
over distance, right? Over distance, where errors increase, the greater the distance.
Well, hold on. What are the errors you're referring to? Refraction, of course, is one of them. But there's another major one.
User error and instrumentation error.
Yeah, that your theodolite could be level in the first 20 yards, but after that it could deviate down who knows by how much.
Well, I want to be fair to these guys, right? There's always going to be user error. There's always going to be instrument error, right? But unfortunately, I'm making predictions and I'm getting within feet at,
By begging the question with refraction, that the light operates around a ball the way that you think it would in order to achieve the observation. You're just going to back engineer the refractive effect to make the observation fit when it actually doesn't fit. Also, is there an angle? Did you get an angle to the horizon as well? Did you get an angle to the horizon?
Okay, let me know when you're done so I can respond to that.
You're good.
So I'd be willing to bet money that if you were to take a measurement with one of these instruments, I could predict your measurement using 8 inches per mile square. And so that's something that you guys will never be able to do, unfortunately, right?
Okay, fair enough. But did you get an angle measurement to the horizon, and did you gauge a distance to the horizon when viewing the skyline and your tower?
When I'm over large bodies of water, I always take a horizon dip angle measurement because it's fairly straightforward and easy.
Right, and did you have a distance marker, a gauge by which you could determine that horizon was at a specific distance?
The Chicago skyline.
Yeah, well, you could I just use a radius of 3,959 miles.
That's circular reasoning.
So
right?
assuming a ball
I
in the
calculate
first place.
what that angle would be, right?
That's begging the question.
What that angle would be, and then I take a measurement, and it lines up, right?
Yeah, you guys, be able to see,
Johnny and Matrix, you guys can take.
You shouldn't even be able to see Chicago from the dunes to begin with.
Are you sure?
And though, you should be able to, even with no refraction from the Warren Dunes.
So I could go by where I was, right? Let's see, it's 53 point, what was it, 35 miles?
Typically I round down just to be fair to them, because it still works at 53.
But here's my contention. Like, you guys are assuming that it's a ball, right? But then, accounting for refraction, right, to justify it's a ball, right?
Well, it's assuming both.
So it has to be a ball in the first. It just, no matter what it is, it's going to be a ball because you're assuming it's a ball.
Wait a minute. Are you saying it's always going to measure a globe?
That's what you're saying because you just add refraction.
If you keep doing your formulas the same way, it will.
Like we could show you an observation where you will have to invoke extreme amounts of refraction, which go well in orders of magnitude beyond your standard, right? So, and you will do that. You will do that. You will not accept that it's that above that standard is impossible, and you will just say, well, there must have been that amount of refraction. So, what about in those instances where the angle doesn't match?
I've only measured one angle where there was zero refraction, right? Bang on globe, and I had a hard time accepting that because refraction, to my understanding, is always going to be there. That's part of the model, right?
Well, that's false. That's your problem in the first place.
Gentlemen.
By the way, I'm sorry to interrupt. Baron is here. Baron, if you're busy, no need to come up. But this may be in your wheelhouse too. There are people who are actually interested in measurements, so you're welcome to request if you like.
Yeah, he might. So the Willis Tower is 53.26 miles from what I'm seeing here. And then we could go to Walter Bisland's, right? I could just do it by hand too, but
what's going on, bro, Chachos?
You're just hanging out, talking about measurements, right?
Okay.
Neil is currently in a Discord. We're talking to some other people there. They can introduce themselves if they want. Baron is the other person here. He's a land surveyor. He can also answer your questions if you have any. That is his profession.
Cool.
He's not just a lame-o hobbyist.
No, appreciate it. Welcome, Baron. Awesome.
Yeah, thanks.
So this 53-mile observation, what's your eye height?
Okay. So with zero refraction.
No, I wasn't after refraction. I was after your eye height in feet.
We should be able to see 855 feet, right?
That's pure globe geometry.
It was 188 feet, Matrix.
188, thank you.
So
you're assuming refraction.
We could add refraction if you want, but this is zero refraction.
You got to measure refraction first. You can't just assume a number.
That's why using zero is more fair to you guys. It makes
target hidden height 874 feet. That's a lot of assumed refraction, my friend.
Yeah, and it's not fair. It's because there's such thing as sinking refraction, which makes things appear to be lower.
How do you know that?
It's a well-accepted phenomenon. Yeah. Throughout history.
What? That means we have a baseline, right?
The horizon.
By the way, Baron, sorry, I didn't say what's going on to you. You said what's up to us, and I said nothing to you. What's going on?
Not much, man. Just hanging out.
Yeah, I just figured this might interest you. It sounds like these guys are actually being genuine. They're not just being, the typical flat earthers. So it's actually fun. It's not just brain rot.
Yeah, we're having a good conversation so far.
Yeah, so I mean, what are their concerns? Like, what's wrong with the Chicago observation?
Let's see. I think I'm assuming the consequence. Is that
affirming?
You guys can feel free to restate your claim. Just try to summarize it if you can. Baron just joined the live, so he doesn't really know what's going on yet.
So what happens if we assume that it's a flat topographical plane, and then we predict using geometry what that angle would be? Should we be looking up at the target, or should we be looking down at it? That'd be my first question.
Are you above the target, or are you below the target? If you're above it, you look down. If you're below it, you're looking up.
Okay. So if I'm on a flat topographical plane and say my height above sea level is 800 feet and the target is some 2,700 feet above sea level, I should be looking up at it contingent that the Earth is flat, correct?
Perspective will wreck you there. How far away are you?
What do you mean perspective? Can you?
Things get smaller as they get further away, or appear to get smaller as they get further away.
Correct, but they're not going to below eye level.
Exactly. No, but
they converge to eye level.
Right, and you've also got to take into account whether there was sinking refraction or not.
Okay, so when you say converge, what you mean is that the top and the bottom smash into a point at the same rate, correct?
To the center of your level of vision. So if the target is above you and something below, for example, we get a lot of people that say ships disappear over the horizon. Now, using the average height of 6 foot, when you compare 6 foot above the waterline to 30 or 40 feet of ship above the top of that, because they normally talk about massive ocean liners, the difference between your eye line and the water level is only 6 feet in comparison to the top. So the angle of resolution, or the angular resolution, the bottom section will appear to disappear first, just due to perspective and due to your inability to resolve that image. The convergence point is your eye level.
Go ahead, man. Let me know when you're done.
You're good.
Okay, so do you know how perspective actually works? Like, like mathematically how to set something like that up?
Well, you're probably going to tell me anyways, regardless of what I say. So go for it.
Well, I mean, so perspective states that as targets or objects move further away from the observer, they get smaller, correct?
Yep.
The angle that subtends that target. So if you think about a right triangle, the target makes up the opposite side of the triangle. The distance from you to the target makes up the adjacent side of the triangle. The angle that's swept from the adjacent side of the triangle to the top of the target creates the angle that subtends the opposite side of the triangle. So we'll call the adjacent side of the triangle X. So in order for that angle to get smaller, that target has to move further away from you along the x-axis, correct?
But you've got two triangles, one from the center of your vision. You split top and bottom. That's the problem. You're assuming one, not two. Offset.
But what you're saying is that the bottom's getting further away.
No, I'm not saying that.
That's exactly what you said. You said that.
No, I didn't say that at all. I said the target is. I was using a ship, for example, sailing away. The issue is from your eye line, which is horizontal. Okay, so from your eye line, when it hits said target, the ship in this case, from your eye line down to the water line, is only going to be 6 foot. From the eye line to the top of the ship is probably 20 or 30 feet because it's a large ship. That's two separate angles. From your eye line down to the water, from your eye line up to the top of the ship. The top one is larger than the bottom one.
Correct. So
and
how
in angular resolution, when it hits 0.0, was it 0.02? 0.04? 0.02. When it gets down to 0.02, you will not be able to resolve said image. And that's why ships appear to disappear bottom up.
We're using equipment here, bud. So we're magnifying.
That's great. So we just go and adjust our numbers through the Rayleigh criterion.
The bottom of the ship is further away, is what you're saying.
No, it's not. No, I have not said that yet. You keep imposing that on me for some reason.
Violating laws of perspective, and I don't think you actually understand perspective.
Well, you're here to enlighten us, so thank you for telling me I'm wrong. Now you can tell me what I'm wrong by.
I just told you. You don't actually understand the geometry behind it. Because if you
told me that I said the bottom is further away. I did not say that.
That has to happen.
No, it doesn't.
For the resolution to decrease, right? So the angle.
In order for angular resolution to decrease, the object has to be further away. The ship itself is sailing away.
Hold on.
If I may interject, call me the middleman here. I'm the high school educated guy. I'm not super in-depth with mathematics or anything, but from what I've heard, I don't know what the person's name on the Discord is on Neil's side, but from what I've heard, what you're describing would mean that the entirety of the ship, top, bottom, left, right, are all shrinking at the same rate. That would be true with perspective, but the issue is at no point would the bottom suddenly start disappearing at a faster rate than the top or the sides.
No, it doesn't disappear at a faster rate.
Resolution alone couldn't cause that.
It disappears at the same rate. The issue is your comparative distance from the ground or eye level to the bottom of the ship. That's the problem. The ship in itself is a given size. You are offset. Your angle of your line of vision is offset. It's closer to the bottom. That's why the bottom appears to disappear first, because you already have a small angular view to start off with.
Here's the problem with what he's saying, okay? The problem with what he's saying is the point in which the boat needs to reach along the x-axis in order for you not to resolve the bottom is so far out that we're not even getting to a fraction of the distance in losing the bottom. The math doesn't
Listen
math.
to what he's saying.
That's the problem. He doesn't actually understand the geometry behind it. That's the issue.
And here's my issue. Just if you can visualize with me here. Let's imagine just a right triangle, right? 90-degree angle at the bottom. You're telling me if I'm sitting at, let's say, a distance of 6 feet above the surface, the ship will begin to disappear because of said distance, right, from bottom to top. If I raise my height, I'm further away from the ship. The hypotenuse has increased in distance. But suddenly I see the ship again. So it can't be just a function of distance why the ship is disappearing. There's something else at play. I would argue it's the shape of the Earth, the curvature itself.
Well, the issue is, you can argue it, but the problem we've got is we can demonstrate bottom-up obstruction on a flat surface. So if we can do it on a flat surface, it's not the curvature of the Earth that's at play here.
Neil, I see
That's a bad argument. That doesn't follow.
Could you show me what you're talking about? I'd like to see it, and I'm sure Baron would be interested to see what you're talking about as well.
All right, Banhammer. The picture is on the screen.
Mind showing your face?
It's blown up on TikTok for them. So go for it, Banhammer. Explain the picture.
Oh, sorry. Wrong button. Yeah, it's simple. Left-hand side is you looking at your ship. The yellow line is your line of vision. So as we know, things appear to get smaller due to perspective as they sail away. In this case, it's the ship. The purple line, top of the ship. It's pretty straightforward, guys. As the ship, due to perspective, gets further away, those two angles decrease. As soon as they get down to 0.02, which is your, what is it, the Rayleigh criterion, something or other. Oh, I forgot it now.
Yeah, he's talking about the human eye here. We're using
we're using equipment. You're talking about the human eye.
Yep, that's great. So all that happens is that 0.02 changes due to the Rayleigh criterion formula. You just adjust it to the different size lens you're using. That's all. So instead of being 0.02, it might be 0.01 or 0.05. It'll be a different number. And that will allow you to see slightly further. Your ability to resolve at a further distance increases due to that formula adjusting to the size of the lens. So if you want to use an optic, whether it be binoculars or a camera, that's great.
That's not true.
It's the same thing.
If you change the number, that's not true.
Well, it is true, because that's how it works.
The human eye at that specific number.
Yeah, because of the size of the lens. It's to do with the size of the lens.
I challenge you to use a different number.
Oh, well, that's classy.
Right. You know, my experience is different than what is being shown on the screen, right? I got a Lake Tahoe observation that doesn't quite line up with this one.
Is it what's being shown on the screen now?
This is the Chicago skyline from Warren.
Yeah, the first tower, I see it.
And the whole skyline is underneath eye level here. That's what's being demonstrated, right? I'm looking down on buildings that are towering way over my, elevation.
Yeah, like 1,000 feet.
Yeah, right. And I'm looking down on these buildings, and I measured an angle looking down. Plus, they're obstructed, right? And that's exactly what we would expect on a globe, right? with the size that they're supposedly telling us. That was my experience. Now,
Mike, let me ask you something. Yeah. Because I want to follow up with what this guy's talking about here.
Okay.
So how much of the building is obstructed? Bring that up real quick.
Let's see. On a globe.
Yeah. How much is it obstructed? How much are we seeing of the Willis Tower, and how much is obstructed? Straight geometry, no refraction.
889 feet obstructed, 855 feet visible.
So he's saying that the bottom, because the bottom is smaller, the angle to the bottom is smaller. He's saying that that's due to the angular resolution, why you can't see it. But in this case, the bottom is bigger than the top. So how does he explain that?
Good question. Especially considering the shoreline and all, that's certainly bigger than the building.
So the angle that I turn from eye level to the bottom of that base is bigger than the angle I turn from eye level to the top, yet I can't see the bottom because of angular resolution. So how does he explain that with his laws of perspective? Like, can you bring that up on the diagram that you had? And just
I'll give you the big screen again if he wants to show us. MS Paint. I'm telling you, if you go to Paint just on your browser, it's pretty good.
So here's something that I want to show real quick. So, those crosshairs represent eye level with my auto level that I'm looking through, right? And if you go on the Walter Bislins and you punch in the data, right, it shows eye level and it shows the antenna right underneath eye level, right? And if you punch in, the top rung of Sears Tower, 1450 plus the 15 feet above the lake. So we'll go 1465, right? 1465. That's what Walter Bislin says should look like on a globe, and this was my experience. Whoops, let me pull it up real quick. Pull back up.
So even in this case, you could call it a post-diction if you really wanted, but it matches what the globe predicts. It does not match what the flat Earth predicts.
Yeah, we didn't
Good
really see
evening,
much,
everyone.
anyways.
Hello, how are we doing?
Sorry, say that again, Banhammer.
We didn't really see much, mate.
And then I'll bring up some video of me doing this observation too. Just give me a second.
If there's anything you guys have to add, feel free.
We're not seeing anything on our end. It's just your word saying, hey, I jumped onto Walter Bislin, high five, happy days, it matches globe prediction. We've got absolutely nothing other than your words saying that.
Well, I mean, you can go measure it too, you know what I mean? Like, this isn't fenced off.
Yeah, I don't even know what you're measuring, mate. That's how little information we got on this end.
I just can't see.
What would the flat Earth predict instead? Would it predict the same thing via different mechanisms?
Okay, obviously these guys don't understand. When you say what will the flat Earth predict, in regards to what? I've got no other information.
In regards to this observation from the Warren Dunes, 53.35 miles, 188 foot observer height, to a 1,463 foot target, what would you predict to see on a flat Earth?
A 53-mile observation? You shouldn't see it at all.
Predicts.
Well, what would the zenith angle be? Let's just ask him that, since he had his little triangle up there.
You shouldn't see it at all at 53 mile. What were the weather conditions for the day?
Is that what you said?
Yeah.
What were the weather conditions for the day?
Can we just put a pin in everything for just a moment, just to do a bit of admin stuff? Neil, I'm just wondering, Neil, is it possible that you could, on Discord, share your screen so that we can actually see what is going on? What these guys are?
I'm on my phone, but I can like turn on my. I can do this.
If anyone has TikTok, you can just send them to my live. It's just Globe Man on TikTok. Globe Man with 2 N's. Just one person can do it.
Okay. TW.
Yeah, that's it's not the greatest. Yeah, that's not going to work. I don't think.
Can you see it or no? Not good. Oh crap! All right.
No.
No,
it's all good.
I guess they can see it, so no need to explain what you're showing.
Well, yeah, I'm just showing my auto level observation, the video I captured while I was there.
Yeah, we've got your information for later reference, so that's good. Thank you.
So I've got auto level stuff. I've got theodolite measurements, right? I've got the video of me taking the measurement. I've got all the data I could bring up on the numbers. We could compare it to and so what's cool about Walter Bislin's is we could punch in all the data and we could see what the angle he predicts is. I could show you what the angle I predicted is, and then we could just look at the measurement, right? And
while you're on Walter Bislin, that was something I wanted to know. You're on Walter Bislin, you've grabbed the slider to make it match what you can see. How big was Earth's radius when you got to the right size that you're after?
I don't think he had any refraction at first, and you should still see it.
Yeah, he asked what the radius is at my location, right? Is that the question?
No. When they grab their slider to match the right distance or refractive index and all that crap, what size radius did they get out to when they got everything right?
Oh, yeah. Are you talking about this number down here?
I don't know if I can see it.
The apparent radius with refraction included, right? I think that's what he's talking about, because that's something that flat earthers always bring up, like, oh, look at the radius that comes up on Walter Bislin's when you introduce refractions, right?
I think you're right. I think that is what he's talking about.
Right. So with the standard refraction on Walter Bislin's, the apparent radius he's bringing up is 4,769 miles.
So Earth magically grew. Interesting.
Is that with refraction, it fattens up the radius a little bit, right?
Well, it shouldn't, because the ground doesn't grow, mate.
Yeah, you're right. The ground doesn't grow.
So using that slider to insert your refraction is a epic fail.
Hence the word apparent, right? It's apparent.
Okay, it's an apparent fail. Either way.
So all this is a simplification of refraction, right? We could get into that, right? But how do things measure? And so we could predict the measurement, and that measurement is based on a radius of approximately 3,959 miles, and the refraction is about 1/7 of that, right?
So you're assuming refraction. So how did you know? What temperatures did you have? Humidity, all of that. Did you take all those too?
I have the tip. Yeah, I have the tip.
Right. Here's the thing, right? So let's say you provide him all that data. Okay.
Right.
Did you guys take it on the day when you did your so-called measurements?
Let me talk, man.
That's great. Yes or no? You can go for it after it.
Oh shit.
We can take turns, guys. We're good.
Yeah. So let's say Mike, let's say you give him all that data, right? You have the time.
Does he have it, bro? That's all I wanted to know. It's pretty straightforward.
Yes. Yeah. I'll bring it up. But go ahead and get it all out of you, right?
Get it all out of you, man, because I kind of want to say something here.
All I asked was, did he take temperature, humidity, and all those kind on the day when you did this so-called measurement? If yes, yeah, that's great. If no, it's a no.
I mean, it's a pretty fair question. It's like a yes or no.
Let's say.
Wait, hold on. Are we going to skip over this because this is the point of contention?
Yeah, I'm bringing it up.
He's working on it, man. Give him
my notes.
No, but can he answer it then? Like, is it a yes or a no?
I have
He's got it. He's pulling it
Oh,
up.
okay. That's all we need to know.
Yeah,
Thank you.
I'm pulling up my measurements.
So yes.
Here's my question. We provide you all that data. What are you going to do with it? What are you going to calculate with that data? Can you turn on your screen and walk me through your process?
Well, me turning on my screen is going to be as useful as what I've seen from yours. But anyways,
I can do it.
The reason we ask this is a very simple thing. Is every time flat earthers put forward any measurement, the first thing we do is we get globers coming and going, refraction! You can't have that because of refraction! And they have a left field meltdown. And refraction's the answer to everything. It's the get out of jail free card. I'm going to slap refraction down and there's nothing you globers, you flat earthers can do because I can walk away freely and you can't do shit. And they're always asking us about temperature readings, humidity readings, and all this bullshit. And you know what? It doesn't hurt to ask you guys. Did you take readings?
He's got it. So here's the data. Do you want the data?
I just wanted a yes or a no. Did you take readings? That was it.
Yeah, he's got it.
Hold on, Mike has it. Here you go.
Yeah,
So here it is. Are you ready? It was 3:58 p.m. at the Warren Dunes. It was 3 degrees Fahrenheit on 11/28/25. I'm going to go ahead and go online and see if that jives, right? And then we can get the humidity too. I didn't take a humidity reading because most flat earthers don't even want to see the measurements, right?
Well,
we're not most flat earthers in here.
Mike, you can make up any number. He wouldn't know what to do with those numbers even if they were real.
I understand that, but since you asked, here's my note. Here's my measurements in my notepad from that day. I have video, I have pictures, I have measurements, I have the equipment, I have the data for you. And I have the distance, I have my elevation, I have the target height, I have all that. So if you have some measurements that you've taken, I'm more than willing to entertain them and check them out and compare, right? But unfortunately, I'm not getting any measurements from you or your side, right? But we can just. I'm more than happy for you to scrutinize my stuff, and if you don't accept it, I'm fine with that. But I would like to see your interpretation of that temperature, right? And then I'll look up the humidity, and then we could go from there and see what you come up with and what that measurement should have been, right?
Perfect.
The reason we ask for that is because we can check out the refractive index using it. That's why. Because then we get all these crazy claims. Like I said, a lot of the times whenever we put forward anything, Neil, can you show them the Black Swan, the original?
You got a picture of it in the side chat? Want to post it? And I'll go on cam?
Put one in there.
Money.
Hold on.
The Black Swan is a fun one, dude.
Yeah, let's do it.
Those are oil rigs, Bob.
We're headed back there. Actually,
thanks, Bob.
If you guys get a really good observation, I would actually like to see it in good definition. If you guys could message me if you get something good, please do.
Yeah, we're so apparently we might be meeting up with Jared.
Here, I can let Neil show it. Here we go.
So the Black Swan, we've been there twice, and he's been there 3 times, I think, right, Baron? You've been there 3 times. I've been there twice. I've been there twice. We have measurements from there. We have a lot of P1000 stuff from there, and we might be going back. We might be going back in a couple weeks, and we might be meeting up with Jaron, that guy that went to Antarctica, supposedly, right?
Jaron has earned my respect. I already liked him before, but he has won me over for sure.
So that might be happening this month, and we're pretty excited about that. So we like the Black Swan. We've been there. We have measurements from there, right? So go ahead, guys.
All right, you're up, Matrix. The picture's on the screen, and batter up.
So based on your Earth radius, allegedly 3959 miles, the formula to work out where the horizon is based on your elevation. So observer height, square root of the observer height times 1.225 or 1.22, make it easier. Some people love maths more than others. So the horizon from a 1 foot elevation should be 1.22 or 1.225 miles.
Yeah, well,
The issue is in the Black Swan, the horizon is well beyond 9.41.
It wasn't at a foot, so I don't know where you're going with this.
It was at 8 inches, which is less than a foot, which makes it worse.
No, it wasn't. I think you
Yes,
need
it was.
to watch that video. Yeah, maybe we
Yeah, the video that was set down on 8 inches. That's what the actual height was, 8 inches, which is less than 1 foot.
So if somebody wants to bring this video up, we'll just watch it together and we'll just go over it piece by piece because obviously there's a problem here. With
Yeah,
that.
let me see if I can bring up the original Black Swan.
Bring that up, Mike, please.
While he brings that up, I would like to mention.
Yeah, go for it.
Yeah, so I wish I could point at it on the screen, but there's actually, you can see there's a false horizon that looks like it's beyond the second oil rig. If you look at the oil rig, though, there's a platform underneath it. That's a walkway. You're supposed to be able to walk.
Why is it, what makes it false? What makes it false, sir? Can I ask you what makes it false?
That entire walkway is gone. There's a helipad at the exact same level. That's gone.
Excellent. I'm glad I'm glad you're pointing out all these problems with the oil rig itself. The oil rig. Right.
I'm more interested in your statement about it being a false horizon.
Go back to the
I'm
false horizon thing.
Very interested in your statement about there's a false horizon beyond the furthest oil rig. I'd like to know how you determined it to be false.
You can see it.
You can see the horizon? Yeah, no shit. What makes it false? What makes it false?
Is missing.
Sorry, say again?
Yeah, so the walkway, you can see it on the first oil rig to the right side, that walkway right underneath. There's a helipad at the same level. It's visible. Platform
How does that make the horizon beyond the oil rig false?
We can take turns. I've barely been talking.
Actually, could I just pose something to you, right? How about hey, just conceive of this, right? Like, see if you can grasp this concept, right? That the horizon, there is actually no such thing as a false horizon. There is only an horizon. That's it. There's only a horizon. There's no false horizon. There's only the place where the water appears to meet the sky. That's it.
Got the original video. So that walkway is missing. Mike, I'll let you have it real.
Neil, can we just tell them the oil rigs are there for demarcation only? They could be a little traffic witch's hat for all I care. They are there for demarcation only. If they weren't there, we have no way of ascertaining the distance to the horizon. But we've got these beautiful oil rigs there for demarcation, showing their distance. We know their distance, and the horizon is clearly beyond them. It should be in front. So all your claims of the walkways or the helipads or the bendy cranes means absolutely nothing.
But here's the issue. Here's the issue I run into. Those helipads and that walkway are 80 feet off the surface of the
congratulations, that means nothing. Totally irrelevant to the... Totally, hey, bro, totally irrelevant to the argument. They mean absolutely nothing.
Hey, you got me, man. Baron, you heard it here first. Observation height, target size, that shit don't matter, dude. It goes off...
The horizon is the target. The horizon is the target.
It doesn't matter because the horizon's the target, not the helipad.
Yeah, not the oil rigs, the thing in between them, none of that. That's not the target. The horizon is the target.
Yes, and the horizon.
You're saying it's false. I want to know why you're saying it's a false horizon.
Okay, so the horizon. Okay, so the horizon is the target, right, gentlemen? So I went to this spot. I tracked down where this guy was, and I went to this spot. I got a different result. And my horizon matched the globe. So how do you differentiate your belief?
Okay. Your horizon... Hold on, just a sec, T-Dub. Your horizon matched the globe. How did you measure the distance to the horizon?
Well, how did you measure the distance?
Sorry.
You're just watching
Well,
a video.
The way that we use it, we use the oil rigs as demarcation, as I've said 3 times now.
Classical triangulation is what I used. I created my own baseline based off an azimuth. Would you like to go through the geometry real quick?
No, of course they wouldn't. What are you talking about?
Yeah, no, you can't infer. You can't infer from angle.
Poisoning the well. Yeah.
you can't infer from angle without invoking a geometric horizon, which then you're throwing refraction away. So you can't have it both ways, man.
I don't even know what you're talking about. What are you talking about?
You're going to be talking about a calculation based on angle to the a horizon you got using your theodolite, right?
Correct. So, like on a flat Earth,
right? You can't do that. You can't do that. You have to throw out refraction now. You've invoked a geometric horizon.
Throw it out. I don't care. Throw it out. Include it. Whatever you want to do, dude. It's so far
Okay, so
away.
there's no refraction.
It doesn't matter what you do.
So it will matter to you once we direct you back to the other black swan image. You're going to say then you're going to say refraction, right? So is there refraction or isn't there refraction?
I can toss you guys refraction.
May I answer the original question asked?
Yeah, we'll forfeit refraction, guys, and we'll just take a measurement and see what happens. That's the difference between us and you. We will take
wanted to tell you how you can determine the distance to the horizon. You have a reference point. Like you said, the demarcation points, the oil rigs, correct. You can use platform habitat as your reference point. You have a known distance, but a part of it is missing. At least
doesn't matter.
27 meters up to that.
It doesn't matter. It's the distance to. It's the distance to it that counts, not above it.
Just not doing it.
Well, so here's the thing, right, guys? Here's the difference between us and you. We've been there. We have the measurements. You have a video that somebody else took and that you believe, right? So I'm going to go with my measurements, and I'm going to encourage anybody to go there, and if you guys take a measurement and it measures a flat Earth, we could go over that, and then
you don't have a measurement to the geometric horizon.
There we do. Yeah. What are you talking about?
No, you don't. How did you measure it?
I turned an angle to it. What are you talking about?
That's going to be a calculation then, not a measurement.
What do you mean? Like really? Here, let's go.
Really?
He's right on this one.
Mike, do you remember when you went to Pelican Point?
Pelican Point. Yes.
Remember? Okay. And you, so here's my horizon dip angle from March 3rd, 2024. And what did I measure? Let me see what I measured. So there's the monument. There's the monument I set up on. So that's going to give me a height above sea level, right? You guys love sea level, right? Here's what's interesting about this. You guys see this lapless correction here? This, I don't expect you to understand that, but look that up sometime. When you get into surveying.
We can't see it on our end, unfortunately. But if you can describe it, if you can tell us vocally, that'd be great.
It's the difference between vertical and down.
It's a surveying thing. It's kind of complicated, but just go with the sea level thing, Baron.
Yeah. All right. So here we go. So here I am. I'm turning angles to the horizon, right, based on that brass cap survey monument, and the angle that I got here. So I measured a 6 minutes and 28 arc seconds. Mike, what did you measure?
Let me look up my notes and I'll.
I think we were 2 arc seconds apart, and we went at 2 different times during the year.
Yeah, that's when I went by myself, right?
Yeah.
I'm pulling up my notebook. Okay, Pelican. That's a horizon dip angle from Pelican Point, right?
Correct. And my face left was a 90.0628, and my face right was a 269.53.16. I'll have to calc up what that error was.
I got 90.0632 on a live.
Okay.
And my average mean was 90.0620.6.
Wow, so we're just a few arc seconds away from one another. When did you take your measurement?
I took mine 8/4/24 at 1:29 p.m. It was 74.
We took ours 5 months apart, and we were like 4 arc seconds away from one another. How do you explain it?
It was 70.
The Earth might be curved or something, dude. What the hell?
It was 74 degrees Fahrenheit when I took my measurement. I have the longitude and latitude of my coordinates, and
if you're saying the horizon and its and the apparent angle dip, right, is representative of the Earth's curve edge, then you are invoking a geometric horizon and thereby throwing out any appeal to refraction when we show observations which apparently break globe geometry.
Show me an observation that breaks globe geometry.
I don't think they understand.
You just saw one.
Something that's
you were aware of one already. The black swan.
Hang on, I've been out to the black swan. I've been out to the black swan 3 times, and I'm not seeing what you guys are saying.
Congratulations. It's because you don't want to. It's like blinkers on. I'll see what I want to see.
Dude, I have video, dude. My video just looks nothing like.
Is a theodolite? Is a theodolite and P900? Does it have capabilities like the P900 to zoom in that far?
Mine does.
I got a P1000.
Your theodolite has the same abilities as a P900? Same zoom capabilities?
Do you want the answer? So I can switch out eyepieces. I can go from different types of magnification to deal with different types of atmospheric conditions. I can get zoom, or I can cut down the magnification to cut through atmosphere. So, you got to kind of call the ball on what you want to do and what time of the year it is, right?
Whip out an 8-inch Dobsonian, it don't matter how far you can see.
It may.
So these guys are using somebody else's work online when the entire premise of their argument is you can't trust anybody. And that's where they follow that up with,
When did we say that's the premise of our argument? When did we say that's the premise?
I'm almost done. So, Flat Earth, they stand on the premise that you can't trust people that we're being lied to.
What the heck, bro? That's a straw man.
Thanks for the straw man. Please try again.
That's a smear campaign.
In the middle of my conversation.
Yeah, but it's non sequitur.
That's excellent. You got called out on a straw man.
I'm almost done.
Yep, that's great. You got called out on a straw man. Start again.
Almost done poisoning the well. Okay, let's let you finish poisoning the well and straw manning it.
Just take turns. That's fine. If he's poisoning the well, just take turns. That's what
Look, you may not like what I'm saying. You may not agree with it. It may not even be correct. Okay? But the premise that I've learned throughout the 5 years I've encountered and had an interaction with flat earthers is that you're being lied to. And that's why, right? That's why it's so important to do your own research.
When have we claimed we were lied to? Thank you for using someone else's argument on us.
Let him finish. Let him finish. I know he's gonna finish. Go for it.
Okay. And so the importance of doing your own research. So this sounds really attractive, and I took your advice on that. And I did my own research. Unfortunately, it disagrees with you. The problem with the research you're doing is you're not actually doing any research. You're taking other people's information that you think agree with you, and you're putting it on here as evidence.
All right.
You don't actually have any evidence.
All right. Are you done? Are you done poisoning the well? That was real great, bro. We literally just went through a full conversation, and then out of nowhere, you just 360'd and poisoned the well for some reason. So thank you for that.
Yeah, you're
hey, I got a question for you. I got a question for you.
Yeah, what's the question?
I heard you say something that you switch out your zoom depending on the atmospheric conditions. Doesn't light come to the theodolite? How does changing the focal length change that?
So when you increase magnification, you sacrifice clarity. When you decrease magnification, you increase clarity.
Okay, magnification is simply increasing the focal length. Okay, that's just blowing up the image. If you want to, look, bro.
Switch on an eyepiece that increases the magnification
Guys, keep in mind you're talking to a surveyor, not a photographer. Don't
Yeah.
get too adept with the focal length nonsense. It don't matter.
Sure, he's a surveyor.
Yes, I am positive he's a surveyor.
Do you know what deflection of the you know what reduction of the horizontal direction is?
Do what?
Reduction of the horizontal direction. Do you know what that is in surveying and why it's done?
Reduction of the
Called
horizontal.
reduction of the horizontal direction.
Oh, this is getting good. Yeah, please explain this to me.
Well, it's on page 47 of the Great Trigonometric Survey of North America.
Do what now?
You don't know what it is? It's the first operation you're supposed to do when you're surveying. It's the very first thing.
I don't think you really understand what you're saying here, but
okay. So,
but if you want to get into it, we can.
So I don't understand. Doesn't address what I said. Just
I would like to say, as the host, please.
So please don't comment about me because I'm not the topic.
Quiz. I would like to stay on topic, please.
We are on topic. I don't think he's a surveyor. And if he is, he's just my friend used to survey when he was 18 years old as a summer job. So what? You don't know what reduction of horizontal direction is. I don't understand. Then you don't know what you're doing.
All distances along the ellipsoid are longer than distances along the chord.
Okay, that's a cool story. What do you need an ellipsoid for in the first place?
It's a measurable fact. I don't know what you're talking about.
So okay, if the Earth curve was measured by surveying, what's the reference for ellipsoid for in the first place?
What's the reference ellipsoid for?
Yeah, what's it for in the first place? If you're simply measuring curvature, you wouldn't need that.
Well, sure you need it because the Earth is not perfectly round.
So what is it for?
I'm not sure.
Can you explain it to me?
The geoid model is an undulated model, right?
Yeah, there's the EGM, the Earth gravitational model, which is the geoid, right? And then, but then there's the reference ellipsoid.
Correct.
It's two different
and
things.
The ellipsoid is an average between those two.
No, it isn't.
Between sea level and the geoid.
It isn't. No, it isn't.
Yeah, it is. Sure
no.
It is.
Okay. One determines the direction of the plumb line. Okay, the geoid. Right. You know plumb lines are curved in geodetic surveying, right? You know that?
No, they're not curved.
Yeah, no, they're not. Jesus Christ. You don't know anything, do you? So there's publications from that say curvature of the plumb line, specifically talk about that, titled curvature of the plumb line, but it doesn't exist in geodetic surveying.
Plumb line and vertical that you're talking about.
The plumb line, they curve the plumb line because the combination of the geoid and the reference ellipsoid to map. Hold on, listen. Because the plumb, because of what they say is the irregularity of masses within Earth. Plumb lines is not perpendicular to the surface of the Earth. That are to be tilted or deflected in some way. But because that projection, that mapping, when you put it on the reference ellipsoid, it has to intersect it at 90 degrees to preserve distances. That they have to curve the plumb line.
It's the deflection between vertical and plumb. So I don't know what you're talking about. It's called Laplace correction. And it gets greater.
It's called deflection of the vertical direction.
Okay, are you going to let me answer, or you just want to steamroll this?
No, you're full of shit, dude. I can't believe you bamboozled these people.
Okay.
You can, look, anyone that just heard what I said, they can go on Google, AI, whatever, fact check what I said.
Yeah,
you're full
and
of
I can
shit.
show you in a book
Anyone
right now.
that says that you can increase the zoom of an instrument and see better is fucking full of shit.
Do you hear that, Mike?
Yeah, that's great.
Yeah.
Okay, so
you look through an instrument that's
he
got
said because of atmospheric
and
conditions.
you don't see better? Is that what you're saying?
Look, brother, what does zoom do?
It lets you
What
see
does zoom
more.
do optically?
You're able to resolve more, right? When
No,
you zoom in stuff,
no,
right?
that's angular resolution. That's a different thing. So they're different equations. The equation for magnification is one. The equation for angular resolution is another thing. They're two different things. You guys confuse this shit all the time. So light, if you want to collect more light
I think we're
at
really
the
honest.
optic, you need a larger diameter optical. That will increase your angular resolution. Increasing the focal length does not change that.
Optics here, and I really want to learn more. So I
do too. I think the audience wants to learn more from a surveyor who's full of shit. So let's listen to this guy's interpretation of Laplace correction.
Not my interpretation. I'm quoting the literature.
You wouldn't need a reference of live sway.
I just said your interpretation. Just because you read something doesn't mean that you understand it.
Okay, yeah. So again, you're attacking me instead of refuting what I said. You can't refute what I said because all the literature says exactly what I said.
I can refute it. And I'm going to
yeah, with what? Nuh-uh?
No. Laplace correction. Define what Laplace correction is.
I have no idea. I've never even heard that term used before.
That's because
Laplace correction.
Because what you're talking about right now is exactly what I'm talking about. Laplace correction is the deflection between vertical and plumb. And it gets bigger and bigger and bigger the higher you go up.
You got a citation? Can you give me a document that's in?
Laplace correction is greater than if you were at sea level. It's the difference between vertical and plumb. There's an angle there.
Spell that.
It doesn't mean curve. It's a
Spell that,
deflection.
please.
It's a deflection.
Yeah, he has to spell it so he can.
Can you spell it for me, please? The word.
You're just wrong, dude. You're
Yeah,
just
spell
wrong.
it for me, please.
Laplace correction. Laplace correction.
Laplace.
With surveying or else
It's
just
called,
talking about-
the name is Laplace. He was a
gas
physicist.
corrections, and that's not
Laplace. So he's just talking about deflection of the vertical, Indio?
Yeah, it's Laplace. Okay, so Laplace is correction. You didn't say it right. That's why I never heard of it. You didn't say his name right.
So this is a really good live, guys. I appreciate you guys coming up. You know, there's a lot of research on your end, right?
I don't. Can I say one thing? I don't appreciate him saying we didn't do anything. He doesn't know what we've done.
Yeah, we don't know much, right? So you guys have done a lot of research. You guys have been flat earthers.
I've done experiments, tests. Look, man. I've done plenty of actual observations myself. Just come and say we haven't done anything and we just watched a bunch of YouTube videos is nonsense, man.
No, he said the opposite. He said you've done a lot of research.
Going out and doing experiments is not research. He said we didn't do anything. He said we're researching the wrong thing and we're just sitting there just watching YouTube videos.
You're talking about Baron, dude. Mike is hyping you up. What are you talking about?
Yeah, I'm rooting you guys on. So how many years have you guys been researching this stuff?
This is the good guy. This is the good guy, by the way.
Decade, please.
Yeah, I mean, I've only been taking measurements for 2 years, right? But you know, it sounds like you guys got a better understanding and a better handle of all this stuff.
Can you give me the big box, Tyler, please?
I got you.
So the very first thing I looked at when I got involved in this topic 10 years ago was surveying. It was the very first thing I looked at.
Okay.
I didn't look at flat Earth videos. I didn't watch Eric Dubé or Mike Sargent.
I don't know how to read.
I'm familiar with differential geometry, so I know how this stuff works.
Google this, according to him. So I put in do plumb lines curve in geodetic survey. And it says plumb lines do not curve.
Yeah, well, that's wrong. So I'll give you actual citation to an actual published document from the University of New Brunswick, GIS department.
I would like to ask, if I may, you said you first started looking into surveying. What is the point of geodetic surveying if the Earth is flat? Could you not just do plane
To map the
surveying
surface of
the
the
whole
Earth
way
to the
through
sky.
and be fine?
It's to map the surface of the Earth to the sky. Latitude
but
and
why would
longitude
it
are
exist
coordinate.
If the Earth is flat, nothing would work.
Yeah, nothing would work. Yeah, prove it.
I can prove it.
Well, hold on. Are you asking me to prove?
Yeah,
that
just like I can't prove it. It can't work. It's impossible. Those are just words. Dude.
A geoid is not flat, therefore geodetic surveying would be useless on a topographical plane.
The geoid is an imaginary equipotential surface of gravity. If you measure 9.8 meters per second squared, everywhere you measure that would form in its own imaginary surface. That's what the geoid is. It's also said to be what a mean sea level would be if it went under the land masses and all that shit.
Line at sea level.
Look, latitude and longitude are not on the ground.
That's an average, and it also doesn't matter in what you're talking about.
No, look, it's simply a map. It's not even a map. All it does is tell you the level that 9.8 meters per second squared acceleration is. That elevation.
I'm not asking you how the WGS-84 was built.
It isn't the WGS. This is the geoid. This is the EGM.
Listen,
look, you're confusing two different things, dude. You're confused. You're confused. You're confusing two different things. There's the geoid, and there's the WGS-84. Did you hear a word I said? There's the geoid, and then there's the WGS-84. They're two different things. One is a gravitational model. One is a reference ellipsoid. They're two different things. And then if you want your actual height, you get the orthometric height, which is the subtraction of one from the other.
You're right, man. You're right.
I know I'm right.
Aaron, you should just fucking quit, man. You don't know shit, dude. This guy's got it. This guy's got it.
Yeah, too bad you can't. Sarcasm is not telling me how I was wrong. Okay? I'm not wrong.
Yes, it is.
You ain't the first survey I've ever talked to.
You're wrong. What do you want me to do? Convince you against your will?
Yeah, look, dude. You just said you Googled, and it says there's no curvature of the plumb line. Listen, type in Google, type in curvature of the plumb line surveying, hit Google Images, and that will give you a bunch of diagrams that are linked to freaking peer-reviewed documents from ResearchGate, Google Scholar, all these things where you can actually see it. It has to be the case if you're going to have an Earth gravitational model, because the plumb line has to intersect a reference ellipsoid at 90 degrees. And if the plumb line's tilted, a deflection of the vertical because of lumpy gravity, it can't intersect at 90 degrees. It's going to be tilted.
You already referenced what you're talking about. He talked about.
No, he looked on Google.
Hold on. Between vertical and plumb. He already mentioned your deflection angle you're referring to.
Deflection of the vertical is what it's called. He said the Laplacian correction.
And you're just pretending it didn't happen.
No, look. The Laplacian correction is called deflection of the vertical. That's what it's called. And it's the correction of the celestial sphere to the surface of the Earth. So I'll tell you how it works, right? Let's say there's supposed to be a star at zenith, right?
Same conversation, but worded differently. It's like a game of fucked up telephone.
Well, it isn't a uniform terminology, okay? In the field itself.
Guys, is this what flat Earth is now? I took a break.
So there we go. That's what you guys always do. Now you're going to talk about us.
Neil.
Yeah, the same old stick. Now you're going to talk about us instead of the topic.
I think we're on point, actually. This is like the perfect spot.
You can't adjust the topic. So you got to talk about us. You flat earthers this. You don't understand that. They try to make us the topic.
You got me. But Neil, I don't think you understand. When you first joined, I had so much confidence
Neil,
in you.
I don't think you understand,
These guys
Neil.
were dragging you down. You were making better points before you got them involved.
No, but this is literally like at the point where we're trying to have a conversation, but you're not letting it happen. You know what I'm saying?
Because the conversation it's just going in a loop.
Okay, which part? Okay, time out. Which part of it? Which part of the conversation? Which part?
I was going on to that. You guys are talking about deflection from vertical. Baron brought this up about 15 minutes ago. This was the first thing he brought up in reference to survey.
No, he's talking about something else.
Pronounce it right.
He's not.
Whatever.
Brother, he's not talking about.
He was talking about if this is something you're actually interested in.
He's talking about. Listen.
Oh my God.
Dude, look, brother, you're confused.
Back and forth? Can we have a back and forth?
Section of the vertical direction because it's not the same thing.
I'm just going to repeat what Baron and Mike.
No, I'm not. You're confused. He's talking about reciprocal. Look, bro. He's talking about reciprocal zenith angles. Deflection of the vertical direction is something different.
No, I'm not, dude. No, I am not. What are you talking? This guy's fucking wild.
Okay. Reciprocal zenith angles are the tilt because you are on a curved surface, so the verticals will be tilted away from each other because they're supposed to converge at the center of the Earth, right? Deflection of the vertical is the difference between plumb being perpendicular to the surface of the Earth. God, so you talked over me the entire time. Really?
Well, can we have a one-on-one and just let each other talk for like 15 seconds at a time? Appreciate it. Thank you.
Baron, you got it. I'll be quiet.
Let him get it out of him, and then we'll talk about reciprocal zenith angles if you want.
Okay.
Right?
Reciprocal zenith angles would be verticals that are tilted away from each other because of curvature of the Earth, right? Because the plumb lines would converge in the center of the Earth if it was a perfect sphere. Okay, right? That's correct.
Not a perfect sphere. But
Is that correct?
They're not verticals, dude. They're zenith angles, bro.
That's what I said. Reciprocal zenith angles.
No, you said the verticals. You said the verticals.
Between plumb and vertical. We just went over this.
Oh my
You
God.
said the verticals would be leaning away from each other. There's no vertical here. You're measuring.
How do you find? Okay, let's start from the beginning. Let's just do this.
Okay,
so
let's put it this way. The summed zenith angles is equal to your change in latitude. How do you explain that?
That's not even true, dude.
It is true. It's a measurable.
You made that. Okay, post the data. Post the uncorrected data that was not corrected for by reduction of horizontal direction. It was not corrected and posted on a reference ellipsoid. That's raw measurement data.
What are you even talking about, dude?
Okay, because
the problem here is
you don't even understand what you're doing. You don't even understand your own profession. Okay, this is sad. So you have a reference ellipsoid. Every measurement you take is mapped to it.
Let's say you're right. Let's say you're correct. Let's say that I'm full of shit, okay? And you're and let's say that you're here to help me. So I want you to help me understand in the notes, in the tabulated notes that I have in my field book.
Okay.
Can you show me what reduction to horizontal is and why it would make a difference in reciprocal zenith angles? Go ahead.
Okay. The purpose of reduction of the horizontal direction is to change the azimuth direction. You understand? Because you have to reduce the measurement. Because you have to reduce the measurement down to. You're going to let me finish? So you're going to talk over me. Hey, you can talk. Let me talk over you, though. So, look, you have to reduce the measurement to sea level, right?
No.
No?
No.
Oh, okay. So how do you know your vertical elevation?
The elevation's irrelevant.
Well, it's not irrelevant.
It is irrelevant. And I can demonstrate it. But can you demonstrate that it is?
Okay, so say I'm a mile above the surface and I do a sight to something that's at sea level. What's my distance?
What's your distance?
Yeah. It's the hypotenuse of a triangle, right? That isn't going to be your arc length distance.
I don't know.
So yes, you have to do this reduction of the horizontal direction to sea level. You have to reduce all the measurements down to sea level for the distances to be correct.
It has nothing to do with zenith angles. You're just measuring a zenith angle, dude. It has nothing to do with sea level. Topography is irrelevant. Reduction of whatever this horizontal thing you're talking about.
Is the direction of gravity relevant?
Do you even know
Is the direction of gravity relevant?
A slope, distance, any of that. I'm not even a fucking surveyor, man. This is not hard.
Is the direction of gravity relevant?
Can you tell us what an azimuth is?
Yeah, it's the direction relative to true north.
Cool. I accept that answer.
Okay.
So look, when you take some measurements, say at the top of a mountain, and reduce it to sea level, the azimuth is going to rotate. So they have a correction called reduction of the horizontal direction, which you take. Hey, let me ask you this, Baron. Do you think that you measured angles greater than 180 degrees?
Yes.
Oh, okay. So how did you do that?
Our turn for a question. How does azimuth pertain? How is that relevant to zenith angles?
Oh God, because you have to assume that the verticals are tilted away from each other.
I know, but an
That's what you're measuring. You're not assuming that. You're measuring if that's the case.
Hold on a second, Tyler. Hold on a second, Tyler.
If
So
you
he's
cherry
talking
pick measurements.
directions, right? One's in the vertical direction, the other's in the horizontal direction. What he's saying is I need to know what my azimuth is, like whether I'm 270, 183. What does my direction have to do with the zenith angle? That's what I'm waiting to hear.
Okay, so you're assuming that the verticals are tilted away from each other, right?
I'm not assuming anything. I'm assuming they're parallel.
We're measuring that, though.
No. Let's just go with I'm assuming they're
Have
parallel.
you ever measured a positive zenith angle?
What is a positive zenith angle? Give me a
So
number.
instead of them being tilted away, they're tilted toward each other.
Okay, but no.
The zenith.
What is a positive zenith angle? Give me a number. Like what is a positive?
I don't know. Plus 0.001 degree. I don't know.
Why are you saying it? Then why are you saying it, dude?
I just want to know if you've ever measured the opposite. This is an honesty check.
No, you said positive. You said
Yeah.
positive zenith angle.
Instead of tilted away from each other, they're tilted toward each other, right? Instead of the plumb lines converging at the center of the earth, they're tilted away.
You don't know what a positive zenith angle number is. What's a negative zenith angle number?
When they're tilted away.
What's the number?
It's less than 90 degrees, right? 89 degrees? Positive would be greater than 90 degrees.
What the hell, man?
Dude, this guy doesn't belong in this conversation.
Are these guys just acting stupid or what?
Yeah, they are. They're trying to pretend stupid. So if I take a horizontal line between the verticals and they're tilted away, and I take a protractor and measure that angle, it's going to be greater than 90 degrees. That's a positive zenith angle. Negative would be they're tilted toward each other.
You're about 90 degrees off.
I think a positive angle in what he's saying is less than 90, looking up.
Correct. A negative angle would be looking down.
So is he asking? So I think he's asking if you've ever measured the Earth to be concave. That's what that question.
You wouldn't be measuring the Earth to be concave. Yeah, I am asking him that. Has he ever measured the Earth to be concave? Yes. No, I'm serious. I'm serious. I'm asking him. This is an honesty check.
Honesty check.
Yeah, it is. It's an honesty check. Because if you're actually, I know the entire process of surveying, and I know the data that's collected, and I know the process of statistical outliers and weighted means and all that shit. So I want to know if you ever measured a concave Earth.
Now you all heard that, right? He says
Yeah, that's right. Yeah, that's right. Answer the question. Answer the question.
Right along with the 90.
Answer the question. You're dodging. Answer the question.
What is your question, man?
Have you ever measured converging zenith angles?
No.
Never.
Never.
You're a liar. You're a liar, dude. Why would you do that?
Aaron, he got you.
Well, just the statistical. Look, we know from the variation of just measurement, just the variation. Every once in a while, you're going to get some statistical outlier where you're going to go, holy fuck, where did I get that number? Now, you might not believe that's a valid number, but you did make that measurement. To say you've never got that measurement, you're a liar. You're just a liar, dude. Look, measurement. There's a whole field of measurement called metrology. Okay.
This guy, man.
The techniques you apply weighted your measurements, right? Is that what you use? Do you use weighted means, or you use weighted means or mean values?
So look,
so giggling is not addressing anything I'm saying. Notice how I'm on topic and you guys are all over the place. Use weighted means or mean values.
Indio, while we've got these fellas here, can we ask them actually something
Use
sensible
weighted
about
means
how
or
far
mean
they
values.
use their theodolites and the like? Just so we can
Am I
settle
muted?
other problems?
No, you're not. You're there.
I'm on your side,
Use
man.
weighted means or mean values.
Angles, fucking whatever else you said, I'm with you. I'm down.
Use weighted means or mean values.
All right, hold on. Do you hear what he's saying? Repeat back what he just said.
No, I didn't hear a word he said because it's probably
Use weighted means or mean values.
No, okay. Now you're just being dishonest. So now, can we continue in the conversation, or are we just?
Yeah, no, I was talking to Baron. He knows exactly what I'm talking about if he actually does surveying.
Tyler.
Anyone that collects data from measurement knows exactly what I'm talking about.
Let's figure out who the real fraud here is. Let's get into
Use weighted means or mean values.
Means. Let me talk.
Yeah, when you answer the question.
Let's get
into the question, dude.
And the standard deviation. You want to go over that together?
Yeah, but are they weighted or are they mean values?
Reciprocal zenith angles.
So, according to the standard, measure in the wrong direction, right? Every once in a while. Correct?
What are you talking about?
Every once in a while, you're going to get statistical outliers where you'll measure values that are under what you think you're going to measure.
What are you talking about?
A Gaussian distribution, just measurement, measuring in general. If you take 100 measurements, they're not puts. You're going to have a variation, which usually follows a Gaussian distribution. It's my understanding, and you guys use weighted means, which is a whole nother thing.
Dude, wow.
Don't even know what I'm talking about, do you?
Do you know? Okay. You know what a weighted mean is?
Yes.
What is it? Describe it to me.
I'm the one who brought it up. Why are you interrogating me?
Because
you didn't even answer the question on which one you use. Which one do you use?
Because you're applying it to something that doesn't matter, dude. So
your measurements don't matter.
When you're done describing
good concession.
Describing a weighted mean, you're going to realize, wow, I should be talking about a weighted mean with reciprocal zenith angles now, should I?
No, I should.
No.
Because that means you're going to have statistical outliers, meaning instead of measuring an angle that should be what you think should be 89 degrees, it'll be 91 degrees. Right? And you'll just throw that away because it's a weighted mean, right? So you're throwing away the ones that are way far away from the average measurement. Right?
Okay, weight it. Don't tell me how to weight the mean.
Unbelievable.
Tell me how to even get the mean.
I just want to know is that if you've ever had a statistical outlier that would indicate the Earth is concave. You can't tell the truth about that.
Dude, I'm not interested in your opinions of me, dude. Right?
These are not opinions. These are mathematical facts, dude.
Here's the mathematical fact. The mathematical fact is how do I get the weighted? How do I weight the mean in reciprocal zenith angles? Walk me through that process, please.
Okay, you take a bunch of measurements. Say you take 10 measurements. Now, depending on how you want to do it, let's say you take the top lowest, the highest value and the lowest value, and you throw them out, and then you average the remaining ones. That's a weighted mean.
No, that's incorrect.
Well, that's one way to do it. Tell me I'm incorrect. Does that show I'm incorrect? That's one way to do it. There's other ways to do it.
Okay. Do you know what a weighted mean applies to?
Any types of measurements you want.
No, incorrect.
It can apply to any set of data you want it to apply to.
This guy's fucking out there, bro.
He's spitting, dude. He's cooking.
There's nothing I'm saying which is factually incorrect. All you guys can do is, posture at this point. So why won't you tell the truth that if you did 100 measurements, let's say you did 10,000 measurements, you are going to get occasionally some very weird measurements, right?
Okay,
why can't you admit that?
See, so let's go over this, right? So you said you take the top one and you take the bottom when you throw them out, right? Did you know?
You can do it that way.
Okay, well, a weighted mean assumes that they're all equal.
No.
Okay, dude.
Dude, Baron, you're
What do
getting
you think the weighted part means?
dude.
You treat all
No,
values
what do you think the weighted part means? The weighted part. You're talking about the mean.
way, dude.
That's why I was very specific. You take means or weighted means. So one weighted mean you guys do is that you assume that the Earth is curving. There's a weighted mean.
Oh my god, dude.
And that deviations of numbers outside that value, you throw away. The larger the deviation,
Here's how it
the
actually
less,
works. Yeah, here's how it actually
less
works.
weight you give to it.
Right? I'm gonna tell you how it actually works, right?
Oh,
So what you do is you take all your measurements, right? And the first thing that you do is you take your face left and your face right, you sum them. Okay? Because you're turning the instrument to face right, now you're measuring from 180 to 360. And face left, you're measuring from 0 to 180, right? You add those two together. You hope in a perfect world that they'll add to 360. That's unlikely to happen. So what you do is you find the difference. Let's say you're heavy 2 arc seconds. Let's say you're 360.0002. Okay? You chop that in half and you subtract it from the face left. That is your corrected face left. And you do that to each one of your measurements. Then what you do is you add all of those together and divide by the number of measurements you had. That now becomes your average mean. Then you take either the mean or the corrected zenith angle and subtract them. It doesn't matter if it's a negative number because you're squaring it. You're following that so far?
yeah. So if it is a negative number,
you show me the part.
You wouldn't be able to see it. Is that what you're saying? You wouldn't be able to quantify it because you're squaring it.
Excuse me? I didn't hear you.
If you did measure converging zenith angles, you wouldn't be able to measure it because you're squaring the number. Is that what you're saying?
Why wouldn't? What are you talking about, dude?
You said the negative value. What negative value are you talking about?
When you subtract the corrected angle from the mean, or if you subtract the mean from the corrected angle. If you
The vertical angle, right?
It's irrelevant because you're squaring it. You do understand how math works, right?
Oh, Jesus Christ. Are you talking about the vertical angle?
Dude, I'm
the
telling
zenith
you,
angle?
you still don't get it. Like, you're supposed to be the pro here.
He's just talking about the angle we're measuring, right? And the difference from 360.
Okay. It wasn't clear. Are you talking about the horizontal axis?
You don't have to draw it out. Guys,
I just need you to use words like horizontal or vertical, right? So which one are we talking about? Because I was confused when you said 360. I don't think you're spinning it vertically 360. So.
Oh my God, is this guy fucking serious, dude? He doesn't even understand how this shit works.
Maybe here's an idea.
Just more posturing, dude.
Yeah. Maybe if the guys on the other end,
and you confused an average with a mean. Mean is where 50% of the samples are above and below. Okay, that's a mean. It's not an average.
When you square a negative number,
I'm aware of that.
Will be positive. We understand that, right?
That's fantastic. Great.
Okay.
What's that got to do with what I just said?
He's not.
What does that got to do with the question I just asked? What was the question I just asked? What was the question I just asked you?
We would say nearly done. All right, nearly done.
What was the question I just asked you?
And then you can bring forth all of your.
No, what was the question I just asked you?
He's a fucking mess. What was the question? Sorry.
Yeah, what was the question I just asked you? You guys don't even know. You guys haven't been paying attention the entire time.
Aaron was in the middle of explaining.
I know you have no idea. Because you haven't been listening the entire fucking time. Because you're a bunch of fucking zealots.
A source of entertainment and knowledge for me. So,
yeah, that's what it is. Oh, more posturing.
But as I was saying,
more ass covering.
Baron Baron, the person who's giving you so much free knowledge that you would normally have
He's not anything. He can
he's
barely
not giving
fucking
knowledge.
elucidate what he's talking about.
Hey, Neil, can you inform your little friend on the other end to shut up?
The host have to step in for some fucking reason. Just
He
let
can
Baron
barely elucidate what he's talking about.
guys can do this.
He's the host, so
It's a horrible host.
that's okay. You're doing good, host. I like you.
Fuck you, Neil.
Well, the issue we've got, Neil, is the whole time Indio's been trying to talk, he's been yapping at the other side. And then they complain
all
that
I
they
know
don't...
is I just want the answer to one question. Have you ever had a frickin', have you ever measured, had a measurement?
360 happening.
Holy
360 on what axis?
I don't see how
HOV, dude.
even makes
Why do you have to think about this?
is. Are you measuring the sky?
My God.
So look.
My God,
Okay,
dude.
for the guy that's at the other end,
You gotta be
the reason
fucking
we
kidding
don't
me.
know which axis is because you have been speaking through our speaker. So it's just all garble at this end.
Oh my goodness, Neil, I like you too.
I
Your
like you,
friends are
bro.
much idiots.
No, I think
You're dumb. I'm a one-trick pony. I just say you're dumb over and over again.
They're not able to
Say
see.
something original, dude.
The sound will do us justice. Hey,
Say
This
something
car-
original. You're
What are those?
done. You're dumb. That's all I can say. You don't understand. You're dumb.
This is a wash.
All right. So, are we gonna continue with the conversation? If not, I'm gonna have to
This fool, man.
leave. You know what I'm saying?
man, that's up to you. This conversation has gone nowhere in the past hour. This is
All
just
right.
kind
Yeah,
of
you guys need to go research what I said. Flat Earthers don't do research. No, you guys don't. You
I
guys
give it
don't
one.
research.
I give it one more shot. If you want to continue, we can continue from now. If not, we can have closing statements.
Is it? I'm totally
Is
good
it
with
still just about entertainment?
angles. I'm totally fine with that. I've got probably 100 of them that I've made. So
What is he talking about? Reciprocating penis angles?
to let us know how it works, man, I'm all ears, dude.
Oh, what a load of shit. You haven't been listening for the last
Okay.
half an hour.
Okay. All right. Okay. Sorry. I'm sorry. Okay. All right. We'll continue. No. It's okay. We'll be cordial.
He said he's all ears. That's quaint, dude.
All right.
He's Australian. That is being cordial. For
It
him,
is.
man.
It
That's
is.
good.
I know.
Like that.
I know. It's cool. It's cool.
So look, I know he can't see, but for everyone that's watching,
This is the good guy, by the way.
we're measuring in the vertical, right? The vertical, the up and down here, right? And when we're talking about 360 degrees with the theodolite, this
What? Vertical or horizontal?
for those that can't see, right?
Yeah,
So what do you-
vertical, horizontal. I just need you to answer that question. 360 degrees, vertically or horizontally?
Vertically.
Okay.
Both, Mike. Both.
I don't know why it took 30 minutes to get the answer to that.
180 degrees, and you turn the instrument 180 degrees. So if I'm in face left, in face left, I'm measuring from 0, which is straight above my head, to 180, which is directly below my feet.
Right.
Then if I turn the instrument face right and plunge the eyepiece, I'm now measuring from 180 to 360.
Right, which is like this, just so you guys know. So what we do is we flip the instrument, right? So let's just say I'm looking perfectly horizontal 90 degrees. It would look something like this, and this is face left.
If you went into face right, it'd be 270.
So let's just say I got a target that's 30 miles. It's 90 degrees. It measures 90 degree angle, and then I want to make sure that I'm getting an accurate measurement. So I turn the instrument, and I do it again.
You plunge the eyepiece, and now you'd hit a 270.
So if I have a perfect measurement, I add those two measurements, and I should get 360 degrees. But here's the problem. I'm a human, so there's going to be error. There's stuff going on in the atmosphere, and then there's stuff going on with the instrument. So we figure out how much error there is, and we take that difference and we cut it in half. Okay?
How would you know what the error is?
Add it or subtract it to your face left, depending on what the summed angles were.
Yeah, so if we're fatter than 360, we subtract it. If we're less than 360, we add half of the error.
Right, and then what you do is you add all those corrected face left values and divide by the number of measurements you took, and that's the mean. That is the mean. Then what you do is you take the mean, or you take the corrected angle, regardless of how you do it, and you subtract one from the other. You square that result. So the positive or negative integer is irrelevant at this point because you're squaring that result. Then what's the next step, Mike? You know it pretty well, right?
I'm drinking. It's been a while.
Okay.
Let's see. So you divide by the number of face left, face right measurements, and you have an average mean, right?
Correct. And then you take the corrected face left, you subtract it from the mean. You square that result. Okay. You take all those square results and you do what?
Our results.
Those are your residuals. That's the V inside the standard deviation equation.
Yeah, it's been
you add them together. You add them together and you take the square root of it.
Yeah, I don't remember, to be honest with you. I've done it like,
and that right there is the standard deviation. If you want the standard error from the mean, which is the most important number, you take the square of the number of measurements you took and divide it into the standard deviation, and that's your standard error from the mean. That tells you the grouping of your arrows, how tight your arrows are. So like if you've got 5 arrows and you've got a bullseye, and you shoot those 5 arrows, how close are you to the bullseye? But how tight are your arrows together? So my question is, with that process, if I were to weight that process, how would you go about doing it? Because he's saying it applies to every measurement. I'm disagreeing with him. This is his opportunity to tell me how he would do it differently, and not only do it differently, but then also get the result of a flat Earth.
First of all, I didn't say it applies to each individual measurement, if that's what you're implying.
Oh, I thought you said it applies to every measurement.
No, weighted mean, you throw out the statistical outliers, right? The outliers. Like say, like most of your values are clustered between 5 and 8, right? Say most of your measurements are clustered between 5 and 8. You have a -1 and a 12. You know those have to be some sort of error, so you throw them away, and then take the mean of the essential values.
But why would you?
Because a mean is the number of samples that are 50% above and 50% below. I think you're confusing an average with mean. So 50% of the samples on a mean will be above the value, and 50% of the samples will be below the value. That is not necessarily true for an average. They'll be close, but they won't be the same.
Means average, right?
No,
mean does not mean average.
In mode.
It's called the arithmetic mean.
He's conflating mean, median, and mode to be all the same thing.
That's why you said throw out the outliers and remens and find the middle value. I kind of clocked that earlier, but I wanted to let it go because they're getting mad at me.
Regardless,
guys, maybe we're just outclassed here.
The central question wasn't answered.
The Earth measures flat, obviously, right? We got it all wrong.
Well, yeah, that's right. Which is why you need a reference ellipsoid.
Right.
That's why you need a reference ellipsoid.
10 years.
If the Earth didn't measure flat, you wouldn't need it.
So with their 10 years of
you know what the theorem of Grigium is?
With their 10
theorem
years
of Grigium was Gauss's seminal work on mapping one surface to another surface.
What? No, Mike. Let's hear this. This is my wheelhouse.
So you can map any surface to any other surface. You're aware of that?
No, that's not true.
that you can't map one surface to another surface?
Correct.
Okay, how is that not true?
Because
Because you have to
geometrically,
hold features. You have to either sacrifice. So what? Let me ask you
I
this.
didn't say, look, it will map. I didn't say it will map distortionless. I didn't say it would be fucking invariant under transformation. I didn't claim that. Okay. But you can map any surface to any other surface. You're gonna lose you might lose information. You might introduce distortions.
You cannot show the entire Earth, the globe, on a flat map.
Through projection, you're correct.
no, it can't be represented two-dimensionally. It doesn't work.
Through projection, that is correct. You know, there's a difference between a projection and a map, right?
No. Like taking the known locations of places and the known sizes.
The known location. How are those known?
Yes, by measuring the distance, and then
by measuring the distance. Okay, here's your
Yeah.
challenge. Who measured 69 miles per
People
degree?
measure these. Okay.
Yeah,
So
who
you're just
measured
throwing shit.
69
This is
miles
not good
per
faith.
degree?
It's
Who
not good
measured
faith.
69 miles per degree?
Surveyors.
Okay, show us. Actual measurement of 69-mile measurement baseline and 1 degree of tilt of some star.
Has he ever pulled up the triangulation data just for his state?
Yeah. Okay, cool story, dude. That's not a measurement. The longest baseline measurement that I could ever find was 7 miles. So no one's ever measured 69 miles per degree. It's hypothesis.
Ever triangulated is from
Oh my God.
Mount St. Helena to Mount Shasta. So I don't know what you're talking about.
No, I'm talking about the longest surface baseline.
Yes.
Okay, you're postulating that if you're assuming a globe, you're presupposing there's some arc length between those two distances.
Globe, dude. Why can't we just assume a flat Earth since that has so much power in this conversation? Let's just assume flat Earth and then go out and measure it and see what happens.
You do measure it right now.
I'm not getting a flat Earth, dude, is what I'm telling you. You might be getting a flat Earth.
Then what's your reference ellipsoid for?
What's my what?
What's the reference ellipsoid for if you're measuring a globe? If you didn't use the reference ellipsoid, what would you map? What would it look like?
Oh my God, dude, so that we can get height above and below sea level, dude.
This all started from reciprocal zenith angles, by the way. I don't see how any of this shit is relevant.
Yeah, of course you don't. Because
the reference ellipsoid is strictly for elevation purposes only. That's it.
The reference ellipsoid is strictly for elevation purposes only.
Sea level and the geoid. That's all it is. It's a modeled gravity. That's all it is.
That's the geoid is the model of gravity. The reference ellipsoid is where you're mapping your points to.
Dude, I really think that what you should do, is you should take a class. I know that you can go on I think
shut up, dude.
Posturing is sickening, dude. Utterly revolting. You're the one who said curvature of the plumb line doesn't exist. So I'm going to give you citations that show it does.
All right.
Featherstone, Southeast Asian Surveyors Congress, use and abuse of vertical deflections. Proceeding of the 6th Southeast Asian Surveyors Congress. What is it? Fremonte, November 1999. There's a specific part in it called curvature of the plumb line. As stated, deflection of the vertical changes with position along the curved plumb line. Therefore, the deflection of the vertical in the geoid does not necessarily equal that at the Earth's surface or vice versa. In order to equal the two quantities, the curvature of the plumb line between the geoid and the Earth's surface is required. The quantity cannot be observed directly because of this, what did that say? Presence of topography. It must be estimated using a model of the Earth's gravity.
Sure we're on the same page here.
You had to talk over me the entire time because you're a fucking coward.
I'm a coward.
You talked over me the entire time because you're a fucking coward and don't want anybody to hear that this motherfucker was wrong.
Indio, he hasn't listened to a word you've said, dude. This
I know
guy's
he
just
hasn't.
monologuing like a motherfucker, man. He thinks he's all that. He just won't fucking listen.
Do you
Like, this is a
agree with the
useless
first sentence?
conversation, dude. Let's
Evaluation.
sit the fuck down,
Okay,
man.
so here's another citation. Peng Shuang Hung, evaluation of the plumb line curvature, effect on the deflection of the vertical, 1986, Department of Geodesy and Geomatics Engineering, University of New Brunswick, Fredericton, New Brunswick, Canada. As stated, the deflection of the vertical. So you try, look, you want a posture that I don't know what I'm talking about. That's great.
Do you agree?
Oh, shut up, dude. Fucking this Andy hold my fucking beer.
Do you agree with their findings? Yes or no?
Yep, we couldn't hear your findings because you decided to present them through Indio speaking. Thank you.
Do you? I'm sure I've heard it. Do you agree with their findings based on even just the first sentence you said? Do you agree with it? Yes or no?
What was the
what? I
first
don't know what
sen-
their findings
What was the
are.
first sentence that he said, dude?
There's a difference between vertical and plumb.
Well, there's a difference between zenith and plumb.
And what is that caused by?
What do you mean, what's that caused by?
What causes that to happen?
It's a conceptual difference. Whether there's a physical difference, I don't agree with.
Oh my fucking god! So what's the point of this conversation?
Because it's in the globe. It's your idea.
Argue the point
Curvature of the curvature of the plumb line is your idea. It's the idea you've adopted. This isn't my idea.
Neil,
you think it's still? This is something I run into with talking about this topic. When I talk about curvature of the plumb line, they think it's flat Earth made up bullshit. No, it's globe Earth made up bullshit.
No one thinks it's made up. You just don't know what the fuck you're talking about.
Correct. He doesn't understand it, right? That's the problem, dude.
I fully
right back to the shtick. Right back to the posturing. You don't understand.
That's it.
Yeah, because you can't refute what I'm saying at all. You said nothing of substance.
You're agreeing that gravity fucking exists.
So guys, he kind of reminds
me. Look, things fall. That exists.
You don't even
that
realize
falling,
that you're saying
the thing that causes the falling doesn't cause the Earth to be a ball.
Between plumb and vertical, based on the gravitational vector. Holy shit! You are walking yourself into a corner and don't even realize it.
There's a difference between plumb and vertical. What's the difference?
I realize that these are the people.
What's the difference?
No, I'm not
right back to the ad hom shit.
I'm not gonna let that happen. No.
Ridiculous.
No, okay.
Yeah, right back to the ad hom shit. Can you
These guys
explain
don't-
to the audience what's the difference between plumb and vertical?
Yeah, tell us.
I got kicked.
I'm interested.
Oh, you're kicked?
Yeah.
Oh my.
Those guys don't. Those guys don't understand what a hostile witness is and an internal critique, right? They have no idea what you were trying to get at.
That's why Globe Man wins all of his arguments, because he just keeps rattling on, driving through people. He's one of the morons that's on Facebook, that's in one of the channels, that just keeps driving and driving and driving, puts his fingers in his ears, and basically just keeps hammering through.
Yeah. Well, I'm glad I at least maybe they could heard of him over talking. I got that shit out about curvature of the plumb line. That Baron Rutledge is like one of their gods. I've talked to him before. He must not remember. Or he did remember, and he was like, shit. I talked to him on Twitter before, on X Space. But I love how he denied that it even exists.
Someone brought up Baron Rutledge the other day.
Curved plumb lines. I don't believe in that shit. The fucking plumb and vertical are the same to me. I know how to build a building.
These reciprocating zenith angles, like the distances that they're doing, the curvature is so small, and they have errors both ways, plus and minus. Like, how the fuck can they be so positive that this is the right answer, right? And never mind the error margin on their tools, you know, like, and if they do a larger distance, then the error margin's fucking way out of whack too. Like, it just doesn't make any sense how they can say this is the way it is.
That's why I specifically asked him if he ever got a measurement that would have indicated a concave Earth, and he said no. And as soon as he said that, I know he's lying. I know 100% fact he's lying. Because you're going to get measurements that are all over the place depending on the meteorological conditions. All the data shows that if you look at any testing of surveying for refraction or anything, it shows pluses and minuses.
Fluctuation.
Like
I wanted
so
to
the one they
ask him
like to
about that
show all the
actually, and I didn't
time.
get a chance.
Yeah, one like they like to show all the
wanted to
time
see their data set.
is the reciprocal zenith angle one. It is a paper, and in that it says, the published review, the literature says angles of plus or minus k, plus or minus 20K. That means they're measuring concave according to them, or convex according to them, and concave. So for him to say that he's never measured that, he's lying. He's just lying.
Well, did you hear them when they first started out? Like they're basically saying that when they don't understand what these flat earthers are on about with their observations and measurements, because when they go out with their P900s, P1000s, and theodolites, they bat 1,000 for the globe, right? And that's where it all started. Like basically, we got into it.
They're like Jesse.
Yeah, exactly. That's what I said in the side chat. They're just like they're Jesse duplicates, but a little less polite. And I mean, I wanted to see that, like, ask them about their data set. What's the minimum, the maximum with their angles that they've ever recorded? Like, how far under or over the globe did it go? All that. But never got there. But yeah, they could not understand your internal critique of deflection of the plumb, and that guy mistook you talking about it for you accepting it to be true when you were actually using it as a hostile witness against them.
Yeah, I definitely don't believe in that. I don't believe in that nonsense. I don't believe in tilted gravity. I don't believe in lumpy gravity. I don't believe in any of that stuff.
I just think that it's funny that that's all that it took for him to spiral out was curved plumb line.
I can't believe they lasted that long, quite honestly. They hate that.
Fair enough.
It's hilarious. They're praising
They have
me.
to adopt it. They have to accept it.
Yeah,
they literally have to accept it because it's part of the geoid. So if you don't to throw out curved plumb lines, you have to throw out the geoid, and then you have to throw out the reference ellipsoid. That's why I always get to, what's the reference ellipsoid for? Like, what do you need it for in the first place? So if you, I'm trying to get them to throw out all that stuff, and then okay, now show me your measuring curvature with no ellipsoid, with no geoid, with no presumed globe. Now show me, and they can't.
Well, they start with a radius. They admitted that, and I called them out on begging the question, but
yeah, there you go.
Fell on deaf ears.
No, they don't care about that. Begging the question, we do that twice a day.
I got a question for the room. What is the consensus among flat Earth people for the trip to the moon that recently happened?
Who cares?
Well, I'm curious of your perspective.
Dude.
Why don't you run a poll?
The topic isn't flat earthers, dude.
Are we not in 24/7 flat Earth?
Yeah, but not 24/7 flat Earth, not 24/7
yeah,
flat
so
earthers.
I'm just curious of what you guys thought about the trip to the moon recently.
24/7 flat earthers.
Does the title of the room say 24/7 moontards?
Yeah, moontards. Yeah, 24/7 moontards. Yeah, I'm for that.
Well, do you think
he already gave you your answer? Would you like to repeat himself a third time?
Why would I believe that shit? Give me one good reason.
No, I'm not saying whether you believe it. I'm not saying whether you believe it. I'm just saying what you think happened.
No,
do you think it's a conspiracy? Do you think it's all
independent?
psyop?
Independently, bro, of being a flat or globe. Give him a reason to believe it.
I'm not asking him to believe it. I'm just asking you guys what you believe.
Are you asking us to speculate?
What do you believe?
Yeah, I'm asking you what you believe.
Well,
no, thank you.
I don't look. It's just noise, as far as I'm concerned. There's nothing to
like,
believe.
was
It's
it
just a
like a
TV show. It's like
government
the Kardashians.
conspiracy, or was it like,
No,
did
it's
it
just like
happen
the
or did it not
Kardashians.
happen?
It's just
Or
nobody went to the moon. A rocket took off in Florida, yes. The rest of the shit's fiction.
oh, so okay, so a rocket took off. Where
Yeah.
did the rocket go?
Out of sight.
So did it drop below the edge of the flat Earth, and that's where it
What
went out of
edge?
sight? Or
What edge?
Bro, you're just way
I have no idea. I'm asking you,
Who
man.
thinks
You
there's
tell
an
me.
edge? No flat earther thinks there's an
I
edge
don't
to
know
the
what
flat
you
Earth.
believe. I'm asking you.
I know, dude. So why don't
That's
So
spill
why
your own
won't
beans?
you tell me what you believe? What?
Something went
You
up and
didn't
came
ask me.
down.
You asked me about the moon.
Yeah,
cares?
and
Now,
what
let me ask
do
you
you
this.
believe happened
Look,
surrounding this event?
I don't believe anything. I don't believe it. Do you understand?
Okay, when I say believe, I mean what is your narrative surrounding what happened?
I don't have a narrative. There's people in Florida. They saw a rocket launch. They showed a bunch of imagery on a fucking screen.
So it was an elaborate government staged conspiracy?
I don't
How did
consider
you
that
get
elaborate.
all that
It was a
out of
screen.
what he just
Well,
said?
I'm just asking because I don't know
Holy
where.
shitballs.
Like, why would they do that?
Yeah, he's got a
I don't
problem. with
know.
why would
Incredulity
they,
is not an argument. Your
So you'd have
understanding is
zero
not
beliefs on
required.
any. It's just nothing.
Why
Nothing
should
at
I
all.
believe it? That's why I started there. Why should I believe it?
No. What do you think happened?
I don't really have an opinion. It's a TV show to me, the same as the Kardashians. What don't you understand? It's a fucking TV show. It's just like watching the fucking movie
So
Gravity
did a
or
rocket take off?
watching
Yes or
the
no?
Avengers or something like that.
So you're
Did a rocket?
realize you're listing works of fiction rather than say documentary, because a TV show can be a documentary, and documentaries are factual.
Don't. That's something different. Don't worry
Documentaries
about
are
that.
factual. Why? Because they said so?
I'm just. I want to know what you believe, man. I just don't understand why that's
You're
difficult
the
to
one
answer.
with the beliefs, dude. Not me. You have beliefs. You believe there's some people that they jumped in a rocket and flew to the moon and flew around
I
it.
didn't say
and then
that.
came
I
back,
haven't put
and
forward
then,
a case
and
one
then
way or
waved
another.
and then shook hands, and you believe all that shit. I don't believe.
I haven't put
So-
forward a case one way or another. I could be a flat earther. I'm just asking
I
your
mean, you
opinion
could
of
be,
what you
but,
think happened.
I mean, believing in the
Definitely not a
moon
flat earther.
landing and being a flat earther are not mutual exclusive things. There's plenty
Like,
of globe
for
guards that
example,
don't
if I was
believe in
to
the
ask
moon
someone
landing.
about, say, 9/11, I go, what do you think happened? There'll be a bunch of
What
people
in
that'll
a
go, you know what,
non
9/11,
sequitur?
that was a government inside job, right?
That's
They'll
a
say
perfect
that.
example of a non
So what
sequitur.
is your perception of the rocket launch recently?
It was a look. I can't. Nobody can tell the difference between, say, an intermediate range ballistic missile and a
I'm not
rocket going to
asking what
space.
nobody
What
else
do
can
you
believe.
think
I'm
they?
asking what you believe, bro.
Look, no, I'm talking to you what they know. Talk about what they
I'm not
believe.
asking about what others know or what others believe. I'm asking what you believe.
I told you what I believe. It's a TV show. This is it, like ask, ignore, repeat shit.
So
tell me what I said. Tell me
it
what my
was-
answer
so
was.
basically
Tell me
it
what
was
my
no
answer
different
was.
than-
No, tell me what my answer was. Verbatim.
So a TV show. So who was the producers
NASA.
that set it up? And who are the
NASA.
actors?
The
The
astronauts.
astronauts.
Okay, so who's the producer?
NASA. Dude, what are you doing with the ask, ignore, repeat shit? You asked the question,
Sorry, say
I
again?
answered, and then you ignored it and repeated it.
This guy's literally actively strawman farming.
Because you can
Who owns
elaborate
the world's
further.
largest
When you say
green screen in
TV
the world? Let me
show,
ask you this.
when you say TV show, do you mean it was like a reality TV documentary, or do you mean it was like Game of Thrones?
Bro, do you know anything about the Earth?
Dude, it's just video on a screen, dude, that people represented to mean one thing. In no
So,
way.
but was it
can
it entirely fictional? The rocket.
Yes. Other than
So
the
there was
launch
no
part, when
rocket.
people
Is
saw.
that what you're saying? There was no rocket.
No, I already covered
that's
that.
what he's saying. There was a rocket.
Ask, ignore, repeat for the third fucking time. Do it again and see what happens. Really, do it again and see what happens, dude.
Okay.
So I'm
So
going to
was
answer
the
you
rocket real or
again for
not?
the third fucking time. People saw the rocket launch. They did not see the rocket go to space. That's impossible.
Okay, so
They will see
there
the
was a
rocket
real
take
rocket.
shut up.
Okay.
They will see the rocket take a parabolic arc and go out of sight. It's the same for any rocket that goes further than 300 miles. They will all look identical because they're ballistic. Okay? You know how that works?
Sure.
Okay. So from the ground, people, yes, they saw a rocket. They have no way to tell from the ground where it went. The rest of that shit after that, the rocket launch, the rest is shit you're showing on the screen. Right?
Sure. Okay. You're
So
answering
the
what you
rest
believe
is
now. Cool.
so the only real part is the rocket launch. The rest is just story
Okay.
time TV show. NASA, you might not know this, NASA owns the largest green screen studio in the world. In the world.
So
They
when the
rent it
rocket
out
went
to
out of sight,
Hollywood.
did it go to space or not?
No. Nothing
And were
goes
there
to
astronauts
space.
on the rocket ship?
There are no astronauts. Look, astronauts don't
So
exist.
the rocket was
There is
real,
no
but it
outer
was an
space.
empty rocket.
Nobody's going to the moon. Do you understand all that?
Was it an empty rocket or did it have people on it?
Oh my God. How would I know that?
Ridiculous question.
I'm asking you. I'm asking you
So,
what you believe in.
hey, Ziptard, he just said the rocket went out of sight, and then you're asking him what the rocket did when it went out of sight.
You don't know-
Hello? You're not very
Exactly.
fast, are you?
Yeah. But you can still say whether you believe it went this direction or not, okay? And when the direction is space, did it reach it or not?
At least we're agreed.
So
they're not that
would
fast.
go into
Beliefs is
orbit.
you. You're defending someone else's claim, carrying their fucking water for why? Why are you carrying water for fucking complete strangers that told you some fucking story about going to the
I haven't
moon?
even told you what I believe, man. I'm asking you what you
We
believe.
know what you believe, dude.
I'm just asking you
Stop
what
being
you
a
believe. I'm
fucking
trying to
coward.
get your opinion, your perspective.
Nah, you're just
I
a
don't
coward,
know. I am
dude.
so far out the realm of where you guys
You're
normally
just a
are. You
coward,
believe all
dude.
completely different stuff to what we do. So
Yeah,
I'm
you're
just
just a
curious
coward.
as to what your opinions are.
I haven't
Proselytize
formed
me.
an opinion about it.
Convince
It's
me.
just a TV show. It's like the Kardashians. I'm gonna say it again, dude.
So the rocket was real, but it was empty. It went out of sight, but
Whether it
not
was empty or not
necessarily
is
to
irrelevant,
space.
dude.
He already told
Like-
you he doesn't care.
What part of that
It
don't
doesn't
you
matter.
understand, dude?
What's it like? What does it matter if there's people in it or not? It's irrelevant.
Why are you
'Cause
trying to
I'm
force
curious
people to
as to
tell
what
you a
you believe
story?
happened.
And if they won't tell you a story,
Why
you're
do we
just
have
going
to
to take
believe
everything out of
anything?
context.
Dude, why do we
he's
have to
told
believe
you.
anything?
You don't have
Why
to
do you
believe
feel
anything.
Told you
compelled
3 times
to either
now, dude.
believe it? Well, I don't understand why you feel compelled to believe it or not.
What's
Why
your
do you have to take
opinion? Gets really angry about that question
Why
for
do you
some
have to
reason.
take any
Why?
position? Because you're trying to force a position on us that we
I'm
don't
not trying
have.
to avoid. There's
I
no
don't
trap here,
care
man.
about it. I
There's
don't
no
care
trap
about it.
here.
People
You're
like
paranoid
you
that I'm trying to
care
fucking trick
about it.
you. Like, what the hell's
I
happening?
don't. Look, brother. I don't care about it. People like
That's
you
my
care
answer.
about it.
That's my answer too. And when India originally said "Who cares?" spot on. Who cares?
I said, who cares? We don't care. It's a fucking story. It's just noise. It's media noise, dude. You saw some signal in the noise, and you're like, I'm gonna latch on to that fucking moon story signal. And I'm gonna fucking go into Flat Earth Discord and defend it.
No, you're reaching here a little bit.
No, it's
I'm
reaching,
literally.
dude.
I do
fucking
not
dead on
understand because
target.
I like defending things that I believe in. I don't understand why you're having such a hard time with it. But all right, have fun. See ya.
having a hard time. Like, I don't know why you believe in it. You can't even defend why you believe it.
He left just like that.
He ran like a little bitch.
Well, that's
He
what
should have
they
got
are.
on his case, man.
He did. That's why he left.
Dude, his girl was there. He just took that beating right in front of her.
Little soy boy
Get his
act.
clock number.
Jeez.
I at least say I believe it because I think NASA's credible, so I own up to believing it.
Really?
You think they're credible, Matthew?
How'd you do that evaluation?
It's not a big stretch if you think the Earth is a globe.
You know,
Sounds
the
a little
Earth could be a
circular.
globe and they could be liars too, you know.
Exactly.
Yeah, that's true. In fact, I have a friend who thinks the Earth is a globe, but he doesn't think the moon landing's real. There's quite a few of those.
Well, NASA's beginning is kind of unsavory. You know that, right? You have heard Yoda quote the documentation of formation and why NASA was formed, and that was
It was a
purely
bunch
like
of
for
bunch of
propaganda
Nazis or
reasons.
something, right?
Like, say that again, Matt.
It was founded with a bunch of World War II Nazis in it. Is that what you mean?
Well, no. That the purpose of it being formed was propaganda, is to project the idea that the United States was technologically superior, so no one would oppose us.
Yeah, I don't know about that. I mean, that might be part of the reason. It
It's
was
right from
it
the
was
National Archive and shit. I probably got it right here. So I asked him for it, and he sent me a whole bunch of them. Right, I wanted them right for moments just like this.
If you
Preliminary
think the
U.S.
Earth is
policy
flat,
on
you're
outer
retarded.
space. Find the right one. This policy is concerned with U.S. interests in scientific, civil, military, and political activities related to outer space. It deals with sounding rockets, Earth satellites, and other space vehicles, the relationship to the exploration and use of outer space, and their political and psychological significance. All the relation between outer space talk. This isn't the right one. The significance of outer space to U.S. security. Outer space presents a new and imposing challenge, although the full potentialities and significance of outer space remain largely to be explored. It is already clear that there are important scientific, civil, military, and political implications for the national security, including the psychological impact of outer space activities, which is of broad significance
What are you
to
talking
national
about, though?
prestige.
Low key, he cooked.
What is bro talking about?
the founding of
Formation of
NASA.
NASA, but that isn't even the right document. The Psychological Coordinating Board, PSYOPs, Covert Action. I have freaking so many documents that Yoda sent me. I haven't had a chance to look through them all. But he's quoted this before in this chat. I think what you hear that says the purpose is to project power and control so that no one will oppose the United States.
Well, yeah, I wouldn't deny that that's part of it, but you just read several other things, to have
That
dominance
was
in
not a
space and
classified
all those.
document. That was just U.S. policy paper.
Dude, what are you talking about?
NASA.
Why NASA was founded.
Why not like the formation? Yeah, well, its formation. Why it was formed in the first place? God damn it!
The guy who was speaking out, do you know why?
Yeah, to
The guy that was
project
asking, the guy that was
power and
asking about
control.
what we're talking about and interrupting the conversation. You know why NASA was formed?
Project power. Just if I take them at
I
their word,
I got
project
you.
power and control.
I was just
Yes,
thinking of this other-
inform me.
He just did, dude. Fuck, you weren't
Wait,
listening.
I froze. Can you say it one more time?
Yeah.
The directive establishing the Psychological Strategy Board. This is the genesis of NASA. Let me read this. September 1953, Eisenhower reorganized and renamed the Psychological Strategy Board to a Blander Boring Operations Coordinating Board under Executive Order 10483. Later in 1957, it came Executive Order 10700, which made the OCB part of the National Security Council, integrating it into the national security framework.
India, what is your ethos? What is your ethos, dude?
Bro, what are you here for?
Christianity.
Hey, Fufu, what are you here for, dude?
I'm here to learn.
Are you a glober?
You're here to troll.
Yeah. Do you think you live on a globe?
Of course.
Do you have
Why?
any evidence of a globe?
Yeah, when I look into the horizon, I can't see all the way because it's the
See,
Earth is round.
Bro,
yeah,
are you dumb, bro?
that's the reason.
Bro, are you dumb? There's a lot of reasons why you can't see the flat Earth as you should.
Do you think if you stood on top of an infinite checkerboard, you're going to see every square?
Yes.
Exactly.
Dude, then you're retarded.
Yeah, then you're retarded, bro.
These guys are together, obviously.
Obviously, freaking goddamn inbred Jeds. So why do you think the Earth's the globe again? Because that reason you just gave was horrible.
Gravity, bro.
Did they already leave? They'll stay in power.
What about gravity for a flat Earth? How does that work?
Makes things
What's
flat.
gravity?
We're happy with that.
What's gravity, dude? What do you mean by that?
How are we all standing on the Earth?
What should we be doing if there was no gravity?
You'd be floating around and shit.
Well, why don't we float around?
Because there's gravity.
Oh. So gravity's the effect, right?
The effect of
Yeah, well,
two
like drop
objects pulling
something,
on
watch
each
it
other,
fall, that's gravity.
because it's going towards the center of the Earth.
Okay, so that cause, is that gravity? Is the cause or the effect of gravity? Which one?
Gravity is the force that's pulling it towards the Earth.
Yeah, that's not answering my question. Is gravity the cause or the effect, brother?
It's not a cause-effect relationship. It's you're getting pulled
It's
towards
not
the
a
Earth.
cause-effect relationship? Really? So a phenomenon without a cause-effect relationship, really?
You have two large
That fucking
masses that are gonna
plonger.
pull each other to each other,
Yeah, that's your theory.
because that's what happens.
Okay, do you have evidence for that's what happens? That the reason things fall is because things are getting pulled toward each other?
Yes.
Okay, let's hear it.
When
Experiment.
you know Newton, he saw an apple fall towards
Jesus
the Earth,
Christ.
and then that's because it's falling towards the center of the Earth.
Yeah, that's your claim, dude. You're just repeating the same claim. I asked for the experiment.
Then what's your reasoning for us?
I don't
being
need an
up there?
alternative hypothesis, dude. You just need to support yours.
You do need it. You need something to
So
prove
your
that
story's
we're standing
true
on
if
the
I
Earth.
don't come up with a different story, even though your
Is your
story has no
story
evidence.
true?
Your story has no evidence.
Neither does yours.
I don't have a story. I don't think there's upside down people. You do.
What do you mean upside down people?
You think you live on a ball and there's people upside down.
They're not upside down. They're standing on the ball.
Bro,
Yeah,
that's-
upside
that's
down
low
from
key-
you.
That's low-key a really selfish thing to think about.
There's no reference of upside down because not everything's on one
Look.
plane. They're on a ball.
Look, T-Dub and Van Hammer are down under, as they call it, right? Are they upside down relative to you?
Sure.
Yeah, upside down people.
Okay.
So you
And
think there's upside down people.
And
We don't need upside down people. We don't need that. We don't need everything gets pulled to the center. We don't need all that because we don't think there's
Right.
upside down people.
We're both the right way up, parallel with one another.
That guy's from England, bro. That guy is 100% not from America.
Me, from England.
It's Australia, bro.
What sounds crazier, that we're parallel when we're standing vertically, or that we're antipodal to one another?
That we're
What sounds more ridiculous? Yeah.
The antipodal sounds more ridiculous.
Us being on the same, everyone
Thank you,
on
Matthew.
the entire Earth being on the same plane sounds more ridiculous.
Does this sound ridiculous too? Let me ask you, how ridiculous does this sound? The Earth looks flat because it is flat.
Where does it look flat,
The ocean.
bro? Oh my god! When you're standing on a really big object, a surface, you know what a derivative
So it
is?
sounds ridiculous. Is that what you're
Have you-
saying?
wait, have we gotten this far into math? We know what a derivative is.
Yeah, dude.
So we know
yeah,
how
dude.
the slope at a very small point just looks like a flat line on a curve.
You don't live on. It's supposed to be
like
an
that.
exponential curve, not a slope, dude.
Yeah, it's considered a slope when you're taking two infinitely close points. So when you're so close together on such a big scale, it looks like it's flat.
So is that what you're telling yourself? That's the reason it looks flat,
saying
not
the
be.
Earth is
So
such
I
a
just
big
want to get straight.
sphere.
I don't want to straw man your position. Earth is so big it looks flat, as opposed to it looks flat because it is flat.
At the point you're standing on, you're
Yeah,
so
I hear
small
your
compared to the Earth.
rationalization on why it looks flat
It is
and
so
it
much
doesn't
bigger. It
isn't
looks
act.
flat.
Look, brother, I heard your entire rationalization. I've heard it hundreds of times. You think that it's a very small curving, that the curve is very small and it looks flat, but it's not flat. And that looking flat is some sort of optical illusion. In that looking flat because it is flat, it's ridiculous. You could have just said, yes, I think that's ridiculous.
It's not
Because I can imagine being on a giant ball that looks flat.
Wait, how big do you think the flat Earth is?
I mean, how big's your
feel
mom?
I feel like that has an important part to play because,
Not yet.
well, I don't know what that means, but I'm gonna continue on. I think it has an important part to play because, like, there's a thing called, or I think I've learned this. It's called relativity. So basically, like,
Please don't, dude.
You
If you don't
know,
know
like-
anything about it, don't bring it up. You
Yeah,
obviously
please don't mention a scientific model which disproves my flat Earth. Please don't, dude. Please.
How does relativity?
Want him? You came back for fucking to rage quit again? Anyway, Ryan.
I didn't rage
What's
quit. You
more
did.
reasonable? The Earth looks flat because it is flat, or it looks flat because I can imagine it just being a giant ball?
Local linearity and calculus is what he was getting
That's
to.
cool.
You cut
That's
him off.
imagination.
It looks flat because it's a giant ball you're standing on.
You think that's more rational than it looks flat because it is flat?
Absolutely.
So, Ryan.
And there you have it, folks. The mind of a Glober.
So,
right
whilst
there.
you're thinking along those lines, Ryan, the next time a Glober
Fucking
comes in there and
crackhead.
says, I see ships going over the horizon, can you inform them that this is most incorrect, that it's so biggy that it's flatty?
It might just be like the language barrier from Australian to English, but I didn't get all of that there.
I didn't get all that. Yeah. Next time a Glober comes in and says, I see ships go over the horizon, can you tell them they fucked up?
No, because the ship went over the horizon.
So it's not so big that it's flat then.
Wait, is it true that all Australian
got
people
you, bitch.
are like Great Britain's prisoners?
A dumb fuck.
Wait. So like, how
It's
would
so big that it looks flat, but at only 10 miles, an object 66 foot is completely hidden from the Earth curvature. Oh, cool story, bro.
So how would magnets work in a flat Earth?
So I'm going to go to another subject because I just got wrecked.
No. I'm just asking other questions.
What do
I'm
magnets
curious
have to
about
do with a
these.
flat Earth, dude?
Like how does a compass work in a flat Earth?
Dude, they align with the magnetic field.
And how does a magnetic field work on the flat Earth here?
Wow.
Well, it works the same way as it's all in all directions. So you probably think compasses point toward the poles. They don't. You need to update your bullshit. No, compasses don't point toward the North and South Pole. It's not how it works. They align with the local magnetic field.
And how does this magnetic field look?
It's all wavy and all. There's an image in the chat. It's freaking all over the place.
Wait, I'm looking into the server. Where's the chat?
You're not looking? Is that what you said?
Wait,
I said
there's
I'm
two
new to the
south.
server, I'm trying to find the chat.
There's two south poles?
If you go to the top, there'll be a little bubble, open chat bubble, up top where the BC.
Bands, partnerships happening. Oh, way too far up.
Those are magnetic declination maps. So these lines, if you were in that location and you looked at your compass north-south would be pointed north-south along these lines. Now, you're going to ask us what causes this. We don't fucking know. Nobody knows. There's hypotheses.
There's an explanation for the
So
a
what?
globe having
There's
a
no
magnetic
evidence for it.
field.
And in fact, the evidence is that their claim is impossible.
How's the claim impossible?
Curie temperature.
What's
Above a certain temperature, metals can't hold a magnetic field.
There's still metals below that certain
They're
point.
supposed to be molten metal. They're supposed to be like molten nickel, iron. Can't hold a magnetic field above the Curie temperature. Their story is bullshit. So what they'll say is, well, it's actually an electromagnet. But then you got the problem. What came first, the chicken or the egg? The electric field or the magnetic field, because one has to start the other.
Well, if it's molten metal in the globe, that means you have metal moving, which will cause electrons to move, which creates current.
The only way, no, it has to be moving within something. And it's not just simply moving, it has to be accelerating.
No, it's just electrons moving is what causes the current.
Electrons moving, no. No.
It doesn't have to be accelerating. It's just if it's
To
causing
create
it to
the
move,
magnetic
now
field,
create an electric field.
create the magnetic field, you need accelerating electrons.
No,
It
they
has
do
to be
not need to be
changing in
accelerating.
time. When the electric field changes in time, either through acceleration or intensity, changes in intensity, it'll create a magnetic field, and vice versa. So which one started which?
The metal moving. So the electric field
You're gonna
started
pull
it.
itself up by its bootstraps. It's a bullshit story, dude. But it sounds cool. You get little kids to believe it in elementary school, I'm sure. And it sounds so much better than we don't know. People don't like we don't know. Ever considered that, like, what if they were wrong about everything they told you in school about the Earth?
What if they were right though?
Yeah, but they weren't. We know they aren't because we tested it.
What test?
Yeah, what test did you do?
Laser tests, microwave, long distance observation, infrared, radio waves. I mean, mirror test, mirror flash.
Let's start this laser test. What was the laser test and what was the results?
Well, there was which one you want? There's been
There's
dozens.
hundreds, thousands of them, dude.
What distance? The longest distance is 36 miles.
There's a home server there, 24/7 flat Earth, and there's a section there for laser tests, and you can sit there for days and watch videos, man.
You're probably thinking of stupid shit you saw on TikTok that wasn't a laser. That was a flashlight. You're talking about Jeranism. This flashlight couldn't have worked. Tried to shine through boards. Didn't work. Lifted the flashlight above the board. Saw the flashlight. But that's not the way they spin that narrative. Teddy said, oh, that's interesting. Even though he said that 4 hours before that part was even filmed. And the people that produced that admitted that they were going to make it neutral until they found out that some of the people that they had in their show were teaching their children about flat Earth, and that pissed them off. Yeah, there's emails about it.
if you're near a body of water, man, you can do the test yourself, dude. You can see how far you can see across a body of water. Check and see if there's any obstruction.
Did he bounce?
Wait, what did they say after the whole 24-hour Antarctica thing? What was the explanation?
Who's they?
The people that were there. I never watched.
I don't know.
Thing. The Flat Earth. Remember the Flat Earth content creators that experienced 24-hour sun?
Yeah, which is still a flat earther, and Jeranism is still a dumbass. He was a dumbass before he went, and he's still a dumbass after.
What was he saying before? Like flat Earth? Like what did he say again? Why is he a dumbass before?
Jeranism was allegedly a flat earther before that, but he was more like a group. Well, he was saying he was a true earther, whatever that is.
Let's see.
Which is still a flat earther.
What's his explanation for it?
His explanation?
For what?
Yeah. 24-hour flat.
That's flat.
Not flat. 24-hour sun.
He saw a 24-hour sun. What's to explain?
Like that. It was predicted on I guess you could say a globe model, but it
Incorrect.
wasn't predicted on a flat model.
No, incorrect. It's not how they predict the sun position. They don't use a globe model.
In the globe model, 24
No,
hours.
you were incorrect. You're just making that up because you just believe it's true.
Okay.
You are.
Like.
Yeah, you are. You're just making it up because you believe it. Okay, tell me post the equations you looked at.
Okay.
Yeah, that's right. The equations don't have a globe in them.
Let me pull up these equations, sir.
Yeah, do it. Make sure it says radius 3,959 miles in it. So you just believe that they use a globe to predict this. And these guys were told even before, because I told them. And Duffy responded to me, so he knew. I told him, you guys don't even use a globe. Like time and date, SunCalc, U.S. Naval Observatory, that model is not a globe model. Doesn't even involve the Earth at all.
Wait, is it actually? I'm genuinely curious.
Yeah, they just use the celestial. They just use the celestial. They just use a celestial sphere. That's it. There's no Earth. It's an observer-centric model.
Oh, I see what you're saying.
Observer-centric meaning it doesn't matter what you're on.
I see. They infer a celestial sphere, and then they.
No, they use a celestial sphere mathematically.
Gotcha.
And you guys think that the celestial sphere is an Earth sphere.
I see.
But the model, if you look at the math, the observer is at the origin of coordinates, right? In all the measurements, right? So latitude and longitude are actually coordinates in the sky. And to find your coordinates, you look in the sky and look for where's the sun? Well, you can tell that by what time it is. Then you get your longitude. Where's the celestial equator? Based upon its elevation above the horizon. Then you got your latitude. And then using that, where you are relative to the celestial sphere, what's over your head, you can predict where the sun will be. When it'll rise, when it'll set.
What should I say?
Huh?
Because this is like the most stupid argument ever. It changes from where you are on the globe.
Wrong.
How can you say it's wrong?
It's not based upon the coordinate system is not based upon a globe.
Have you ever read any of like the autobiographies on like Harriet Tubman and shit? Like the slaves.
You know what a celestial sphere is, dude?
Shut up, dude.
No, the slaves that were more
Harriet
east
Tubman.
And the south. Yes, they could. The
Oh my
North Star
God,
was a
dude!
different
Harriet
geolocation
Tubman.
than the ones that were more west.
The Underground Railroad, really?
Yes.
That's where we're going.
Yes. It's
Did
irrefutable.
he just quote Harriet Tubman for some fucking uneducated
Jesus.
slave?
Gentlemen, please.
No, give them a little credit. So what were they're looking for the Big Dipper or something and follow that?
No, they looked at the sky and the people that were more east saw the stars more east, and the people that were more west saw the stars more west.
Yeah, great. We know where the
that's why
stars
there was
are.
an issue with the communication between like the east slaves and the west slaves.
Beautiful.
Thank you for that. That is the best sleep I've had in a long time. Thank you.
Look, you can look in the surveying documentation. So, latitude and longitude are not points on the ground. This is a urban myth.
No, it's not.
They're-
It's just
they're
it's a
po- yeah,
simple it's
they
a simple
are.
demonstration of why the stars are different and are irrespective to which point of reference you're standing from at a different point of the globe.
Okay, so this is easy to prove. Tell me how I can't see the sky. It's cloudy. How do I find my latitude and longitude?
Use a compass.
That's not going to find your latitude and longitude.
What's the answer you want me to give here?
You
The
use
correct-
a, you use,
the
you use a
answer is
sextant, right?
I can't
Okay.
because it's not based upon the Earth. It's based upon the sky, and if I can't see the sky, I have no latitude and longitude.
That's why you would use a sextant, right? That's what I believe. It's for latitude and longitude, right?
Yeah, they let you see through clouds. The sextants.
Okay.
Yeah,
This
they
is
do.
this is an irrelevant point.
No,
No,
it's
the
not
point is-
irrelevant.
the
You
point
said
is-
latitude and longitude were on the
You-
ground, but you can't use the ground to find your latitude and
Just
longitude.
because you say something is so doesn't make it. You can't just say this is a not relevant point and be like, oh,
No, it
it's
is.
not relevant, everybody.
This is the simple anecdotal experiment that I proposed to
Well,
y'all.
everybody, it's
Go-
he said it's no longer.
Who the hell
not
even are
relevant,
you, dude?
so-
This is irrelevant. This is what I'm saying. Look straight up in the sky from the United States. The North Star will be in some, like if you look straight up, you're looking straight up. Okay, you can make a coordinate map from looking straight up, and you can map each star from that origin. Okay, the North Star would be X, Y, Z away from that origin. Okay, then you go to France, do the same thing. You look straight up into the sky, and you try to find the North Star. It's going to be a different spot. Do you know why? Because the Earth is round. Okay, and if you look straight up, you're looking at a
Yeah,
different angle.
I
away
went
from
in
the globe.
Walmart. I was in the sporting goods section. I looked at the light above my head, and then I walked into the women's lingerie section, and there was a different light above my head. Oh my God, Walmart's a sphere.
You can. The thing is that the issue with
dumb,
your argument
dude.
there, though. No, you can tell what the North Star is based on its luminosity.
He could tell the
Based
lights
on
in the
its
lingerie section.
luminosity. That's
No,
a
but
new
they all have
one.
the same luminosity.
Just stick to Harriet Tubman, dude. Fucking
Good shit.
look, brother. Fucking, my God. Okay, it's really simple.
My point did not get disproven with this Walmart counterexample. Okay.
Yeah, because Walmart's not a sphere.
Indio, have you ever traveled outside the country? Where are you at? Where do you live?
Your point got demolished with Walmart.
No,
Do
it
some
did
shopping while
not.
you're there. Learn something.
The lights in Walmart are completely different than the celestial bodies in the universe. Okay, you
They
cannot
still
make-
represent lights in the sky. Settle down, princess.
Over your head.
No, guys, because distance is a
Yes,
factor
yes,
here.
yes. All
Oh,
you've
it
done
is.
is change
How do you know that?
position.
I've changed position, yes, but it's more about the angle than it is about the actual distance.
Well, the lights in the lingerie section are at a lower angle too. What's the problem?
They're not at a
Angle,
lower
what?
angle. They're at a
Angle.
Yes, they are.
shorter distance. Guys. The magical thing about radial coordinate system is a small change in angle over a long enough radius could make a huge arc length. That's the whole point. That's why people use the radial coordinate system when describing huge celestial universal bodies, okay? Because small change in angles can represent big arc lengths. And you can't earnestly represent that in a Walmart. Are you serious? You
I
have
can't
to
use
be
polar coordinates in a
space.
Walmart. What if
We
my
can assume
Walmart's
it's a-
round?
Yeah, we can assume the Walmart's round. Fuck.
Oh, guys, come on. This cannot be. This
You're
cannot be your
being
counter-argument.
silly, dude.
This cannot. India, where are you at?
I'm in Boston.
Have you ever been out of the country? You're in Boston, okay? Have you ever been out of the country?
Yes, I've been out of the country. Why?
Where out of the country have you been?
I don't want to say.
Okay, even say you've been out of the country. What's the nearest country to Boston? Canada. Okay.
Canada, yeah.
From
Quebec.
Boston and Canada, you look straight up in the sky. You cannot earnestly tell me that the star positions at both of those locations are the exact same. You cannot.
I know they're
That would be
not. Just like the
disingenuous to
lights
say.
in Walmart when I move, the stars that were over my head, and I move out from under them, and then there's different stars over my head. What don't you understand?
Wait, I think the argument would be that the roof of the Walmart is too close. So obviously, the closer the roof is to your body, the less of total
What the
space you would
fuck?
see. But I guess someone would argue that like if the roof was like a proportional distance to whatever the observable universe would be, and then you like move that same tangential difference, right? Because obviously, if you're looking at one light in Walmart in lingerie, and then this other guy Umafue
Analogy,
is in
dude.
like
Fuck me, man.
the sports section, obviously you would see two different lights, but that's like it's not a one-to-one comparison of like the celestial body model slash. Obviously, that can be counterly argued that just the roof is so close that you would only see that light in general, right? So like that doesn't necessarily disprove the point.
So let me get this straight. I'm in the sporting section. You're in the lingerie section. I have to look across and up at an angle of about 45 degrees. You look straight up. We're both in different positions. We've already established we're looking at different angles to the lights in the sky, but you are going to stand there and argue that we're not looking at different angles.
Oh, is that what Uma was talking about? Was he talking about angles when he was going on that whole tangent?
Mm-hmm.
Uma, what did you mean by that? Elaborate.
No, I said if you look straight up into the sky, okay, you see a different set of stars from two different locations on the Earth. But those locations you have to be some distance apart, some relevant, appropriate distance apart because the Earth is so big, okay, to actually note the difference in the position of the star relative to some origin that you yourself established by looking straight up into the sky. If I could send images in this channel, I would put a
We
perfect
agree with
diagram
you.
describing
You
my
have to
position.
be in different positions to see different
Right.
stars.
But so
Congratulations.
this is where you're fucking up. So you're fucking up a little bit. Because in the globe model, it isn't the distance you traveled that determines what stars you're looking at. In some ways, yes, because you have to get over the curve of the Earth. It's actually because you're rotating inside a celestial sphere.
But what does rotation have to do with?
So when you walk around the
Honey,
surface of the Earth, right? If it's a ball, you're rotating, right?
Yes.
Physically. Like, so
Yes.
say you're on the North Pole and then you walk to 45 degrees. Now you're tilted at a 45 degrees angle relative to
Sure.
your first position. So that's why the stars change, is because you're rotating relative to the celestial sphere. It's not because of the distance you traveled, because according to them, stars are so far away, you could fucking be any distance. You wouldn't be able to tell. That's why, and right, we're gone full fucking circle, okay? They don't use a globe model. They assume the Earth is a fucking point. That point is in your fucking eyeball. In the entire model for predicting the sun, predicting eclipses, predicting the moon, predicting planets, all these things are based upon a model which is observer-centric. The observer is you. You're at the origin of coordinates. They don't place you on top of a ball because in their model, it's redundant because everything is so far away, you can just model the Earth as a point. They don't use a globe model. They use a celestial sphere model. And that's what I was trying to tell you.
Wait, how does that refute what I said?
Because none of that crap proves the Earth is a globe because you see different stars.
Word salad.
That would happen on a flat surface too, dude. You wouldn't walk around, the stars would be the same stars over your head following you around.
Wait, but like, would the flat Earth model explain like going further south and then
Models don't explain things, dude.
not seeing like Polaris, right? And then you start seeing the southern stars. Like, would you not still see the same stars if it's just
First
a
of all,
flat plane?
models don't explain things. Okay. And you can't see things when you walk under them because of perspective. Okay.
You said under. Oh, you glitched out. You said what?
What? I'm
Sorry,
under.
did
I
I
didn't
speak
say
quickly?
under. I
You
don't
said-
remember
did you-
saying under, dude.
Oh, my fault. I didn't hear you right then. What'd you say?
I mean, I could be confused.
I'm sorry. I don't know what you.
No, when
my
you
mic
walk,
glitched
look,
out, my mic
when you
glitched.
walk south, right, the stars get lower, right? They're going to get lower and lower. If you're looking north, walking backwards, right, stars going to appear to get lower and lower and lower and lower and lower. It's just because of perspective.
Then what about the ones that disappear? What
Yeah,
part of
eventually,
perspective makes them disappear?
the stars are going to be at the vanishing point on the horizon. You won't be able to distinguish them from the horizon.
Like That's similar to the Walmart point, right? Where like you keep walking away and then like you wouldn't see. But wouldn't that kind of assume that the stars are really close? Like in theory,
I don't assume.
if it was
Look,
flat, like
no,
wouldn't
no,
if the
no.
stars were truly far
Look,
away
if
and you had
we
that viewing
adopted
distance?
your worldview of uniformitarianism, yeah, that might be true, but I have not adopted that worldview.
I see. Okay.
So you've adopted the Copernican principle? Yes, no?
Sorry, were you talking to me?
Yeah. You've
Could
adopted the
you explain what
Copernican
that is?
principle?
Can you explain what that is?
That the Earth is not unique.
What does that have to do with
That the Earth has no unique place in the universe, and it's just like everything else.
What does that have to do with what we're talking about? You can say your point.
Yeah, well, because it's a different worldview. So if you believe there's one set of rules on Earth and one set of rules for the heavens, right? That is non-Copernican. You think that it's all the same. So you're going to apply the rules of geometry and
Oh, I see what you're saying.
observation and
Oh.
triangulation to the Earth, and then you're going to try to apply them to objects in the
Oh,
sky,
to the sky. That's
right? And that they're
that's
not going to work,
oh.
and then you're going to have special pleadings about
Yeah,
parallelism of rays, and they're just so far away, and all this other nonsense,
yeah,
right?
yeah.
Cosmic coincidences and blah blah blah, right? So you're going to try to fit your observations into that worldview, and of course, I'm going to fit my observations into mine.
Oh, which is that
But
it's
because
not
this worldview is
necessarily.
founded philosophically,
Yeah,
and not empirically, it's just philosophical difference.
Okay, so you would argue that like the rules of geometry, physics, science in general, like we can't
The
necessarily
rules of
use
science,
the same.
no,
We
not
can't use the
science.
same rules of like
Staring at shit
on
is
like
not
Earth.
science.
When did I say that?
Because when it comes to the sky, things in the sky, stars, moon, sun, right? Planets, it's
Yeah.
purely observational. They can't do any experiments.
You don't think they can do any experiments?
Well, what could
that your argument?
name one astrophysics experiment. Just one.
That's not an argument. Look them up. That's not my job.
There
I
isn't
don't wanna,
any.
like,
It's
I'm
not
not your mother.
possible.
You can look it up. Look
It's
at
not
look
possible.
at what NASA does with 45 billion a
Okay,
year.
you know what?
however much they
You know
get.
what are the constituent parts of an experiment? You need an independent
Again,
dependent variable,
yes, you're
right?
right.
You
Okay.
manipulate the independent variable to watch the effect on the dependent variable. Now you tell me some fucking property in the celestial fucking in the in the sky that they can manipulate.
I'm not sure that would disprove the entirety of like science. I'm not sure.
So straw man. We
You can't
went
just yell
from
straw man. Oh wait, you
showing
got
that
me.
astrophysics can't do actual science and it's purely observational to, oh,
Wait, what's
you're
the you're
disproving
saying?
all of science. Shut up, dude.
Which one is which again? The dependent. You're saying the one that what's the one that's changeable
Okay,
again?
so you observe a natural phenomenon, right?
Yeah.
So say there's a supernova. We see a supernova. Boom, a star flashes a brighter light. How do we know what caused that?
I wouldn't know the minutia of how they calculated
Well,
that.
how could we figure out scientifically using the scientific method what caused that? Well, we know how to do it with the scientific method. You have the observed natural phenomenon,
Yeah.
a supernova, and you
Okay.
would try to replicate that. So whatever you thought the cause was, you would manipulate the cause to see if you would have a change in the effect. Okay? That's how the scientific method works. You can't
I
do
see.
that.
You're saying we can't do that with the supernova.
Yeah, nobody can do that.
So therefore, like any like work they do, like necessarily like okay.
It's just storytelling.
Okay.
Well, that's all it is.
Well, like what if you like made a prediction and then like checked against what actually happened and it like aligned? You're still saying that you couldn't
Mystic Meg
necessarily
makes predictions,
use that.
dude.
You're saying that you couldn't necessarily like that couldn't be used, right?
No. I'm saying you couldn't claim knowledge.
That works for like anything in life.
No. Why are you just like constantly straw manning? and taking
Well,
what
I
I
just don't think
said
I don't
and
think it's
going to
fair to
some
say.
fucking
No, I just
extreme thing I didn't even close to
no, I just
imply.
don't think it's fair to say that in like the entire world of astronomy that like that only for a valid scientific test to be like for a scientific test to be valid that you have to physically manipulate the object.
Okay.
Because I agree with what you're saying. Like with
Okay, so
whatever
here's the problem. So this is where there's a reason why I say this requirement, because when you say science, people think of certain things, right? They'll think of the laws of thermodynamics, right? They'll think of the gas laws. They'll think of things that we know that are 100% positively scientifically known from experiment. And then when you say things like, oh, astrophysics is science, the layman thinks they use the same types of methods and have the same scientific certainty that we know those laws of nature and that we know what causes supernovas and that they use the same methods to figure that out. But they didn't. Okay? They looked at it, come up with some hypothesis about how that could have happened.
Yeah. Agreed.
Right?
Agreed.
And then maybe they'll get an observation that matches what their hypothesis was, and maybe they won't. Maybe they'll if they get one and then they don't get one, they'll cherry pick data, whatever. But it's not the
Yeah,
same method.
yeah.
They're not actually applying a scientific method to that. But
But
people
they
want to
don't.
lump it all together and say this is science and that's science. But when
Yeah, but
people
that
think
applies to
science, they
every
think
topic,
truth.
right?
But when people hold on, this is the important part.
Okay, yeah.
When people hear the word science, they hear this is truth.
Well, I guess the issue is what you're saying is true in like almost like most, I would say like most examples like in our world, like geology, weather, like all these things. Like
Yeah, I
I
know.
get what you're saying, and and you're saying you don't agree with that either. You don't like that.
Look, they make big fucking claims that they don't know are true.
So like even like
Look
for
up the
weather,
DART
like
mission.
the predictions of like the weather and like things like
What
that,
do
or
you
even
say?
like geology.
Look up
I
the
don't know,
DART
something like that.
mission. Recent experiment that was successful.
Yeah, sure it was. I heard that story too.
Well, look it up. They
Yeah, sure.
altered the known
Right after
trajectory
that, I'm going to
of
look
an.
up the Lion, the Witch, and the Wardrobe.
I mean, this is confirmable by anyone with the
It's
equipment to look
confirmable
up.
by anyone with a screen. I know.
No, like with the telescope, it was confirmed by several different independent sources with
Oh, I'm
telescopes.
sure. Absolutely.
Look it up.
independent.
Look it up. I mean, you could just deny it to be at the forefront, or you
Deny
could just look it up.
what? Deny your claims? Your claims are not evidence, and neither are theirs.
Well, I'm citing evidence, and you don't want to look at it.
You're citing. Look up the DART mission, and then I'm going to look it up, and then I'm going to look at somebody else's claims. It's called claim
No.
stacking.
You asked for an experiment that NASA did where they altered something that we see above us, like in the stars.
Okay, what was the independent variable?
The knocking into an asteroid with a vehicle.
So, oh my God, are you serious?
No. The independent variable. Yeah, that was the independent variable. Yeah.
What was the dependent variable?
It's a known trajectory, or the trajectory of the
trajectory is not a variable. So, a dependent variable is a natural phenomenon. What was the observed natural phenomenon?
But the trajectory of an asteroid.
Trajectory is not a phenomenon, dude.
No, the change in the orbit of
You're-
Dimorphos. That was the dependent
Oh my
variable.
Jesus Christ, dude.
No, yeah. So the dependent variable, like you see, like you know how there's like cycles of like rotations of bodies in the sky, and they're just like.
No, I don't know how that is.
No,
I know
but
there's a model for that,
but okay. So you know how things like the positions of things in the sky change.
Yep.
Okay, and you know how we predict those, right?
Yeah, Kepler orbital elements. Yes.
Okay. So you understand? Okay, so orbits. You agree that
you don't
there
even
are.
know.
Okay, so you acknowledge that there are known orbits of things.
No.
Okay.
You
so,
asked how we predict them.
Yeah. Okay. Yeah.
I cited a model. I don't reify models.
Okay, but
you reify models.
Bro, if you don't reify models,
Okay,
then
wait. I'm just wait. Just out of curiosity, how do we know where things are in the sky? Like when they're going to be there? Like if you were to say,
Well, I
when
mean, there's a
eclipse is
bunch of
gonna happen.
methods. There's a bunch of methods.
No, but like generally, how? At a general level.
Well, right
how?
now we use Keplerian orbits.
No, like what is that at a general level?
Well, it's imagining that the planets are taking elliptical orbits around the sun.
So you're predicting things based off your imagination.
Yes.
And your imagination is actually predicting things.
Like epicycles also work. Are they imagination?
But my question is,
no, but
so do we
epicycles.
observe?
No, Donald. Epicycles. Do you know what they are?
Like part cycles. Like you acknowledge though that there are
They're called
cycles.
epicycles.
Okay, but you okay. I
No,
don't know why this is so
shut
hard.
up, dude. If you don't know what they are, shut up.
I'm just asking. Do you
Epicycles
acknowledge that they're?
also, I'm gonna fucking mute you. Okay. You're intentionally muting me so I can't make my point. Okay. Epicycles are also a way to predict where the planets are. When you go to a planetarium, you know what a planetarium is, and you look up and you see the planets move against background stars. The model that they use is not Keplerian orbits. They're called epicycles. It's called the Ptolemaic astronomy model. Now, nobody thinks that that model is physically real, but it makes predictions just as accurate as Kepler's orbital elements. They just didn't happen to like it.
You're not letting me ask the question. I'm trying to ask a basic question, and you're not letting me. Please let me ask a question.
You weren't trying to ask a question.
No. You misinterpreted what I said, and you made some point like combatively. But you're not letting me actually ask
What
my
was
question.
my point, Donald?
That there's we use a Keplerian thing or this thing. My question though is that do you acknowledge though that there are what you described observed and known predictable cycles of bodies in the sky or things in the sky?
What does that mean?
That there are there are predictable trajectories of things that we see above us.
No. What do you mean by trajectories?
Like the ability to predict eclipses. Like literally, can you?
Yeah, the Saros cycle, which is
you're
also
saying
not
yes
even a
now, but you just
geometric
said
model.
no. Okay, so yes, right?
The Saros cycle doesn't have trajectories, dummy.
So
dummy,
okay, so you
dummy.
So you
That's the cycle of events.
yes,
not
okay.
directions.
So you acknowledge that there's a cycle, right?
Yeah, of events.
Okay, yes, but you ignore. Okay, it's a cycle of events.
Are you confused?
And those events
Cycle
are
can
the
mean multiple
positions.
things in different contexts. You know that, right?
I don't know why you're so resistant to say that there are
Donald,
things.
shut up
Cycle
for a
mean
second.
different things in different contexts, Donald.
Donald, instead of yabbering away, why don't you just
You
listen
couldn't tell me a
for
single
30
thing I said.
seconds?
Yeah.
I'm trying to ask a question and he's not understanding the
No,
question.
you're not. You're just
I am.
trying to hammer through. No, you're just trying to hammer through. You're not listening. Tell us the last thing he just said.
That there are cycles, but there's not cycles.
Question.
He's not addressing my question.
You're
That
trying to
there's
control
no things based off of
the conversation
events.
through sea lining, and it's not
Events, but like
working.
known positions, like we can predict the known.
What's the question, dude?
Yeah. He said, you're not answering my question. We have known positions. What does that mean?
So if there's
Positions in what
apparent,
sense?
if there's a dot in the sky and there's a smaller dot around that dot that
Okay,
appears
we
to
want
go
to give it a
around that
position.
dot.
Okay, down.
Oh,
we want to
no.
give that dot.
can't.
Hold on. We want to give the dot a position. Okay. What coordinate system is it?
No. It's not about the position of the dot. You're not letting me ask the question. You're just not letting me speak or ask a question.
Oh, go ahead. Go ask your question.
You're so combative that every word you think is an argument. Like the question, like, do you acknowledge that we literally see things above us as dots?
Yes.
Like, let's start with there. Yes. Okay. Good. So you're not going to backtrack on that. We see dots above us. We see circles. And do we ever see those circles moving?
Yes.
Okay. Thank God. So do we ever see? Are we able to say with any confidence or prediction, like, do we see them moving in a way that is predictable?
On this date next year, it'll be in this position.
Yes, like are we able to see things
Now,
moving?
before we go, before you put
they're
forward your next
predictable.
statement,
Yes, dude.
Okay, so if things have a
pre or
predictable,
post,
okay,
pre or post,
post what?
Diction.
Yeah, we're still waiting for your fucking question, dude.
So if there's a predictable cycle of something, and we're able to, and that cycle has never been observed to change this. This has always been observed. There's never been record of it not being according to the cycle. And then we do something. As humanities, we have an independent variable where we claim, okay, we're going to shoot something up at this dot, and we're going to hit it, or shoot it in the trajectory of this. And if the cycle changes, it's like if one day the cycle of the moon changed. Like after never doing so, but after we shoot something at it and then it drastically changes, would you acknowledge that that would be an experiment where you are using an independent and a dependent variable, i.e., knocking into it and it's changing its direction or its cycle?
No. It's not going to tell you the cause of anything.
No. Like, if one variable is remaining consistent for all of observed history, and then you're like, oh, watch
All of
this,
observed.
and then
How
you
long has
and then you
how
shoot
long
at
has
it.
it been observed, dude?
How long has the moon been observed?
No, whatever you think that they smashed into and moved. How long has it been observed?
As long as we can observe things as high above
Yeah,
us.
how many observations of that particular thing are there?
I don't know,
10,
countless
20,
every year.
100,000?
Countless every year. You can see
Countless.
it. You can see it all the time.
You can see it all the time. What are we looking at again?
Well, I told you what we're looking at, but you didn't want to hear it. I
You
can
said
tell
the
you it
Dart
again.
mission. Didn't they smash something into a comet or something?
Yes. So if
Okay.
we
That
take,
so you just said that comet is visible to the naked eye all year round.
not the naked eye. No, you need to use a machine, a telescope or something. Telescope.
Well, you said it's observed all the time.
With telescopes.
Okay. How well, telescope time is very expensive or very competitive. So how many observations of this thing do we have?
I don't know, countless.
Yeah, a countless as in you've never counted them.
I know that this was the
So you've
observations of the.
extrapolated. I just want to point out you've extrapolated
How many
your
observations of
imagination
Venus do we
that
have?
there's a
I don't know,
cycle
a
that's
lot.
existed through all of humanity, and now it's different. Though you don't know that, you just made it all up in your head.
Since we were able to use telescopes and look at it, like.
Yeah, they also looked at old photographic plates from the 1940s and saw fucking satellites. So how does that work?
Okay, we acknowledge that we see things in the sky above us. We use telescopes. They have unchanging cycles.
Look, not everything
And then if we have an independent
because
variable
some
that
things
seems to
have
change that
unchanging
cycle.
Look, bro.
Okay, you're being
Just
intentionally
because
dense here.
shut up. Just because some things have unchanging cycles doesn't mean everything has an unchanging cycle.
Sure, yeah, but if something has an unchanging cycle, and then there's nothing else that's affecting it, and then you do something which affects it, you shoot something at it, and then it changes for the first time ever recorded, then that would be good evidence of your independent variable changing the dependent variable.
Or it's good evidence of cherry picking observations to fit your confirmed bias.
No, it would literally be like there was no other observation that would be able to disprove it. Like there's never been a try before.
How do you know that?
Because it's never been recorded otherwise.
Your ignorance of whether it exists or not is proof that it doesn't exist.
No, everyone who's looked up and looked at this thing says so.
Who's that?
We'd have to
give us the list.
Yeah, we just exactly. Where's the data?
And look this up. Look up the Dart mission. It was corroborated.
Then we'd have to look at how
corroborated by some people I don't know who they are.
Oh my god, you're being intentionally.
JJ, you're being intentionally a pain in the ass. Post your claim in the side chat so we can attack the data.
I can't post. And I've told him this. I've said this many times, and I've also told him what the name of it is. The Dart mission.
DM it to him, man.
Yeah, but I want the list of people that confirmed it.
The Dart mission. They cross-reference other observatories, amateur observatories, other places that observed it at the time, and also corroborated the change in direction.
Oh, sure.
Look it up. The Dart mission.
Yeah.
I can't post.
No,
post it in the side chat. You can post now.
Okay, good.
Make it
Is it going to
worthwhile.
be a change in direction or a change in what they predicted it should be?
Change and observe cycle.
A change in what they think it. Well, no, it would be a change in its location relative to some prediction.
Yes, the known observed cycle of this object.
No, they wouldn't have observed it yet. It would be a prediction. Can't observe it before it
they
happens.
observe the cycle of the object. Like if you have something floating around something, and then you
look. Okay, maybe you don't know how fucking orbits are supposed to work.
Oh, really? I don't know how orbits supposed to work. Okay.
Yeah, orbits precess. Okay, right? The orbits precess. Do you know what that means?
Right.
No, you don't know what that means.
You're denying the existence of orbiting.
Oh my fucking!
You don't believe in.
You are confusing the difference between a model and reality. So I'm going to give you the most generous fucking interpretation. Okay. They see something. That something, according to their calculations, is supposed to be here. They think they shot something up there and knocked it. And instead of being at that place at this time when they think it's supposed to be, it's at this other place in the sky. Right? It's not being monitored 24 hours a day.
No, I'm just posting the study that was published as a result of this.
How about you just answer what I said? You didn't even read this.
I have read this, not the direct first-hand study. I've read the primary press release and looked at the data, looked at the images, and I'd seen the names.
Oh
of
my
this
God, look at the size of those fucking error bars. Are you fucking high?
Yeah, got to look at the data and then ask, is this falsifiable? Right. So when are you going to observe an asteroid? Yeah, when are you going to observe the pattern of an asteroid for 20 years and then shoot a rocket at it?
I don't even
Donald?
think 20 years is long enough. He said there's never been all human history.
You got evidence of it being otherwise?
Yeah, I didn't make the claim all of human history.
No, all of observed, ever since all of observed.
Ask me to prove a negative is crazy.
Observed.
Which doesn't mean anything.
It has a known cycle around something. It does mean something. If the moon, if somehow, like tomorrow, the position of the moon and the sun changed for everyone on Earth, and it was after a bunch of people launched rockets at it, and then you could see stuff like you could see on the surface of the moon and the sun a morph
we've
to like
heard it
an
already.
explosion. That you could then reasonably conclude that we're shooting stuff there, right?
Breathe for a second. What are you trying to prove with this bullshit?
That we have physically altered
backs up what?
positions of things in space.
So your claim is because of this here, humanity has altered things in space. That is a very large claim, my little friend.
Which was corroborated by everyone else.
What?
Everyone,
by what?
yeah, everyone. That magic science guy I can't name.
Dr. Finkelstein Jr.
Yeah, look, I'll give you
so
here's the
right.
pre and post imagery. Look at this shit. This is crazy. Like, I encourage you, look this up. This is very recent. We just did this. This was a big success.
There was no we in any of this, dude.
Well, if you don't go to the universities or work at the laboratories or work for the government or any of the other places or have telescopes, then sure. But for everyone who has telescopes, then it is.
Yeah,
sure.
Yeah. We just add yourself to every endeavor that every human being makes.
I'm pretty sure
Just add
Bojero
yourself
is
to it,
hearing
dude.
people say, "When have
This
we
is
done
like
this?"
stolen valor.
What was
so
your role?
out of that category of things that we must have, telescopes, work for the government, or go to university, which one do you do, Ice JJ?
I've done 2 of the 3.
You're at university and you work for the government. I call bullshit.
It's how he's paying for food stamps.
Have you looked at the link?
You work for these guys or something?
Is he selling it? Yeah, he's selling it.
Yeah,
he still has a debt outstanding anyway.
I mean, you can just deny, but this is all recorded. Like they take photos. Every other place they've taken photos to confirm it.
There's no photos in this.
Well, look at the other link I sent. It's a whole link on imagery.
What did they do to determine that it changed track?
They observed the track.
No, hold on. Walk us right through the process.
You can read it yourself. They observed
Oh,
the
really?
cycle of the
Tell
thing.
us
They observed the
exactly what
cycle
they
of the
did to
comet.
determine that
Okay.
it changed track.
They observed the cycle of this comet or asteroid. They
They
observed
observed
it.
it. Like, what does that mean?
You look at it, and you look
Yeah.
at it. You look
And they
at
see it
how
in a
it
place in the
moved.
sky, and then
You're
they look
having
later and they see it in another place, and then they look later and they see it in
so
another
if you
place.
I'm trying to explain this to you. So if you look at it and it seems to circle around something else, it has a known cycle of rotation. It moves in a known predictable circle or it's shape. It moves in a cycle, and then that cycle is unchanging. And then you change. You do something. You launch something into it, into the coordinates or the direction of where it is. You see it. You have a camera on the thing you launch at it, so you can look at whether or not you're going into something. You put a camera on the front of the thing that you're driving into it, and then you also just observe it. And the direction of it changes after you hit it. You can see, I'm pretty sure they saw a marking
What does
or
that
an
look like?
effect.
What does that look like?
You ever see like
This
a
change in
you ever see a
direction,
bag?
what
You
does
ever
it
see
look
like a
like?
you ever see like a
Does it look
ball?
like a ping pong ball or a two ball smashing together?
Do you know what? Do you have any conception of what orbiting looks like?
Dude.
It looks like changing its orbital course.
Oh, really? What
Yeah.
does that look like from our
Okay, so
point
do
of
you know
view
what? Okay,
here?
so do you know what orbiting is?
Yeah, dude. Okay,
Okay,
you're
so it looks
playing
like
games.
changing the.
What does
No,
that
it's
look
not.
like from here?
It looks like a change in the known observed rotation of an object of this
The
cycle. Like if
rotation. So now they're measuring the rotation. Is it the rotation or the trajectory?
trajectory and a rotation around another thing.
You can't look, bro. Are you
It's
confused?
very simple. You're having a hard time with
No,
like basic
I'm not
observation.
having a hard time.
Like
You're
how
having
do
a
you
hard time
observe a
because you
car
don't
going around a
understand.
track? It's like you
It's
look
not
at it.
Yeah, but you're
JJ. The reason he's having a hard time, as per your perception, is because you didn't do a good job of explaining it. Don't just think he's
No,
a
I'm
dumbass,
not having a
therefore
hard time.
fail.
He doesn't understand geometry.
That's what, yeah.
He has shit spatial awareness.
He's asking what it looks like for something to change its orbital course.
Okay,
And I'm asking you, have
depending
you
on
ever
your
seen something
viewpoint,
orbit?
depending on your viewpoint will change how it looks, right?
Not the orbital course.
Yes. It'll
No, but
how
like
that orbital
accounting for
course
that
look.
viewpoint. Like
Okay, I'll
if we, no, no, hold on.
I'll
Like
give you a simple example.
no. Like we all
You're
see the sun.
above.
Like if the sun looks in different positions from where we are, we all still have a known cycle for where the sun is that we all can account for.
Oh,
like
so
we know how to predict. We know how to predict where the sun's going to be.
So timing.
It doesn't predict. You don't. It's not like we don't know because you never know where you
So
are
timing.
relative. Well, timing is part of it.
Well, you
Like
said it was
cycles
changing course.
have durations. Yes, like you're having a very hard time with known
No,
cycles
I'm not
being
having
changed.
a hard time.
You
You're
are.
having a hard time being specific.
I am being very specific. Literally, something moves in a very specific cycle. It moves in a very specific trajectory.
Okay,
It
and I
doesn't
asked you
change.
specifically,
And
what
then
does that look like from Earth? And you can't
it
tell me.
looks like the trajectory of the thing moving in a different way.
Yeah, in what way is that?
Off the trajectory that it is always observed to be.
They don't say any of that.
They do.
No, they say it's just adjusted by some micro arc second.
Yes, that's a measure of direction.
Okay. But that's a difference in time.
No, it's a measure of direction.
A difference in time is a measure of direction?
No, like the measurement of of it moving.
You never read this paper, dude.
I have read the summary of this. Yes. An arc second is an what? Do you know what an
micro
arc second is?
dude. Micro arc
Yeah, that's
second.
an angle.
Yeah, I'm well aware of that.
You just said it was a unit of time. It's a second.
No,
it's an angle. Literally, the angle of the direction. It's
bro. It's the same shit I said before.
Yeah, so the angle of the direction. Yes,
bro,
it is direction.
You think it's going to be? Shut up. You think it's going to be in position X at time t? It's not at position X at time t. It's 10, 11 microseconds different than position X at time t. Okay, that's what they're observing.
They're literally observing something being pushed off of its orbital cycle.
No, they're not.
Shifted. Yes, it is.
I just told you exactly what they observed.
Yes,
Okay.
yes, a shifting. Yes, that is a shifting in something's cycle in its trajectory.
Yeah, you can interpret it that way. Sure.
No, that's literally what it is. It shifts.
Yeah. If
And
you
it
say it
shifts.
10
And it
more
shifts
times,
only
Dorothy,
after it
then
shifts.
you
It does.
go
There's
home.
no.
You go home
No
to Kansas
documented
too.
shift before. It shifts only after they do this, and
Yeah,
right
full
after.
story.
Right as, and they literally got it on camera.
Yeah, I'm sure they do. I got fucking Santa Claus on camera. He did it. Santa Claus did
Yeah,
it.
but
He fucking
Santa
rammed it
Claus
with his
isn't.
sight.
Yeah, but Santa Claus isn't backed up by reputable
No,
scientists and
Santa
independent
Claus
sources,
rammed
is
it
he?
with his sight, dude.
No, he's not, is he? Yeah. So
No,
there's your
Santa
issue.
Claus rammed it
And
with
he's
his
not
sight.
backed up in science or any of that. Like
He's not backed up in
you're
science.
now just you're just spoiling the water, whatever you call it, poisoning
When
the
was
well.
this?
Like you
When
won't
was this
accept
object
you won't accept
identified?
anyone or anything.
When was
This
this
is
object
literally an
identified? Shut
no,
up,
JJ,
bro.
shut up.
For
No,
fuck's
this
sake.
is so ridiculous.
Yeah, shut up, girl.
This is so
He's gone.
ridiculous.
Yo, I have a question, like kind of related to this experiment here.
What
So,
experiment? It wasn't an experiment.
Whatever you want to call it. Do you think they sent some up there to hit this asteroid orbiting it? No, just no.
No, it's a fucking show.
So like it's just all staged there.
Not possible.
Space is fake, dude.
Like all space.
What guys don't you understand is outer space is impossible.
In what way?
Physically impossible. I know it's been on your TV set since you were born. And I know that, Democritus and Epicurus invented the idea in 300 BC, even though they had zero evidence for it. And that it's an idea that's infected humanity for, 2,000 years. Okay? I know all that. But we know the second law of thermodynamics say it's impossible. It's fucking impossible.
Why?
Because you said why, right?
Yes.
How did you generate the gas pressure to utter that word?
Because I want to know why you think space is
Yeah,
impossible.
so you generated gas pressure in your lungs to utter that word. Well, how did you get gas pressure?
Because there's gas around us.
Yeah. Is that gas next to a vacuum?
Yes.
What's in between? What's stopping the gas from fucking off into the vacuum?
Gravity from the Earth.
Okay, so if I get a vacuum chamber and I put gas in it, will the gravity hold the gas to the bottom of the vacuum chamber, away from the vacuum?
Well, then it's not much of a vacuum chamber if there's gas in it.
Yeah, I know.
Gas filled with
Welcome to Flat
space.
Earth. Yeah, welcome to Flat Earth, dude.
Then how come the oxygen, like it's less oxygen at like the top of Mount Everest? They got to bring
cares?
gas tanks with them.
Who cares?
It's because
He answered his
more
own question. He doesn't even know it, dude. Fuck.
because there's more
Who cares?
oxygen towards the bottom of the Earth.
So what? Look,
which means it's being pulled
open
in by
systems.
gravity.
Look, closed systems can have gas pressure gradients. Open systems cannot.
So are you saying there's just like gas everywhere?
The Earth
There's no such
is a
thing as a
contained
vacuum outside of it.
thermodynamic system. Thermodynamic, the key word being dynamic. It's a thermodynamic system. There's energy inputs. Okay, so we have gradients. Okay, that's the way it works. It never reaches a state of equilibrium because we have a constant asymmetric energy input. Okay,
What's outside of this system then?
Nothing. It doesn't even make sense. There is no outside.
You said the Earth is a closed system. So what's outside of the system?
Nothing.
So it's a vacuum.
No, not nothing as
No.
in it's a vacuum, as in nothing.
The vacuum is the emptiness.
Okay, what's outside the universe? Is it vacuum
Yes.
or is it nothing? I mean nothing in the true sense of the word. Not fucking vacuum foam, not quantum foam. I mean actually nothing.
So there's just nothing outside.
There's
of it.
no existence. There's no reality. There's nothing like that.
So what about stars and other celestial bodies then?
What about them?
What are they?
I don't know.
Nothing.
You think you know?
You taught.
I think they're condensed bodies of gas or other materials. Yeah,
Why?
because gravity pulled the things in together, and then they became
You
spheres.
claim stacking, bro. You claim stacking. How do you know that?
I mean, gravity is a proven theory, so we can go
And
off
it
of
is.
that. Yes.
Then why on NASA's website for the kids it says what is gravity? And it says I don't know.
For the kids, I don't know.
Yeah, so NASA has like a
NASA also probably has something else on a non-kid
Star
website.
Child, isn't it? Star Child?
yeah, Star Child. Yeah, so it's actually for like middle schoolers. But one of the Star Child questions of the week is what is gravity? And the answer is I don't know. We don't know. But it's proven. How do you prove something you don't know? What do you think about gravity has been proven?
They've proven that there's a gravitational force between objects.
Really? How'd they do that?
They put, what was it, 2 like little balls of lead, and they noticed that they attracted each other.
Really? That's what they did?
They got 2 little balls of lead. Oh, that proves everything, guys.
They also
really believe
measure
that, don't you?
gravitational fields just like electromagnetic fields.
I didn't hear what that was.
You know what dowsing rods are?
Yes.
I think they prove gravity.
No, I don't think they do.
Oh, why not? Same thing.
They're the same thing.
It's the same thing, right? Put up 2 things, they just come together magically by themselves. It's got to be gravity.
Well, then what else is it if they just have...
Yeah, well, what else is it?
Yeah, what is it if they just happen to attract each other?
It's an unbalanced torsion rod.
No, not the fucking dowsing rods.
The torsion rod. In the Cavendish experiment, the experiment you cited, which actually what happens is the balls oscillate back and forth and eventually reach a state of equilibrium. But it's because it's unbalanced. And there's no way to balance it. It's a parlor trick. Remarkably hard to even get work even once.
But isn't gravity like an argument for unbalanced people?
He said it was proven. Gravity was proven.
No, it wasn't.
That's a bold fucking claim. Has anyone
say there's
observed a
enough.
star
Oh, sorry.
forming from gravity?
Sorry, can you repeat it?
I was asking this guy, has anyone observed this? He said stars form from gravity. I was just wondering if anyone's ever observed that.
Yes, that's Donald J's argument that he has an outstanding debt on. He said that we can relate gravity to the appearance of round things in the sky, and left when he was challenged on how he connects the two, and he's never bothered to elucidate. He said one day, so that we know that things pull towards the center and form spheres due to gravity. And I said, what evidence do we have of that? And he said, haven't you ever looked up at the sky and you see those things in the sky? That was his answer.
Shocking. Is that guy still here? Did he take
Young
off?
fella? You still here, young fella? Ryan? Is it Ryan?
What was it?
Yeah, so let's say I grant you gravity. Gravity's the thing. How do you know that's what forms stars?
So we're saying it is true, like
No,
gravity is how we think it works.
just for the sake of argument. How
Well,
do
yeah,
you
yeah,
know
like, I'm
that
saying
is
for the
what
sake of
is why?
argument, we're saying that's like gravity is how I think.
For the sake of this argument,
You know, I'm not trying to like trap you into saying like like to make you think you're saying it. Like I'm saying, like for the sake of argument, we're saying
Just-
gravity's how I think it works.
I'm trying to get to a larger point. Okay, the larger point is you said stars form from gravity. Gravity's proven. I'm trying to get to the stars thing. Even if gravity was proven, there's no observation. That's how stars formed.
Then how else would they be formed?
That's not an answer, dude. That doesn't answer. That doesn't. Just because you come up with a story and you can't come up with an alternate story doesn't make your story true.
I feel like you could use that exact argument for everything you've argued this entire time.
Oh yeah, try it.
You come up with a story, but then you can't.
What story?
Everything you've said.
Nothing I've said is a story. I cite evidence, dude. I don't cite stories. No one's ever observed a star form. No one's ever observed a star form, much less the cause of a star form, which is a different question altogether. No one knows what causes stars to form. No one knows what the composition of stars are. No one knows how old they are. The stories that you've been told, that I've been told. Like I said, I could grant you gravity. Gravity pulls mass together. Oh, great. Well, how do we know that's how stars formed? You don't. So you don't have the fundamental requirement for science. Empiricism, observation, experiment.
In fact, that was so off with their gravitational expectations of celestial objects that they had to invent something called dark matter and dark energy.
Oh, they have to invoke all sorts of special pleadings to get the solar fusion model to work. Photons take 1 million years to quantum tunnel to the surface before the sun emits it as light. The core, even though it's where the fusion is only like 6,000 degrees Kelvin, but the surface of the sun is 1 million degrees Kelvin, so it's thermodynamically uphill. The further away you get, the hotter it gets.
Right. And I mean, why don't nebula just form into one big giant sphere? Why are they like cloud shaped within which stars form?
No, Ryan, what they say the sun is, they say, imagine this. It's cold out. You come inside, your wood stove's going. You warm up next to the wood stove, and then when you're nice and toasty, you walk away, and then it's getting hotter and hotter the further away you get from the stove, and then you burst into flame. Okay? That's what they say the sun is.
It's scary.
That's what they say the sun is. Thermodynamically uphill. 1 million degrees in the chronosphere, but inside the core of the sun, it's only 6,000 degrees. You can believe that bullshit if you want.
Yeah, and in helium atoms, they have a natural propensity to repel each other. But if you have enough of them, they can dance a load of shit. Yeah, Fred Hoyle said it best himself. He said, the astronomer is quite restricted and impeded in his ability to be like other scientists, which can get hands on. He said you can't go out and peel a star like an onion and see how it works. see what it's made of and everything. And he was pretty much the one who brought forth the idea that they go with today about how stars are formed. He proposed that.
From a curious point of view,
Bless you.
I just want to know what y'all think
Thank you.
about like other planets and stars. Like, do you think that they're flat also, or is it only Earth that's flat?
The only right answer is I don't know. The best answer
right
is I don't
answer is
know.
it don't matter.
Yeah, it don't matter.
But
I
I'm
don't
just
know.
curious. I don't think that it doesn't matter.
Based, hold up for a second. CY, can you put yourself on mute because your microphone is like one of the worst ones I've heard today.
Hold on. Yeah, let me reset it. Sorry.
Nasty.
Back to what I was saying. Like,
You
do you
gotta
have
change the
any
battery,
theories?
dude.
I'm sure you've thought about it before, right?
Doesn't matter to me.
Mac.
You'll never experience Earth as a planet, as a celestial object. It'll always be terrestrial for you, beneath you, below you, not above you, not out there somewhere. So liking what you live on to things in the sky is like it's not logical.
You ever heard the saying, you got your head in the clouds? I don't have my head in the clouds, dude. People have been telling stories about the planets and stars for as long as human beings have existed. Everybody thinks they're right. They thought they were right 10,000 years ago. They thought they were right 500 years ago. 1,000 years from now, the people are going to think everything we thought was stupid. Are they read that about stars? Ha ha ha. And you're going to laugh. And you're going to be so adamant that all stars are made of hydrogen gas and it's nuclear fusion and blah, 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 blah. Planets are this, planets are that. And everything you think now, it's all going to be wrong.
So, do you think that they'll think the same thing about you in your arguments right now?
What are they going to think about me? My arguments are sound.
But you just said every argument made, like in 100 years.
About the stars. About the stars and the planets and shit like that. Because we can't access those. All we can do is look up and imagine.
Okay, but what about in, let's say, 100 years? I'm sure by then we will have traveled to Mars, and I know.
Oh, you're sure? I'm sure.
Okay.
We call this the appeal to the future fallacy.
Let's just assume in this argument that we do travel. There are astronauts that
Yes,
travel
let's
to
assume the second law of thermodynamics will be falsified. Yes. Okay, let's assume that.
Okay, and you arrive on Mars.
Let's assume Jabba the Hutt's there to greet us.
Yeah, I want to go to I want to go to the underworld from Total Recall. I want to get that bitch with the 3 titties. Anyway, moving on.
Just assuming that we were there.
Assume she's there.
At that point, would you assume that Mars?
I love this question from you guys. I know where you're going. Well, then would you then say that the Earth is a globe? If you saw it with your own eyes from space, right?
I didn't say that I was a flat earther.
Yeah, I can hypothetically entertain that. Yeah, of course. I'd have no choice if it became my experience, right?
Yeah, that's easy.
What about you? What about you?
Yeah, well, we already know what his answer is. He sees a flat Earth every day and denies it, so.
Exactly.
Are you aware of that every day of your life you've seen a flat Earth and deny it?
No.
No? Where did you go to see the Earth as a globe?
No, I didn't say no.
So you've never seen the Earth as a globe?
No.
Right?
Right.
It's just an image on a screen. So the point is that you guys often conjecture, hey, if you went to space and you saw the Earth as a ball, would you believe it? Yeah, if I saw it with my own eyes, but right now, the only thing I've ever seen is a flat Earth. And that's the only thing anybody I know has ever seen. Everyone you know. But, on the TV screen, There's some people that say, "Hey, man, I went to the moon and saw the Earth as a ball." Well, you're going to need to get more people because as of this point, that's what? What are they up to? 32 people or 35? That say they saw the Earth as a ball? That ain't enough.
That wasn't my question. I wasn't even going to ask about Earth.
Well, I mean, I don't think anyone's. I
question.
don't think space is fake, dude. Space is fake, man.
Think so?
I know so.
How do you know so?
Yeah, because of the reason there's a second law of thermodynamics. Didn't I just discuss this with you, or was that the other guy?
That was the other guy.
Okay. How do we have gas pressure without a container that we're breathing? Why doesn't the gas on Earth just go fly off into the vacuum? And you're going to say gravity. And I'm going to say that's a cool story. Do you have any experiment that demonstrates that's even possible? Like showing a vacuum chamber with the gas all sitting in the bottom, held to the bottom by gravity, away from the vacuum. Same way the Earth is supposed to be doing it. Holding gas to the surface, away from the vacuum. Well, you can talk about it, but you can't demonstrate it's possible. Just an idea that someone came up with 1,000 years ago. And still infests the human psyche. And that's all it is. It's just a freaking meme that won't die. And you're probably an atheist, and that's probably depressing to you. But sucks to be you. See, outer space is atheist salvation. Did you know that? That is where your salvation is. That is your heaven. There's nothing more annoying on earth than hearing an atheist say, "We're doing it for human progress." You're an atheist. What the hell do you care about human progress?
Are you religious?
Not particularly. Just
You're not an
atheists annoy
atheist?
the shit out of me, dude. I just think materialist atheist is just retarded.
But you're not atheist.
Oh, hell no.
What are you? What do you
Well,
claim to be?
religious, look, bro, religious is not the same thing as being a deist. That's not the same thing. You can be a Buddhist and be religious, but you don't believe in a god.
So what do you claim to be?
Me?
Yeah, I'm just curious.
Oh, Jesus Christ.
Okay.
I'm not religious. I don't go to any particular church. I don't have a particular practice.
Grew
My
up
reasons are
religious or no?
personal. They went like whatever the reasons that convince me can't possibly convince you because they come from my experience. They don't. You'd have to walk in my shoes really to
Oh, so you didn't grow up religious or whatever?
know them. What?
Did you grow up religious?
I still didn't hear that. What?
Did you grow up religious?
Part of my youth.
That's not necessarily the reason you are religious, I guess, is what you're saying.
All my actual religious experiences, or well, let's call them spiritual experiences, happened way after that.
I see. So
I
it's more
stopped
of
like attending any type of religious practice probably when I was.
I see. So it's more of like
7 years old, 8 years
it's
old.
more of like an individual experience versus like I was taught this or I read this.
Yeah, I mean, I remember stuff from the Bible just because I have a good memory and I read it then. So I also remember shit I read in other books. So that's not really unique. Yeah,
I
as
don't know,
far
I'm
as
just
like
curious.
being in a practicing religion, that probably stopped when I was 7. I'm like 50 something now, so It's a long time ago. That isn't really. That, I mean, I wouldn't say it's influenced me to some degree, but that has nothing to do with the experiences I've had. Like they're very. I could explain them to you, but I'm not gonna.
Yeah.
Way too personal.
Fair enough, man.
Too personal for this place.
Did that also part of the reason why you believe flat Earth as well?
No, it has nothing to do with flat Earth. Is independent of all that.
Yeah. Okay. Interesting.
I was a globe-tard. I was the same way. I was a
Oh,
globe-tard when I had the religious with the experiences. So I mean,
until when? Like a few years ago? The advent of technology.
no, I've been a flat earther for like 10 years now.
Okay, interesting.
But that was based upon. I didn't even look like it. I was looking for something that was kind of related to it. I was looking for So you can model electromagnetic waves using something called the plane wave equation, but I didn't want that. I wanted something called the 3D spherical wave equation, which doesn't really exist, but I didn't know that at the time. There's actually no 3D model for the propagation of electromagnetic waves. They have something called like I can't remember the name of it, bezel spheres or something like that. It's not exactly identical, but anyway. So just from like searching plane and sphere, plane and sphere, plane and sphere, plane and sphere over the course of like 3-4 months, I ended up getting flat Earth stuff popping up in my recommended over and over, and I didn't really pay any attention to it. And I'm like, fuck, dude, like, why is all this flat Earth shit coming up? This is after like a few months. So I clicked one of them, and I think it was the Chicago skyline. So it was a news broadcast of someone had taken a picture 52 miles from one side of Lake Michigan to the other. And there was a news broadcast that showed the photograph. And the guy was like, here's a picture from Josh Nowicki, but what you're seeing here is a mirage. Conditions are right on the lake to see Chicago or whatever. But it was obviously not a mirage. I know what a mirage is, and that was not it. So I'm like, why would that guy say that's a mirage? Doesn't make any sense. So then I looked at other stuff. And then I backed away from it for a while. It's like I was doing like some other research. Something totally unrelated to this electromagnetic radiation.
Are you Midwest? From the Midwest?
So anyway, so I went back to doing that, but it was like gnawing at me, like in the back of my mind. So then I went back and looked at, like, okay, if the Earth has a ball, they would have measured it, right? So I'll just go look at some surveying stuff, and if the Earth has a ball, they'll have measured it. Well, that was not the case. So, yeah, and then I looked at, stuff all over the place, and then eventually I looked. I'm like, okay, I'm gonna do a random. I'm gonna just do an image search on Google. I'm gonna just try to find long distance observation photographs, nothing to do with flat Earth, right? So I just wanted amateur photographs that Google had indexed that people uploaded to their like blogger.com or whatever, and just find one, which is just some long distance thing. See, not just the globe, because I don't know. People are like cherry picking images, so let's find a random image that someone took. And I found one. It's like 20 miles. It's taken at a bird sanctuary, and it had there's a USGS weather tower out on like a little rock island, and I could get the height of that, how high it was above the water, and none of it should have been visible. So, and it was. So I was like, man, that's nuts. They're St. Paul.
Gotcha. Interesting. If you don't mind me asking, are you from the Midwest? It's like,
No, I'm from Boston.
oh, you're from Boston. Oh, that was you. Yeah.
Midwest. Nope. I've been out there
Most
recently
boring
though.
fucking place in the world, dude.
What
Pretty
is
but boring. The
the Midwest?
Midwest.
There you go.
I'm actually thinking about moving out there.
I visited Nebraska for 4th of July. It was so exciting. Last
I'm
year's
looking for
4th of July.
boredom, bro. I'm sick of this freaking mess, man. Hearing a freaking ambulance or helicopter, airplane every 5 fucking minutes, or somebody honking their horn, or the ambulance, or bro, it drives you crazy after a while, man. I can't stand the noise.
Fair enough.
Beep beep, pop pop, beep beep. Where do you learn to drive?
Freaking junkies everywhere. I mean, come on, man. Things are tough
I mean,
all
I'm
over.
18. I just like going around and like
You
going
live
out
in
to
the
dinner and
city?
stuff with my. Yeah, I live in the city.
Which city?
Portland, Oregon.
That's not a real city. Well, yeah, you guys got a freaking huge homeless problem there, don't you?
Yeah.
Oh, you got that freaking Chaz place, don't you?
That was like 6 years ago, but yeah.
Yeah, I mean, yeah, okay, so yeah, that is a real city. Is it better now?
Significantly.
Are you like in the city, or are you like in the suburbs?
In the city.
Oh, good. So you're actual city person. Good. Okay. Well, I
Yeah.
mean, because a lot of people say they live in the city, but they live in the suburbs, right? And they're just posers.
No, I live right in it, right in the middle. I live actually 2 blocks away from Chaz, where it was.
What do you got for public transportation out there? You got subways or anything like that?
Yeah, we got TriMet, which is super good. We got buses, like a subway line. We got a train line, the West. We got a
Yeah.
streetcar. We got a
How
direct
far can you
line
get on
from.
that? Like you got like a commuter rail type deal?
So the train, which is like it looks like it's like a single car Amtrak train. It
Yeah.
just goes back and forth between I think Oregon City and Beaverton, which is like it's not super far, and it's not from the city. It's like suburb to like another suburb.
Yeah.
And then the Max Rail goes all over. It goes from the airport, which is really far out, all the way to like the furthest part of Gresham, which is super far out in the east, and then all the way far to the west in Hillsborough, and all the way south to Oregon City. And it goes pretty far. And then the buses, dude, they go really far, really. You can get anywhere, dude. You could get anywhere in the city on the bus if you just know the bus line and what time to get on it. You could get anywhere you want in like an hour and a half, no problem.
Yeah. Do they run late?
No. Actually, the only ever issue I've had is they get there too early sometimes.
No, I mean, do they run late at night? Like, do they run till like 2 in the morning, 3 in the morning?
Yeah, about 2 in the morning.
Yeah, that sounds dope. I'm not moving out there, but doesn't it rain? I
Mm.
fucking don't want to chill in the
Yeah, it
rain,
rains a
dude.
bunch.
Yeah, fuck that. I'm good with that. I don't need rain.
Well, ladies and gentlemen, I'm just going to quote George Bush Jr. Let us not tolerate ridiculous and outrageous conspiracy theories regarding the shape of the Earth and it being a globe leading us down the Swanee and taking us away from the truth. Truth.
I'm going to quote Ronald Reagan: "Trust but verify."
Listen, guys, saying the Earth is flat is anti-Semitic. You need to stop. My rabbi is gonna get really mad at you guys if you keep going on with this anti-Semitic rhetoric.
I think your rabbi took too much skin off.
Listen, they don't listen. My rabbi definitely does not run any banks, but he told me he's gonna take away your bank account if you keep talking, even though they don't run the banks. But he said he will take away your bank account. FYI.
Yeah, well, Indio, thanks for explaining to me the ridiculousness of this formula. It's accurate. It is accurate, but the semantics that's being used is ridiculous. Because I spoke to AI yesterday just to get his angle on it, and then we worked out the maths through AI, and we could see that the discrepancy was like less. If you're looking at a distance of 1,300 miles, the discrepancy is less than 1%. So if you're like 500 miles distance between the two formulas, that's the Pythagorean theorem and this one, which is in the side chat, the discrepancy over 500 miles is less than 0.13%. So it's less than 1/13 of a percent. So they're really, these globers that are saying that our formula is wrong is just ridiculous. But yeah, thanks for that anyway. And
Yeah, they're just it's like when you say water don't curve, and they're like, "What about a raindrop?" It's just so lame.
Yeah,
They're just
yeah.
lame, dude.
Yeah. So now I haven't used it yet. I've yet to embarrass his ass even more. You know.
You're like, "That's a parabola." I mean, yeah. So approximates a circle for 1,000 miles. I mean, so what? No one's doing
Yeah.
1,000-mile observations.
That's right. We're not seeing the curvature there. We're not measuring it. There's a whole load of us in here today.
Y'all know Israel's hiding children from
Is that your daddy's name, Israel?
Israel.
Your daddy doing bad stuff? Just report it to the police, man.
Oh.
Just call the police. If your dad is abusing children, whatever he's doing, any crimes, just report it to the police. Don't come here and talk about it. Just call your local authorities right now. Just call them right now. Go out of here. What are you doing here? Just go out there.
Yeah, do your duty.
Yeah, do your duty.
Shut the fuck up, you round earther son.
He's witnessing crimes and he's trying to say here, like, call the
Yeah.
police, bro.
Hurry up. Why are you still here?
Wasn't at all what he said, but
He said Israel, the name of a guy, is doing stuff.
no, he said the Jews are children in the.
Oh, he didn't say the Jews.
They're hiding kids.
Okay, bro. Enough about the Jews. Are there any actual flat earthers here that want to?
They're hiding kids in the firmament.
Yeah. Yes,
No.
we're here. The flat earthers are here. Take a look at the formula
Okay,
in the side
so
chat.
Jin, you
and
know what happened last night? I
No.
told you something, and you just couldn't debate. You actually stopped talking, and I had to.
No.
leave
What are
the
you
call
talking
'cause it
about?
was so
What
fucking
are you
boring.
talking about?
You just sat there and contemplated what I said.
What don't be so what's the word I'm looking for here? You're assuming to the extreme. What was it you said yesterday? Go ahead. I'm still here. I'm waiting.
Oh, my bad, bro. Basically, I told you, and I made it pretty clear on what I said. I said a globe Earth has a horizon, correct? But a flat
No,
Earth
incorrect.
doesn't have
Incorrect.
a horizon.
Incorrect.
And we
Not
know
correct.
that the
Not
world
correct.
is a globe
Incorrect. Not
because
correct.
of the
Incorrect. Not
horizon.
correct.
You
Incorrect. Not
understand?
correct. Incorrect. Not correct. Incorrect.
They would both have a horizon.
Not correct. Incorrect.
How does a flat Earth have a damn horizon, bro? Please explain. What,
Incorrect.
does it go under the disc?
Not
Does the
correct.
sun
Not
go under
correct.
the disc?
When you said the
That's why I
globe has
didn't.
a horizon,
That's why I
that's
didn't
What is
answer
your
him.
model, dude? What is your
That's
model?
why I didn't answer him, ladies and gentlemen, because it was well beneath our intellect to myself and the listeners, and it was an insult to the truth. So obviously you don't answer those
An
sort of
insult
questions.
to the truth. A flat Earth
And
doesn't
now
have
he's
an
asking a
horizon,
question about
genius.
our
I don't
model.
know if you don't
Now he's
understand that.
trying to strawman us with a model. We never made the claim to have a model. We've never
Yeah,
made
you
this
don't
claim.
really have anything, right?
We've
Without a
never made
model,
the
there is
claim.
no
It's not
product.
requirement.
Without a
It's not
model,
a
there is no
requirement.
product, my friend.
It's
You
not
literally
a
just spent the
requirement.
There is no
last,
product.
you just spent the last 5
Baseless
minutes
claims.
talking about how you had a model. What are you on about?
Yeah, we never had
What
a
do you
model.
want about?
That's
Yeah,
what
we've
you
never
said.
made that claim. I never said that. Not
You
Jin.
just did like 5 minutes ago. Are you like
Not
napping?
Jin
Incorrect.
CBR1.
Not correct. Incorrect.
Not Jin
Not correct.
CBR1. Sorry.
Incorrect.
You just
I've
Why
never
are you
ever said that
swerving?
in
the
my
last
life.
5 minutes.
Gene
Correct,
never
correct,
said
correct,
that.
correct,
Gene never
correct.
said
What does
No,
that.
that
That's
mean?
incorrect.
You
no.
just made a whole
Whoever
position.
said that, the
You just
Gene
made a
said
whole
that, that's
position
incorrect.
claim
You're
about how your
incorrect.
Be
position
careful, you
is
might
Dracula,
get
the
muted for lying.
word
You might get muted
Dracula,
for
stop
lying, mate.
lying. Stop lying,
It's what
Dracula.
you
Why
said.
are you lying?
Do we need to pull
You
up the
Why are
might
you
get
lying?
muted
clip, or
for
are you
lying
just
now.
Why are you
Yeah.
lying, Dracula? Why are you lying?
Yeah,
Don't
dude,
lie.
this is literally on YouTube, genius. We could just reverse the
Shut up. We're
fucking
not
video.
measuring it
Why?
in
We can
reality,
reverse
mate.
Don't
the
lie.
fucking video, dude.
Don't
We're not
lie.
measuring in reality? We know.
Listen, bro, you
Dracula.
think the moon is
Don't lie.
flat. You think the sun is
Don't lie.
flat, dude.
Don't
What
lie.
does that
No, we
even
don't.
mean?
Again, more straw man.
So now the
More
sun and
straw
the
man.
moon are a globe now. Now
We
they're
don't know
globes.
what the shapes are. We don't know what they
You
are,
don't
is
know
what
what
we
the
say.
fucking shape is. Are you
Of course
fucking
we don't know.
retarded, bro? Go outside at
Of course
night.
we don't. No, we don't
Look at
know
the
what the
fucking
shapes are.
moon.
Sorry. Don't know.
You don't know what that shape is. We have
I
no
do
idea
not know
what that
what that
is.
shape is, yes.
We have no
Not one.
idea what that is. What is
I'm
that? What
sorry,
is the
I don't
moon,
know
bro?
what the moon is. Of course I don't know what the moon is. How do I know what the moon is, ladies and
That's
gentlemen?
embarrassing.
I cannot
little
make that
bro.
claim that
It's
I know what the
2026,
moon
little
is.
bro. Wake
So
up.
you can
It
make
is
the claim that you don't know
observable
what the moon is,
phenomena,
but you can
Gene. It
also
is
make the claim
observable
that you know where the
phenomena.
Earth is?
Yes, it's an observable phenomena. That's all we know.
It's an anomaly. It's
Then
not
you
an
can't make a
anomaly.
claim. Then your
That's
claim
right. I don't make a claim as well. I don't. That's the thing. That's what
You
gets
don't
you
make
lot
a
upset.
claim. You don't. But you deny every other claim that doesn't
Yeah.
relate to
Well, of
flat
course,
Earth. That's
because
pretty
that's
crazy,
not
man.
provable.
That's pretty
Not
crazy.
provable. The claims
It's
being
not
made are not
provable.
provable.
Right.
That's why. That's why. They're not provable. So why do we have to accept things
I
that
mean,
we
they are
cannot prove?
provable. You just don't have the money to go do it
No,
yourself.
they're not provable at all, ladies and gentlemen. They've never been proven. In
Well,
fact.
excellent, Mr.
So-
Dracula. Tell us how you've verified some of these bullshit space claims.
Sure.
Yeah.
You know, I can go in the same position and say that I can't. I could sit in the same camp.
Well,
and
go
say,
ahead.
You
Explain.
could appeal
you
to
gonna let me
future
speak, or are you just
fallacy.
gonna
Tell us
automatically
about how you can do anything. You ride unicorns too?
Well, do you have enough money to go and buy a rocket ship, go to the moon?
Tell us about your another appeal to future
You're gonna answer
fallacy.
me?
Do you ride unicorns?
Are you going to answer me?
When are you going to do your space trip, mate, to
I'm
verify
not
all
gonna,
these space
I'm not going to
claims?
entertain autism
Yeah,
talk.
you got
That's
your
right.
money
You're
or
not going to
you got
entertain it because you realise that you've fucked up again.
He's
You're just trying
scared.
to
Dracula
dogpile
is
and talk over me.
scared.
It's
I
just
never met a
retarded.
Dracula that was scared of addressing something.
So if
Dracula
you're
is
willing to have an
scared.
actual discussion, I'm more than
Dracula,
happy.
I
you
thought
why are
they
you
were scared
scared,
of
bro?
garlic.
Don't be scared. Change your
I thought
name
they
if
were.
you're scared, Dracula.
Yeah,
Change your
I
name.
thought they were scared of garlic and holy water. That's
Yeah,
what I
so
thought they
are
were scared
you
of.
able to
Dracula,
go through and get
come
enough,
on, put
procure
your
enough
good
money in your lifetime to
pants
possibly
up
go to
of
space?
It's never
vampire
a
and
place that we're
just
going to be able
address
to
what
go
is
to.
being said.
So I'm
Well,
not saving
tons of
my
people
money
have
to
done it
go to
already.
space, ladies and gentlemen. That's a stupid thing to do because we can never go there. So
Well,
my money
we've
will be well
recorded it.
spent on the earth.
We've recorded it and we
Actually.
witnessed it even in the modern age. We can watch satellites.
No,
go
we
up,
don't witness it in the
watch
modern
tons of
age, ladies and
different things.
gentlemen. What we witness is
You
tomfoolery
might be
and
too poor to
buffoonery
go
from
and
NASA.
actually go out of your way to
From
witness
NASA.
it, but that's
That's
not
what we
the fact that it
witnessed,
didn't
ladies
happen.
and gentlemen, from
Oh
NASA.
my lord, these motor mouths.
So
Yeah.
why does a moon have a crest or a crest?
Because of the refraction of the sun, because of light bouncing off. It's all about relative position.
Yeah.
The sun and the moon do not prove the shape of the Earth, ladies and gentlemen. Don't forget that. When you're looking for the
Nobody
curvature,
ever said
don't
that.
look
You're
up.
just bringing that up for no reason. Nobody
Don't
ever
look
said
up.
that.
Well, no, you're going on about the sun and the moon as if they're some
No,
kind
he
of
brought it up, and I'm responding to the position that he made. You're
Earth's
just too stupid to
existence, and they're
realize
not.
the actual context of the
Stupid.
conversation.
No, you're so stupid. You got your head up your mum's ass. Take it out of
Okay.
there.
Random insult for no
Yeah, you
reason.
want to be silly? Want to start being insulting?
I'm
Then
responding to
insult
somebody
you.
else saying something that has nothing to do with the basis or the claim that the Earth is flat or anything of the sort. What
Well,
are you
I'm just
talking
making
about?
sure that you get the message that we don't use the sun or the moon to
All I've
prove the
gotten is
shape
that
of
you're
the
a
Earth.
fucking monkey and you have absolute
No,
problems with
no,
using
that
logical
I am not.
process.
You're more of a monkey than I am, mate.
Okay,
Honestly.
well, When you can use your head
Yeah.
for logical process, we can have an actual thorough
Well,
discussion.
when you take your head out your grandmother's unmentionables, we might be able to get along. Yeah.
Yeah.
Thanks. Yeah.
I can tell you have a lot of friends.
Oh yeah, I have a lot of friends. A lot.
They all exist.
You know what they
yeah,
call him?
yeah.
You know what they call him, Dracula? They call him Jim Sensei.
There you go.
There you go. What? You never made a position.
He has a lot of friends.
I asked you a
right?
question, and you say
As a
there you go.
businessman, as a father, as a
See
well-known
how nobody
man
else
of
like
his
chimes in your
community,
defense?
and
Yeah,
yeah, he
yeah.
has a
Way,
lot
shape,
of
or
friends.
form,
They
is
call
because
him
everybody
Jin
here sees
Sensei,
you
bro.
as just
So
an
why are you being so jealous?
as a
Why are you
retard.
being jealous that Jin has
Yeah,
friends?
why are
and
you
don't?
jealous? Yeah. Jealousy will get you nowhere, boy.
Seriously,
In
why
other
do we have to
hands,
entertain these two clowns?
Dracula has no friends. Do you know that?
Yeah,
Dracula has
that's
0
right.
friends.
0 friends, 0 fans. Everybody hates Dracula. They run from Dracula. That's why you chose the name, because you're a loner. What a
Dracula,
wallow.
you have no friends. So why are you hating on Jin's friends? Come on, bro.
Yeah.
Do better.
I'm like the sun. I attract a lot of people. See?
This is the
pretty
weakest
bizarre
Dracula I've ever witnessed. The
What's a
weakest one.
wally of a
Them all.
Dracula? Yeah.
Yeah, can you use some like common term English speak? I can't understand you.
Oh, you can't understand anything, can you? Yeah, you've got no
Oh,
experience, Dracula.
Sounds
like a
anything. I
you
said I can't
problem.
understand you
He
because
doesn't
you don't
comprehend
make any
English.
You
sense.
Sounds
haven't
like a
lived
you
yet,
problem.
Dracula. You haven't lived yet. If the tone he's got, if words could kill, ladies and gentlemen, if words could kill, but I'm indestructible anyway. So there you go. Usually the adage is if looks could kill,
More
but in
laughing
this
at
case,
your own jokes.
if words could kill, eh? If words could kill.
Guys,
Young
I need
spewer.
validation. Please validate me, guys.
There you go.
You young
The demons
spewer.
are coming out. The demons are coming out. The brain
Yeah.
worms.
There we go. The young spewer spewing out verbal diarrhea.
How's that verbal diarrhea? It's me imitating you.
You're just
You're not
screaming,
imitating
dude.
at
It's
all.
just like
Well,
straight like
It
retardation.
wasn't
It's
very
annoying.
good, bro. Sounded like you're having some kind of mental breakdown.
It's brain worms. He doesn't know yet.
Yeah, you're embarrassing yourself, man.
It's the Bill Gates vaccines going through him.
There you
Yeah,
go.
we don't talk about that shit in here. Just put those away.
Yeah.
What?
Never mind.
Okay.
Yeah, Dracula.
Yeah, that's.
Do you have any curvature proof for your imaginary ball that you believe in? No? Okay. Shut up.
That's what
Then.
you just said. You just said, "Do I have any COVID proof?" What does COVID proof have to do with the debate?
I didn't say that. Didn't say that at all.
Just said
That
it
wasn't
right
what I
now.
He
We
said
involved
No, he
Deaf
didn't.
Dracula. He said Deaf
Yeah.
Dracula.
Reiterate, maybe I
cannot
misheard.
hear well.
What did you say?
He does. This Dracula doesn't speak English.
Yeah.
He's deaf.
Yeah,
You
what?
speak
He has
Romanian?
no friends.
Very inexperienced.
He
Very,
has
very
no
How's that
friends.
inexperience? Me seeding that I may have not heard you
Bro,
correctly
just
and
change
asking
your
you to say
name
it
to
again.
something else instead of
I'm not going to
Dracula.
repeat
Just
myself, mate.
change your
Never
name.
mind.
He said you have proof of curvature.
I have proof of curvature. Have you ever looked at a telescope?
Yes.
Do you know what a
Yes, when
telescope
I look
does?
at a
Can you describe
telescope,
the
you don't
actions of a
see proof
telescope?
of you don't see curvature when you look at the
Yes,
telescope. He said look at a telescope, India. Just look at the telescope.
I'm waiting.
Yes. Let me look at what do I see when I go? What was the second question?
I said, can you
It was
describe
about-
the process and actions of what happens when you look through a telescope? What is the telescope doing?
Well, it increases your angular resolution for one.
No.
No.
He says no.
Telescopes don't include. Sorry, telescopes do not do anything with resolution.
Really?
I'm sorry.
Can you define? Can you define
That's
me
it.
resolution?
What
Angular
a retarded
resolution
Dracula you are.
is
So
D.
inexperienced.
What is D? D is the diameter. Well, the angle, meaning the smallest resolvable angle, is 1.6 divided by D. D being the diameter of the lens, and the diameter of the lens of a telescope is way bigger than my eye. So yeah, it does increase the angular resolution of what I can
Then
see.
I acted as a
It also
faith
increases the
actor there,
focal
so
length.
that way I
So
could actually get some realness out.
No, you made a genuine mistake because you're a retarded Dracula. That's
No,
what
I
you
just
did.
did exactly what I said. You're just a
You
fucking
No,
couldn't
idiot.
even wait for India to finish his sentence to
Anyways,
reply to
get
your
that
silly
retard on mute.
question.
Can't
You couldn't
stand him.
even wait for
Yeah.
India to finish his sentence. Like, this is the weakest Dracula ever.
Yeah.
Angular resolution is the capability of an imaging system,
as I
such
just
as
said,
a telescope, camera,
yes,
or
as I
human
just said,
eye, to
I was
distinguish
using
small
bad faith
details
acting
or
to
separate
make
two
sure that
closely
you
positioned
were a good
objects.
faith actor.
He's scared of listening to the answer,
What did I
India.
just
He's
say?
just scared.
What did I say, Dracula?
No, you said some words.
You know what the Rayleigh criterion is?
That was a
what, sorry?
great Obama.
The Rayleigh criterion
No, please inform me.
It's a dude on our panel.
defines the minimum angular separation between two light sources that can be distinguished. Expressed as theta equals 1.22 divided by wavelength over d. D is in the diameter of the aperture.
Okay.
Okay. So what do I do looking through a telescope? How does that tell me the Earth is a ball?
It really doesn't. I just wanted to put a little thought process because I don't know.
Yeah,
It's
well,
funny.
we're looking for
It's not pretty
curvature,
firm.
so you said, hey, use this device that doesn't tell you anything.
Did you miss the
You're
whole
useless.
being a bad faith actor part? Or did that go over your head?
Oh, you being bad faith? Yeah, we've
Oh,
been
you're a
witnessing
bad
that
faith
whole thing.
actor? So why are
Yeah,
we talking to you? I'm just paying you now. Why wait?
yeah, there's many witnesses to you being a bad actor, bro. Come on.
Yeah, man.
It's more than 3 witnesses, and with 3 witnesses, you go to jail, man.
We don't have time for bad faith Dracula.
He left.
Dracula.
Dracula left. Dracula was defeated. Van Helsing over the Van Helsing in the house.
He's afraid of flat earth words as well now. Not only garlic and holy water, but flat earth words like level, horizontal, perpendicular, angular
Where's
resolution.
Dracula going? Come on,
Yes.
Dracula, come back.
Angles of elevation. They just destroy Dracula.
Dracula had to walk out in the sun to get some angles of elevation. He failed.
He shriveled up.
That's a good one.
And died. Yeah, turned to
Dracula, where you going, bro?
He was emotionally in pain because we are here as flat earthers. That really hurt him emotionally. You could tell. If words could kill, we'd all be dead. You know, honestly.
Instead of asking him why is he running, I'm gonna ask him why is he
Yo,
flying
you know what's
away.
funny? You know what's funny? Dracula told me that y'all moved him. So it's kind of crazy. Y'all are sitting here hyping
You
each other
all
up like
moved him.
No,
you
we never
all,
moved
guys.
fucking
You all
kicked
moved
him,
him.
dumbass.
You all moved him, guys.
You
You're all
literally
good.
kicked him, and you're like,
No,
"Oh,
we
he
never
left.
did
He
that.
left.
We
He
never did
left."
that.
Shut the fuck up, dude.
No,
He
you shut the F
you
up.
literally moved him.
No, we didn't. No, we didn't. You want to be careful you don't get moved with your emotional, ridiculous
You
outburst.
can't handle me, old man.
Shut up.
You're
You
too
can't handle
fucking
the truth.
old.
I'm not old at all. Don't you worry.
That's why you keep muting me, because your brain is
I
too
don't do
fucking
that.
slow.
I'm not a mod. I'm not a mod, so I can't do that.
No, you get muted because you're a moron. It's got nothing to do with anyone else.
There you are. See? Be careful you don't get booted.
Would anyone like to try and have a conversation with this idiot? I know I don't.
Well,
because
yeah,
it's
I'm
just-
ready. I'm ready to have a try with the
Now, globe
young
mogging.
Stuart.
It's going to be you and Jin. If you carry on like a tard, you'll get muted first and probably booted second. If you're lucky. Floor's yours, Jin.
Thank you very much indeed. Right. So, what's his name? I haven't caught it yet.
You can read it for yourself, my guy.
What's his name?
Globe mogging.
Okay, globe mogging. Okay, Mr. Globe, do you have any proof of the curvature of the Earth on the surface of the Earth? That is right. Don't go to the sun or the moon, because that's not where it's at. If you have that, then I'll be glad to listen. Go ahead.
Do I have
Go
any
ahead.
proof of the curvature of the Earth on the
Yes.
surface of the Earth? Yeah,
Correct.
and in fact, I do actually.
Go ahead. Explain how
It's
you
called the
confirm that.
equator, genius. Called the equator.
That's not proof, ladies and
Oh,
gentlemen.
really? That's not proof? Whoa!
Not proof of a,
I'm glad you
proof of
said
a
that.
spherical
I am
ball.
definitely glad you said that because you just got trapped, old man. Like it's a
No,
fucking
not
game
really.
of
No,
chess.
because we're talking about
Yeah,
spherical.
really, you did. Yeah, really,
No,
you
not at
actually
all,
did.
ladies and gentlemen. We're talking about the curvature of the Earth on the surface of the
Oh
Earth
my God.
in relation to the
So are you gonna
spherical
let me
ball.
Hey,
explain
so
myself? Because you asked
Globetard,
me a very important
instead of having a
question.
meltdown,
Yeah.
instead of having a meltdown like you've just won the lotto, why don't you explain to Jen how some imaginary line that's on the ground is going to prove curvature?
Oh, right, some imaginary line. Oh well, in
Yeah.
fact, I can explain that to you, my friend. I actually can explain
Please.
that. So you do understand Jin, because I'm addressing Jin, not the guy that keeps interrupting me from New Zealand. But you do understand Jin, that there's something called temperature. You ever heard of it? Oh yeah, of course you have. Of course you fucking have. So, my friend, if you go to the equator and take a temperature read, which I'm pretty sure you can do on your fucking phone, and you don't even have to leave your house. You could just look up a country that has the current location is the equator, right? You want to find a country on the equator, check what temperature it is. Oh wow, look at that. You don't even have to fucking fly there. You can check it on your phone. And then you maybe go up 400 miles, 500 miles,
When you say
600,000,
up,
and you
yeah,
keep
when you say
comparing
up,
these
go
temperatures.
back, go back,
Whoa,
go
whoa,
back.
whoa, whoa,
When you
whoa,
say
whoa,
up,
whoa.
yeah, I'm trying
Exactly.
to make. We're trying to
Exactly.
clarify. Look, you're a fucking idiot. You've taken a temperature at a country on the equator. That's great. Now the problem we've got from baltards is up is a whole myriad of different directions. So when you're saying up, do you increase your elevation? Are you going north? What is your definition of up? So we can be nice and clear about this.
My bad, dude. Yeah, my bad, bro. So if you start at the equator and you head north, yeah, a direction. So, and you check all these little countries that are close to the equator, and then you check countries' temperature in, let's say, Europe, and then you go to the North Pole. You know why it's like that? Because we're on a fucking globe, and different locations of the land are closer
hold
to
on
the
a second, hold
sun
up.
than other
Hold up,
locations.
hold up.
Okay, you understand
How much
now?
closer to? How
Do you
much closer
understand?
to this?
So
How
the
much
land
why are you still?
that's
I'm trying to.
around.
Yep. Obviously, he's not fast on the uptake. How much closer to the sun is the equator? So I'm going to grant you your baltard. How much closer to the sun is the equator than the North and South Pole as a percentage?
So can you stop strong arming me and let me explain, my guy? Because like it's old, bro.
Hey, Matrix,
Yeah,
don't
no.
stop it. Don't stop. Just keep at it. Don't stop.
Yeah,
Yeah,
because he
because I'm
says to
trying to
Wally at
explain
the
something to Jin, and
Yeah,
you're
but
like,
we're
I'm
not trying to
listening, but
hear to your nonsense. I'd
yeah,
rather
it's
listen
just
to silence,
We,
actually.
garbage
we,
at the moment.
we've got no problem globe mogging. You trying to explain things to Jin, but you jump all over the place. So I'm just trying to keep you in a straight line here, mate. That's all.
Right.
So at the
Yeah.
moment, you've gone to the equator. You've taken a temperature at some country. Doesn't really matter which one. So you've gone there. You've taken your temperature. Now you're traveling north, and you're taking temperatures all the way to the Antarctic, Arctic. I don't give a shit. It's cold there. So how is you having different temperatures prove the shape of the ground? Let's go from there.
Thank you. That's it.
So basically, that's how we know there's a shape, right? Because all these different.
Yeah. Let's link the temperature.
No,
Then go
dude,
back.
let me speak.
You've taken your temperature.
No,
Yo,
don't let him speak.
Yep.
Don't let
We've
him
So
speak.
all
taken the
these different
temperature.
temperature changes.
How are you associating?
Right? That's how we know
See,
there's
this
a
is what
globe.
we're. Yep. We're just gonna go click.
Yeah, click him. Click him.
How
Yeah.
are you associating temperature change with Earth curve? What is the linking factor?
So where the equator is, that's the globe.
Up in the sky,
Better
the
term
equator,
for a
up in
different word, but
that
like bulge, bro.
up in the
That's a
sky, the
bulge, man.
equator, up the celestial
So
equator, up in the
that part
sky,
of the Earth is bulging towards the
up in the
sun,
sky.
right? And
We're
a
talking
person
about the
standing
ground, not the sky. Come on, bro. Stop it.
on the equator
Stop it.
is going to
Stop
be a
it.
lot
Globe.
hotter than somebody
Stop
standing
it.
in the North Pole, my friend. So why the fuck would a flat Earth have different
He said the
polar
equator.
and deserts
That's up in the
and
sky, man.
jungles? How would a flat Earth
Gen
have
Z, you're a
this?
fat loser. Shut up.
That doesn't really make any
Okay,
sense,
thank
bro.
you.
You know, a flat Earth having different temperatures all around the globe.
No,
that
we're
doesn't
not
make
talking
sense,
about the
man.
flat Earth. You're telling us
It
how
just doesn't make
temperature
sense.
you're telling us how temperature variations, these
Yeah, it's called the
temperatures
globe,
that
man.
you've
The
taken.
globe.
Yeah.
Yeah.
Hold on.
I
know
haven't
you're
taken 'em.
excited.
I haven't taken these temperatures.
Why doesn't he just shut up every now and then?
Yeah.
Allegedly, you've taken temperatures at the equator. You've gone north. You've taken another one. You've gone further north. You've taken another one. How has these temperature variations got anything to do with the shape of the ground? You still haven't told us that. Basically, this is you. Temperature variations, it's got to be a ball because temperature variations, and I'm not going to stop talking because the whole fucking world's going to stop, and I'm still going to prove it's a ball. Bro, you haven't proven shit.
Yes.
You've told us so far, temperature basically gets colder, therefore globe. How have you associated temperature differences with shape of ground?
Thank you very much, Matrix,
Okay,
because that's
yo,
what I
all
haven't
right,
said
dude.
anything.
I know you're a little slow here when it comes to technology, but you can actually
He's
see
fast
wind
with
on
the
an
mute button.
infrared
He's
camera.
pretty
Did you
fast.
know that?
He's
Did you
quick.
know you can see
He's not
wind on an
slow. He's
infrared
pretty
camera?
quick with the mute
Did you
button.
know
You know.
that? You
Listen,
know
That he's
why?
pretty quick with the
Because
mute button.
wind.
He's not slow, bro. He's pretty quick.
Yeah,
Super quick.
and by the way, we love infrared, so that's right down our alley, actually.
That was
But
not an
again, we
answer.
still want to know how temperature variations prove shape.
Indio, that's what he does. Not answered. That's him.
There we are.
He's
You
probably
see?
spoken. He's probably talking to the wrong people about infrared. Holy shit.
He's always
Yeah,
talking to the wrong
right.
audience. Every time he speaks, speaking to
Yeah,
the wrong audience.
yeah.
Always. In every answer.
Let me give you a
So,
very simple explanation, ladies and gentlemen.
Oh, you guys
You've
are
got to,
familiar with this one? You guys know this person?
Yeah,
oh
yeah.
yeah.
Yeah,
Oh,
yeah,
of
okay.
course.
That's why we're having fun.
That, that's why he's
yeah,
Until the next
interrupting
one comes
because I
in.
mean, what else can we do? There's no fixing this guy. It's just it's done. It's game over.
yeah. Let's
GG.
explain different variation temperatures on a flat piece of metal, ladies and gentlemen. Okay, and we heat up the metal at one corner, and that temperature then starts to move through the metal as the metal absorbs the heat. So you're going to have the hottest part at the source and the lesser hottest parts at the extremities. There you have different variations on a flat piece of metal. This man's lost, isn't he? Completely lost. If he thinks temperature variations prove a shape, they do not. There
Well,
we
he's
are.
still got that, so we can try to get this out of him. I don't know if he's going to work it out yet or not. I'm hoping he's just going to concede and say, you know what, temperature variations mean nothing. But let's have a look.
Yeah, go ahead.
Okay, globe mogging. How have you attributed temperature changes, as in temperature getting colder, with the shape of the ground?
Yeah,
Hmm.
from the
How
equator.
have I? I already told you how, dude. You're just sitting here like going back and forth with each other about like
You've got
nonsense,
nothing,
and you're
bro.
making up
That's
bullshit, which is
no,
actually
no.
insane.
You're making up bullshit. We're
No,
just
you
calling
are.
you out on it.
You are. And
No,
you
you are.
sell flat Earth
No,
merch,
you
bro.
are.
This guy was
No, you
literally
are.
plugging
No,
a
you are.
book a couple of days
You
ago.
are.
He's like, "Oh, we're actually making a flat Earth book." Like, shut the fuck up.
Wrong
You don't even
person.
believe in flat Earth. You're
It's
literally
already been
doing this.
done.
You're
There's a book
LARPing for
already
money.
out.
You're literally
He's broken.
LARPing for content.
There he
It's
goes.
crazy. It's
You
crazy.
finish
You're
me
Two
up?
books
literally
out
So,
LARPing for content. You know why
Yes,
you never say you're
yes,
a
you're
flat Earther?
crazy. We get
Because
it.
you aren't
You're
a fucking.
crazy. We get it. Yeah.
God,
We
you're
get it.
there we go.
poking hard, man. My God, your
Yeah,
butt hurt is off the chart.
He's
yeah.
broken, isn't
He's
he?
emotionally
Hey,
upset.
where's Yoder's butt hurt cream, dude?
Yeah, he's emotionally in pain because of flat Earth. In pain.
Dracula was better, Indio. Dracula was kind of better sportman.
Globe mogging.
Hey, I'm gonna ask him.
Horrible.
Let me ask him a question.
Hey, let me ask you a question. Who
Hey,
gets the
no, I'm
YouTube
gonna
ad
ask you a
revenue?
question.
Who gets
No,
the YouTube
dude,
ad
you're
revenue?
not in charge here. You're not the guest mod.
Flat
I'm in
Earth
charge.
is.
Look, dude, really simple question. If the Earth was flat, how would it make you feel?
Show me a picture.
How would it make you
What?
feel?
Show me a picture.
I said, if it was flat, how would it make you feel?
Show me a model.
No, you
I
don't
can
want a
show you a
model
model
of a
for a
flat Earth.
globe
You want
Earth.
look.
I
No,
can
you
show you a
can't.
globe Earth model. Show me a flat
No, you
Earth model.
can't.
Yeah, I can.
Post in the chat right now.
I can't post in chat. I'm banned. Someone banned me just now.
What if you were gonna post it? What would it be? Would it be Google Earth?
Someone literally just banned me just now because they don't want me posting my evidence and proof. That's crazy.
How is it?
Y'all
What is
work
a
quick,
model
huh?
evidence
Y'all
of
work
it?
quick. Y'all work quick, huh?
What is a
How's
model
this,
evidence
India?
of?
Hey, check it out. Infrared flat. Oh, that's got to be a bitch.
Ouch.
Let's see your flat Earth model, dude. Come on. Where's the
You
sun?
don't
Is it
want
in
a
the
model of the
middle?
flat Earth.
How
You want a
far away
model of
is
the
the sun to the Earth on a flat Earth? What
Okay,
happens if
that's a
the
model
sun
of the
fell out the
sky.
sky and fell
That's
into
not
the
a
Earth?
model of the Earth. That's a model
Like,
of
I
the
got
sky,
so many
dummy.
questions. Where's
We
the
already
ice wall?
have
How
that,
tall
dude.
is the ice wall?
We
What
already
happens if
have
you go
that.
past the ice wall?
We
You know
already
what I mean?
have that.
What's under the flat Earth? Like, is
Look,
it
we
just more
already
rocks
have
and
that. No
shit?
one said there's an under. Stop
Oh,
straw
right.
manning.
Oh, we live in a fucking dome
You
like the
wanted the
Simpsons
flat
movie.
Earth model. I'm trying to give it to you, but why are you
There's an
filibustering?
invisible
Why
barrier
are you
at the edge.
filibustering? I'm gonna ban you if you don't shut up. You wanted the flat Earth model, right?
Go ahead, dude. Let's see
Time
it.
it. Go on. You want to know what time the sun's gonna rise tomorrow where you live?
Oh, dude, let me just check my weather app
You,
on my iPhone, and I'll tell
okay,
you.
you're banned.
Yeah, retard.
Do you want the flat Earth model that will predict when the sun rises tomorrow at your place? Yes or no?
Bro, this is irrelevant.
Bye. You asked for it. So what he demanded, it's irrelevant. It's crazy.
Yeah. Like you said, he was coping really hard.
But it was irrelevant. He was correct. That's the only true thing he said. Fucking model of the star or the sun or the sky is irrelevant.
Exactly.
Damn, is that a forest fire in the distance, man? You see that column
No,
of smoke?
actually. No, it's not. It's actually something nasty on my sensor.
Oh,
I've got
is
to
it
clean it.
permanent?
I think it's just a bit of dust, but it goes
Oh,
across
okay.
a couple of photos, so I know it's in the camera, which I'm not happy about. But anyways,
Yeah, well, there you
drive
go.
for an hour and a half, go for a little walk, take some awesome photos, drive for an hour and a half home, come back, and there's little dots on me pictures. It's like, oh man,
Nice photos, man. Damn.
Yeah, he put
I
his foot
don't
in the
know
bucket.
how far that is. So at the moment, I'm trying to work out some kind of marker, identifier, anything to work out how
Yeah.
far that was. But
Yeah.
elevation wise, I'm 300 meters above that plane, and that plane
Okay.
is about 130-degree view, dead flat right across the lot of it.
What do you guys think of the Artemis 2 picture?
Absolutely
Not as nice as
awful.
my pictures.
Awful. I guess you could say they're AI, but I mean, this one looks kind of real to me. Looks like they have the reflection of the person in the mirror, or like in the window, and then they have the moon.
Awful because we know they're in a studio doing it.
What do you think of the lack of pictures from the Artemis mission? The lack of the video footage from the start to the finish? Like,
Thank
shouldn't
you.
there be
Yes.
something like that?
Don't they
You
have
should be
like a
demanding your money back. I want a refund.
But they got like they had live streams, they had fucking videos, they had pictures.
Of them slingshotting around the moon?
Well, no, not of the. I guess not of that, but it's kind of hard to tell
Why not?
because you can't take like a third person
What, they
picture.
couldn't put an iPhone up in the fucking window and record the shit, dude?
Well, it's a little bit different than that. You'd be looking at a black screen the whole time. It'd be hard to tell. Like it'd be a window of darkness, right?
So
There's
why don't
nothing
they?
there besides a bunch of stars.
Why don't they take a camera that's capable of picking up the light, starlight?
What starlight of the sun?
No, the stars.
I think they did.
iPhones can't pick it up from space, allegedly.
That's bullcrap. I don't know who said that.
All the photos from their iPhones where you can't see any of the stars.
Weird. Because you can go out with your iPhone right now and go look at the sky and see a bunch of lights, right?
Yeah, but you're coming
Granted,
from a place of light.
coming from a place of light. Not at nighttime.
There's still more light on Earth than there would be in theory behind like the dark side of the moon.
That's true. That's true. But like that's kind of like what I'm saying though is if they took a picture from the dark side of the moon, you're not going to see much at all. It's going to be a black photo.
Off an iPhone.
Well, off almost any camera, unless you turn the gain way the hell up. And I guess NASA
I'm not.
engineers don't know what gain is.
Seems like NASA engineers don't seem to know a lot conveniently.
This one's kind of weird. Some of these look fake. I'm not gonna lie to you. Like this looks fake as hell. This right here.
That's why I said absolutely awful images.
Yeah,
exactly.
check this out. That looks fake as
That's
hell.
how you
That
know
looks
it's
like
real, right, bro?
that looks AI generated. I'm not gonna lie. That moon looks terrible.
You can tell it's so real because it looks so fake.
Yeah. That one's kind of fucked. Why do you think they can't get to it though? Because it doesn't exist.
We don't have the technology to be in that environment. It's a natural law violation. Second law of thermodynamics. There's no way we're doing that. So they're lying. Okay. Once you realize that, you don't get so wowed by their stupid imagery. You get annoyed and you want a refund if you're an American taxpayer. You see, that's the response. You should be demanding your money back and the shutting down of NASA. Stop this buffoonery already.
Why would they? Like, what's the reason to cover it up? Just to like steal tax dollars?
Well, they're going
Like
to
why?
cover it up because they can't go there, obviously. So that's
Well,
one reason.
yeah, but
That's
behind
one
all of
reason.
it, like why? So if they're gonna cover it up, what's the purpose of even covering it? Like, what's the whole purpose to begin with? Is it just to get
Tax
tax
evasion
dollars? Well, the government can't evade taxes if it's the ones
or
charging
whatever,
it.
like making money.
Yeah, and then the control of the human race, mind control.
It's just so all you're saying is like it's a way for the U.S. government to get tax dollars out of the payer. It's like it's a reason,
Who knows,
basically.
dude? Who knows what the reason is?
There are
There
multiple
could be
reasons.
yeah, there could be a
Yeah.
million different reasons, man.
Yeah, there are multiple reasons. The main one is they've got the whole Earth, the population of Earth is believing in something that's not true. Okay, that is going to space isn't a true thing, but they've convinced everyone. Once you've done that, you have to sustain the lie, and that's what they're doing. They're doing it to sustain the lie that they've been telling for the longest of time. Okay, fooling everyone, and it's been very lucrative at the same time.
It's a bit like Christianity.
Well, I mean, that's all very well and already was said and done, but I'm not losing any money to Christianity. But the taxpayers are losing to NASA, aren't they?
Yeah,
Through the
yeah.
government's expenditure. So there you are. So it's in fact worse than Christianity in that sense. Christianity, I don't mean Christianity is bad because that's someone's religion, and I don't have any right to say that religion is wrong. And I don't say it's wrong. That's your religion. Good luck. That's all I say. But NASA stealing your money, telling you they're going to space, and they've landed crafts on Mars, etc., and that's a gross misuse of your tax, and you need
It's
to
weird
have a
that
refund.
somehow back in the 70s they were able to land an aircraft on the moon, but they can't do it now.
Yeah, it is weird, isn't it? Yeah,
Yeah,
exactly.
and they've
That's
got all the
technology.
resources in the world. You know, that's what 60 years of technological advancements, and they can't take an
Yes.
Apollo mission out there and go land it.
Yeah. You took the words right out of my mouth. That technological advancements have been made all over the place, but yet we're going backwards, apparently.
Well, the way that I think the way that Apollo is supposed to work is this mission is just to kind of test the rocket and the technology, and then they're supposed to land on the moon at some point, have a rover, and then build a moon base.
Right. That would be the Artemis, not Apollo.
Yeah, Artemis. Yeah, the whole Artemis missions. Yeah.
Yeah. Right. Yeah. Supposedly. Right. But they've never ever been to space. Apollo never went.
What
So
about
it's
the
never been done.
ISS?
Well, that's the ISS, I call it. Yes, that's not up there either. There was
Well, it's
something up
not.
there that's a light. There's a light up there, but I say a light does not an ISS make. So there you go.
That's
I
not
don't
like.
accept.
That's not. That's not in the orbit of the moon. That's in the orbit of the Earth.
The Earth is not a ball in the first place, so they're not orbiting the Earth in the sense of a spherical ball, but orbiting above our head. Okay, but it's a light. We don't think it's the International Space Station with people in there traveling at Mach 25, 17,500 miles per hour, 5 miles a second.
So, do you think that it's in a studio?
It's definitely in a studio. NASA owns 24 fully equipped to the latest cutting edge equipment of these studios, more so than Hollywood combined. Okay, 24. NASA. Oh, yeah. So they're in a studio somewhere. They've always been in a studio.
You got a link or something? I can look this up. I guess I could just chat GPT.
Well, yeah, you use that. That should help you along. Just ask it. Is NASA in the possession of any film studios? How many do they have? And then the question would be, why would you need so many studios? NASA, what are you up to? You know, studios means you're making film.
Well,
Oh,
Chat GPT says NASA does not own any major film studios in the way companies like Warner or Universal. What NASA does have is a media division where they produce live streams. Yeah, yeah. Okay. Well, I guess you could guise it under the false pretense that it's not a studio. You call it a media department.
yeah. They've got these big, massive warehouses which they use to store equipment, and then they double up as studios as well. NASA owns those kind of buildings. Yeah, and I've seen where they have the cables in the ceiling and rails, and and the screens moving along. Seen all that. Okay, NASA is in the possession of that kind of a technology. Why would you need that? So they're not going to space, that's for sure. It's not possible. The equipment doesn't work in a vacuum due to the phenomena therein. And these phenomena are the cold welding, where things get so frigid that they seize up and stop moving. Then you have the outgassing, what you would call off-gassing in America. MIT calls it degassing, where the molecules that make up the piece of equipment subjected to the vacuum begin to turn into gas.
Doesn't
Okay?
the camera lens has a vacuum inside the lens, right?
Not the cameras that they took to the moon. They were not sealed at all. Okay? So if they went to the moon with the Hasselblad had no radiation protection, and they were not vacuum sealed. Okay? Right.
Wait, say that word again. The Razoblad?
The Hasselblad. Hasselblad.
Hasselblad.
Yeah, that's the name of the maker of the camera they took, supposedly to the moon. They were not vacuum sealed at all.
Oh, you're talking about back in the day.
Even today, they're not vacuum sealed. We don't need it. They don't need to be vacuum sealed here on Earth. They're living on Earth. Digital cameras work perfectly well.
No, but they do that. I think the reason they do that is so that no moisture can get into the lens and obscure the.
They didn't do, like I just said to you, they were not vacuum sealed for the Apollo missions, supposed missions, right? And then the Artemis one, they again, I don't recollect them saying they used Hasselblad. Right, there you are. They were using Nikon, from what I understand, Japanese.
You know, the Nikon cameras, those all have like gas filled chambers in between the lens and the actual photographic diode.
You'll have to prove that. As far as I was concerned, they weren't vacuum tight at all.
But they do that with scopes. Like, you know, I have I got a bunch of guns, so I have a scope on my gun. It's a, what do they call it? It's a not a loophole. The other one, the Night Force. Night Force. They have gas sealed chambers in the lens. So like, you figure they do that for a camera too, right?
Yeah. Why would you have gas filled scope? Is that
Because
so
of
no
moisture.
material can get in?
No, it's moisture. It's so no moisture can get into it because moisture is going to obscure the view.
Yeah, you would have condensation build up.
Exactly. Yeah. And so that's why they fill it with gas.
Yeah, again, I'm not sure that they did that for the Hasselblad. You'd have to look at that. And again, vacuum sealed, that would be the film as well. And they said no, they were not vacuum sealed, according to Jan Lundberg, who is Mr. Hasselblad himself. Jan Lundberg, his name is. The Hasselblad camera had no radiation protection, okay, and they were painted silver. And he said that the film itself couldn't withstand the temperature variations from plus 150 degrees Celsius to minus 150 degrees Celsius. It may fare well in the heat, but in the cold, it cracked, he said. Quote, unquote.
On Apollo 2, they used the Nikon DSLR.
You mean Artemis 2? Yeah, Artemis 2.
Artemis 2. That's what I said, didn't it?
What camera did they use?
Well,
Nikon.
My fault. Yeah, the Nikon.
Yeah.
Dude, that's a
we say
fucking
Nikon here in
expensive
Japan.
camera. Holy crap! That's a $3,000, almost a $4,000 camera.
All right. Yeah, Nikon.
Whatever, dude. My fault. I'm not proper.
Yeah. Nippon. Nikon.
I don't have that British accent or whatever you got. Flagship
Japanese
DSLR.
pronunciation, isn't it? Nikon is English. Nikon is Japanese. Yeah, $4,000 camera. Very pricey. Again, it didn't.
You're lagging out, buddy.
And I'm sure 10 times 17 for that. I'm sure it would begin to get houses. So it wouldn't be so. Here on Earth.
There's a whole forum on this.
In a vacuum chamber at the level of 3 to the minus 10 torr, and they put film inside the chamber, and the film was destroyed. meaning that the material known as the emulsion started to separate and run into each other, bled into each other. So the cyan, the yellows and the pinks, the blues, all bled into each other. And they
For
still
my
use it,
American friends, he means cayenne.
which was very odd. So how did NASA
Cayenne.
manage to perfect that and keep the film from being destroyed on the lunar surface at 10 to the minus 11 torr, for example?
Yeah, I just kind of jumped in. What are we talking about?
Camera that was used for the Artemis 2 mission.
It was just
Yeah,
like a
what about that
regular
camera?
off-the-shelf DSLR. It was like a Nikon 300 or whatever the fuck. It's like a normal camera.
Yeah, that's right. Looks like a normal camera. That's what I heard. Nothing special.
Yeah. Yeah.
Yeah. So if you were to go to space with it and be on the lunar surface, for example, you would experience some outgassing going on there.
But they weren't on the lunar surface, though. They were in
No, no,
a
wait.
pressurized.
No,
Wait.
Yeah.
A DSLR is just a digital camera. Like it just has glass and metal. What would outgas?
Yeah, but they didn't ever go outside of the craft to take pictures. They were inside the pressurized chamber the whole time.
Yeah, I did say if, though, didn't I? I didn't say they did go out. I said if. If they're in that
Yeah, but I wouldn't
spacecraft.
be surprised if a Nikon DSLR would still work in the vacuum of space.
It would work
Not
until the
any contact.
outgassing. Yeah, until the outgassing
What?
rendered it useless, of course, because it would outgas
What is
the materials that make
outgas?
up the camera. Yeah, the materials that make up the camera, the body of the camera, and all the workings would eventually outgas and stop functioning, without a doubt. Yeah.
Okay, so if I place a sphere of stainless steel in the vacuum of space, how long will it take to outgas?
It will outgas. I can't give you the exact time, but it would outgas for sure. And I think the cameras are made of all kinds of material, not just stainless steel. You know, bits of aluminium,
stainless steel,
plastic,
aluminum,
rubber,
yeah,
all sorts. Yeah, it's all going to outgas.
Yeah, some of the most chemically stable
all at
materials
different
known to
rates.
man.
They would
Right.
outgas at different rates, but they would outgas all the same.
So this is a claim I'm unfamiliar with. Can you provide any sort of scientific study about the relative outgassing
Well,
rates
you can
of
search for that.
materials?
You can use AI and search for yourself. I did it. That's how I
AI.
learned.
Oh.
Yeah. Why
No,
don't
I
you
don't.
use your AI?
I don't accept AI as a source. I'm
Oh,
sorry.
okay. Then
I need
go.
you to provide.
Then go to the Apollo Detectives. Okay. Go to the ApolloDetectives.com, right, and then go to their playlist and look up everything to do with vacuums, or go to their video section, and there's a lot of stuff on vacuums and how they subjected film to a vacuum, for example, and what happens. I can post that in there for you. I can give you a link to the film outgassing. I can do that for you.
Yeah, that's what I'm asking for. I'm asking for this. I know we're in the flat Earth chat, but do you believe in space and satellites?
No, I have no belief in satellites or space. I do hold the position that satelloons, of course, exists. Yeah, that's electronic equipment attached to helium balloons. No problem there. That I do
How high
accept.
up are the helium balloons?
That I do accept. Okay, I accept that.
How high up are the helium balloons?
Oh, they can go up as high as 24 miles and a bit more, 30 odd miles up.
So you're telling me that the GPS satellite furthest from Earth is 30 miles up?
I don't accept that there's a GPS satellite out there, so I don't.
Come on, stop playing word games. You know what we're talking about. Whatever you accept is the source of the GPS signal.
That would be from fiber optic cables and cell towers, is what I accept, and then military radar systems Those I accept. Satellites in space, I do not accept.
So how do you get the signal on your phone if you're using Google Maps?
It's coming from a cell tower.
No,
Not from any
okay,
satellite.
all right, man, come on. It's like pulling teeth, man. So if I'm out in the middle of the ocean,
That's where the
and I
signal
have a
comes
GPS
from, is
coordinate.
cell towers.
If I'm out in the middle of the ocean and I have a GPS device, how does it know where I am? Answer the question. Like, how does it know?
Have you ever
Where's the
gone
signal
out in the middle of the ocean to test it, see if it works?
Airline
I'll take that as a no.
Have airline pilots use GPS?
Why is it they instantly jump to something else when they get pressed? Have you ever gone out into the middle of the ocean to test this? A yes or no will suffice.
I haven't gone to the middle of the ocean, but I have gone.
Excellent. So thank you for your claims. You may as well just get a face cloth and use that. Go and wipe your head.
I have gone to a region outside the range of cell towers and used a GPS device.
Just not the middle of the ocean, where your story's all about.
Helium
No,
balloons,
dude.
man.
I
They're
was.
fucking
We were.
helium
I was just.
balloons.
It doesn't. Okay, so seriously, dude. Okay, forget about the ocean. Who cares about the ocean? Why? How do GPS devices work? Answer the question. Stop running away.
I haven't
No
run
one's running
anywhere.
away.
Oh.
Yeah. We just told you. GPS.
Where does the signal come
If you're close
Cell
enough to a cell tower, it comes from a cell tower. If you're not
if
within
you're
the
out-
range of a cell tower, it comes from a helium balloon, helo, whatever this guy said.
And there are always enough helium balloons. Okay, so these helium balloons, how high up are they? You said the max is 40 miles.
$24 miles, 30 miles. Yeah.
30 miles. So what you're telling me is every region on Earth is covered either by cell towers or
Absolutely.
helium balloons, a maximum of 30 miles.
Absolutely, yeah. No problem there. Absolutely.
No, you see no problem with that?
No problem with that at all. It's usable and workable technology that we're using. No problem
You're
at
telling
all.
me that every inch of the Himalayas is covered by a helium balloon.
Now you're being ridiculous. Every inch. Don't forget that these helium balloons give out a signal to a certain range, so you don't have to blanket the whole of the Himalayas with balloons. Come on now.
Are you fucking dense on purpose?
Oh,
You know what
really?
I mean?
Are we going to go?
You know
Are we
what
going
I
to go
mean.
down that road? Do
You
we
know
need?
what I
Do we need
mean.
the insults? Do we need the ad homs? Do we need that? Am I
All right,
insulting
let's
you?
rewind.
Yeah.
A
Am
little
I?
bit,
I'm not
honestly.
insulting you at all. I haven't insulted you at all. I've said nothing
But yeah,
to
honestly,
insult you. I haven't called you dense. I haven't called you a cunt. I haven't called you a
I'll
fucking
explain
arsehole.
to you.
None of that, have I?
I'll explain to
So
you. I'll explain to you the insult, right? The insult is that you would think that when I said you can't, you believe you are asserting that the entire every inch of the Himalayas is blanketed by satellite
I didn't say that.
balloons.
I
You're the
didn't
one
say
that
that.
suggested it, so you've insulted
Yeah.
yourself, you clown.
No,
Stupid cunt.
you're
Now I'm calling
saying
you a
that when
cunt
I
now.
said that, you're saying that when I said that, I didn't mean that every
No,
inch
how about
would
you stop
be
strawmanning?
within range of a
You're saying, yeah,
transmitter.
we've had enough. Zip. You're an
Yeah,
idiot
zip.
last
I
time
love
you
that.
came in, you're an idiot the time before, and you actually ran away the one before that.
Yeah, so you get zipped up. Zip. I love it. Zip it
So,
up.
how about Clown Show Mechanic? You start again. Stop strawmanning. When he tells you something, if he says cats are purple, don't go, oh, but you said, and then ramble on with some fucking non sequitur bullshit. Attack his claims directly. Not some broken ass random idea that you think you've got out of what he said. Seems to be a common fucking theme. Does me head in.
Yeah.
So what's your? How about we just rail it straight up? What's your most favourite proof of curvature? You've just dropped into a flat Earth channel. You're going to lay it on the table. You're going to present your facts, and you're going to light your big fat ass stogie up, put your feet up, and say "fuck you." That's the type of evidence I want to see on the table. Put it down now.
Yeah.
Floor's yours.
I've also, yeah, and in the side chat, I posted the link to the Apollo detectives' findings of film subjected to a vacuum, ectochromac 100 film, which NASA supposedly took to the moon and back, subjected to 10⁻³ torr vacuum chamber here on Earth. Okay, and they discussed their findings. It's all very good. There you go. All right, nice little link there for you. Clearly,
Right,
his
Jim,
source.
can you provide any evidence that every inch of the globe is within reach of a helium balloon signal 30 miles max above the surface? Can you provide some evidence of that, or any source or citation?
Well, ladies and gentlemen, clearly I would not be able to do that because in order to do that, I would have to have access to all of those. I don't have access to all of those helium balloons, but we know they're there because we're communicating right now. We know they're there because we're communicating right now. I'll give you a collage. The best I can do is I'll show you an image of said technologies. That's providable for you. Give me a few minutes. I can do that for you.
No, don't do that. Don't do that. Do that. Here, I have
No, I want to
outage.
do that. I
All
want
right.
to do that, and I'm going to do
No,
that.
no, hang on.
So you can actually visualize, because visualization is also part of our experience. And I'd love to do that. I'm going to do that. So there's no stopping me now.
Oh my God! You're gonna do some irrelevant shit that isn't gonna contribute to the
Look,
conversation. in a
listen,
meaningful way.
stop being so negative, man. What are you scared of? Calm down, relax, chill, and hang loose.
Well, all of you guys just really love to hear the sound of your own voice. I'm not even kidding.
We're cool. We are very cool. We flat earthers. We don't get ruffled up, man. We don't sweat the small stuff.
You don't get ruffled up. Have you met Jedi?
It's okay.
Actually, yeah. And if you've wound Jedi up, that means you must be some kind of special tard.
There you
Dude,
are.
I mean, you guys don't get ruffled.
Yeah,
Have
dude,
you
that's
met
great.
Hammer?
Notice
That guy
how
has
the
the shortest
yeah, we're just gonna
zip.
Conversation's supposed to be of the shape of the ground or any other factors attributing to, not the fucking flat earthers themselves. This is why you get muted. This is why people call you a clown. If you haven't worked that out yet, there is no hope for you.
Yeah. You notice we're not insulting you as such, but you
I
will throw
I've
those
got no
insults.
problem with calling him a clown.
So if you check the side chat there, there's a picture of the ground from the top of Mount Everest.
Yes, and if you look in the side chat, I
So,
posted
wide angle
some of
lens. That's a great shot. Who took it? Tell him thank you very much. That's an excellent photograph.
See, I
What
like
are you
y'all
trying to
because
prove?
you pay attention to details.
Yeah. What are you, Zeons? What are you trying to prove with
I'm
a
not
beautiful
trying to
shot
prove
like that?
anything. Nice, it is a beautiful shot. I'm trying to say that this was all I'm saying is this was a picture that was taken from the top of Mount Everest.
Okay, and
I don't know what camera they're using. I don't know what lens. I don't know.
We're
if it's
trying
a
to
wide
establish
angle.
the relevance of said picture.
The relevance of said picture is that you see a curvature, right?
Yeah, due to a wide angle lens. And
that's what I'm saying. Because you think it's a wide angle lens.
Wide angle lens, fisheye lens.
So every picture that was ever taken
No.
from the top of Mount Everest
Hey,
is a wide angle.
Zeons, just so you know, I'm an amateur photographer, and I was actually out this morning taking photos from up on top of hills and shit, mate. So, you posting pictures with alleged curvature when we know that fisheye lenses and wide-angle lenses produce the same effects is not really going to be of any use to you. We're just trying to...
When you take a picture, when you take a picture from the top of a hill, the hill could be 500 feet. Big deal.
And
this is the
so
biggest
what?
mountain on Earth.
And so, size of mountain, therefore, fisheye lens magically doesn't work.
No, it
What are you
definitely
trying to,
works.
What's the
But
logic behind this?
The effect is going to be greater. With a wide-angle lens, that effect is going to be greater.
Excellent. Do you know about what happens when you've got a wide-angle lens or a fisheye lens So I want you to imagine there's a horizontal line smack through perfectly in the center line of your camera. Now, if you put your horizon above that horizontal line and take a photo, and you put the horizon below that horizontal line and take a photo, you know a horizontal line that you've just taken a picture of will appear convex and concave dependent upon which side of that line you're on. You do know that?
No.
Or you didn't know that?
No.
Well, you do now. Excellent.
I do.
So
I
yeah,
do
so
now.
a fisheye lens has basically a line horizontal. So if you are above the line, you'll get one effect. If you are below, you get the other. And this is amplified the further away from that central line that you go. Okay? And just so you know, they don't choose to use fisheye lenses and wide-angle lenses to trick people. The purpose of it is to get as much data as possible, or photo as possible, in a small area. Like, which is easier, to take one photo or to take 40 photos and then stitch them all together? Like, I'd be going with the wide angle if I'm after a nice panorama view like that.
Well, they have another. Yeah, that you just took the words out of my mouth. They have another photo type. It's called the. What was you said the photographic?
Rectilinear?
No. It's the panoramic view. Whenever you take multiple photos and you make it a circle.
Oh, where they do a full 360.
Yeah, panoramic.
Yeah, panoramic viewing.
Notice how if you stop that panorama at any time, the horizon doesn't bend down.
Yeah, but
Because
you're
that's
also
what you guys.
morphing the original image.
No, it's not. No, that's not. If you do a 360, the horizon actually joins back together. So let's think about it. If you're facing north, so you're up on top of a hill, like that one there, you're facing north. When you look straight ahead, you're claiming you see a curvature. So right in the middle of north, the ground is higher than it is at the sides. That's what you're claiming that you'll see. Now, if you turn around and face south, because we're up on top of the hill and we can see 360, directly south is the high spot and at the sides is the low spot. Now, this is the interesting bit. When you turn east, do you see the dips of the norths and the souths joined together?
Well, by your logic, on your logic, it depends on the type of.
No, not my logic. You face north, it's supposed to be bending down at the sides. You face south, it's bending down at the sides. Now we turn in between the two, which is east. Are you looking at where they join together, the dip, or does it stay flat across?
It ought to bend at the sides the same way the north and the south does.
Excellent. So it stays flat across all the way around, doesn't it?
But there's a bend.
Okay, so where do these bends join together? You don't understand what I'm talking about? You can say, I don't understand what you're talking about. I'm not going to blind you.
I don't understand what you're talking about.
Okay, you're facing north. Okay, so you're telling me that you see in an arc. So at the front, it's high, and at the sides, it's low. Is that what you're seeing?
Leons. Okay.
Sure.
Yes, no?
Yes.
Excellent. So that's facing north. Most excellent. Let's face south now. We spin around, we face south. Straight ahead is the high bit, to the sides is the low bit. Exactly the same, yeah?
Yes.
Excellent. So now let's face east. We're facing both the low bits of the north side and the south side.
And there should be a bend in the middle or a curvature.
And they should dip down and join, but yet they don't. Excellent. So what happened to your curvature?
You just made what? No, you just made an assumption. They should bend the same
I haven't. No. That's what you're claiming. You telling me that it dips down at the sides. When you face north, it dips down at the sides. When you face south, it dips down at the sides. When you face east, and west, it's going to be the same as what?
As north and south. You'll have a bend at each.
So where's the dip there?
You're taking four different pictures.
If you're claiming it's dipping, that means when you face east, we should see the two dips joining.
Right. Whenever I
But yeah,
face
we
north,
don't.
Look, when I face north and I look
I'm gonna have to draw it for him.
When I look north and I face west, there's gonna be a dip, and the dip joins north and west. There's 4 different pictures we're looking at.
The dip is supposed to be on the east. So the north photograph and the south photograph have a dip on the sides, allegedly because of you. So when I face east, we should see where it dips.
Yeah, they join together at each
And
corner.
where's the dip then? Show me a photograph where the dip is. That's what I want to see.
There's no such thing as a 360 camera because the only way you're going to take a photo is by joining multiple different perspectives into one photograph.
So
Like a
it's
panoramic
not Earth
view.
curve then. It's not Earth curve. It's to do with lensing then.
I mean, it's the same with your head.
No, it's not Earth curve. It's to do with the lens then.
You have 2 eyes that have a
You
single
know,
perspective.
you're trying to dodge it. It's not Earth curve. It's the lens then.
Even with your own eyes.
You're trying to dodge it. Okay, even with your own eyes. You look straight ahead. You perceive it dipping to the left and to the right. You turn to the south. You perceive it dipping to the left and to the right. You turn either east or west. You don't perceive the dip in the middle.
You'll have to give me a description because I can see that with my eyes. I could see that.
Yeah, this is not happening. Right. Horizon. It's gonna work.
I've been watching these weird alien releases. Like, what do you flat Earth people
that's
about that stuff? Some of it looks
we
fake as
don't.
hell. I'm lagging now.
Yeah, it's not something we look into. It's a waste of our time. Don't look into the alien nonsense. I think today's news, though, Donald Trump said he's going to leave that for everybody else to work out what that stuff is in the sky. That's what he said. He's going to leave it for you to make your mind up as to what those lights are. Okay.
But
So now you're going to have all manner of ideas.
Yeah, but that sucks. He said we're not getting the last Epstein files, and look, now that half wasn't released and he's totally innocent, we're going to get the alien files. So we stop complaining, right? And now they're not telling us much. They're just like, oh yeah, we could have been testing these things. These could have been like Chinese aircraft or, aliens. Whatever, go.
Yeah, he said he's going to leave it for you to decide. Clearly, I'm not interested, but it's just junk. We know it's man-made, and it was put there by America or China. It doesn't really matter. Point is, it doesn't float my boat. We're living on a flat Earth, and we do not go to space. And the images that I've posted in the side chat, related to the satellites question, it's all in there. Please look at the material, and yeah. I've even posted something to do with vacuum chambers and what happens to film when you subject film to a vacuum. Okay, there's lots of material there for you to learn from. Take a look in the site.
I believe some of the moon footage is fake because you can't really get mice and rats in space. It's really hard to get mice
all of
and
them,
rats.
all of it is fake. You can't have some. All of it is fake. 100% of the material is fake. All of it. Nothing is real there.
The old stuff is because the tech wasn't there to take the
look, the old stuff and the new stuff, all of it is fake. Okay, it's all fake. We cannot go to that region, so they're faking it for you. Remember, Robert. Let me tell you something. Robert Simmons, Blue Marble. It's photoshopped because it has to be. So there we are. It's fakery all the way. Okay, they're faking it yesterday. They faked it years ago. They're going to fake it today, and they're going to fake it tomorrow. They're going to fake it on the day you're dying.
I think it's fake for a different reason. I don't think it's because we don't have a a horizon or a curve. I think it's fake because he can't get past the Van Allen radiation belt.
Yeah, the Van Allen belt is a problem, but they nuked it. They claimed they nuked it and they got past it.
Yeah, you
No,
can't
I
get
wasn't
Well,
there
no,
for
they
any
didn't
of it.
actually. Let me correct you there. Hang on. When you're talking about them nuking, what they did was from 1959 to 1962, Russia and America fired up some megaton bombs into the Earth's air above our head, and that apparently, according to the British astronomer Sir Bernard Lovell, stated that event or those events, that was Operation Dominic, Operation Fistful of the Lord, and the last one in 1962, Operation Starfish Prime. These events, or those events, created a radiation belt 100 times more lethal than the Van Allen radiation belts themselves. So there's 3 radiation belts they need to get through, and there's no way they're going to get through any of those. They would be instantly killed at the first one, if not the second or the third. So, okay.
So there is a way they could possibly do it in the future.
No,
There's
the
this weird
technology doesn't
mold
work in a vacuum.
eating radiation that
The
doesn't need
technology
oxygen.
doesn't
It's
work in a
anaerobic.
vacuum. Sure. The
I don't know.
technology.
Those things generally do. Those things are
No,
crazy.
rockets don't work in a vacuum. Generally, no.
It's
They
not
don't.
the
Hello,
rocket part.
YouTube Live. YouTube, what's up,
Not the
YouTube?
rocket part.
Yo, I have a
I'm talking
giant
about
ass.
yeah.
Yeah.
Not the
Yeah.
rocket
Okay.
part.
Fine.
I'm talking about the fungus part. There are ways
Well,
to
look,
get
if the
things
rocket, hang on.
back.
If the rocket can't get you there, it's pointless talking about the equipment working in a vacuum because the rocket can't get you to the environment that you want to
You
get
can
to.
fling
It
it
can't
up
go to
there. You can
space.
get close enough and shoot it in
No,
there
you
with
can't get
normal
anywhere
fit.
near there. You cannot go to space. That's the problem.
Mm.
Stop hanging on. You're hanging on for desperate. You're desperate here. I'm telling you
Think
point
about it
blank.
this way: if they can get to the electron belt, not to get through it, then they could get
They
to it
can't
to
get
deliver
there,
something.
ladies and gentlemen. No man and man's made equipment has ever gone to the Van Allen radiation belts, through it, near it. It hasn't happened. Okay, we don't go there. They're faking it all the way. Right? This man
Okay.
here is desperate and hoping against hope, but it's no good. I'm here to pop that bubble to tell you, no, they've never been there. We can't go there. The
Wait, but do
technology
you
does not
believe
work
that
in a vacuum.
exists?
Sorry?
Even if I grant you that, for the sake of argument, I grant you that. Okay, and say because I don't know, dude. I don't know if it's round or flat, dude. I don't know.
Well,
I'm
that's because
still
you don't know. We know
undecided
though.
between the middle
We
ground.
know it's flat. We know it's flat.
Yeah,
That's what we
but
know.
so for me,
Fuck's
so
sake.
we say we give that to them. Let's say, yeah, I give you that. For sake of argument, that's true. Okay, then
All
there's
right.
still a weird thing about these disclosures. There's always a reason they give you something. They don't give you something for nothing. Usually
That
you have
isn't
to beg
okay.
for something. If they want to give you something, it's a suspect thing. It's suspect if they want to give you something. If they want to give you a vaccine, that's suspect. If
Yeah.
they make you pay for something and beg for something, that's usually what they do. They don't want to give you food, okay? They don't want to give you the things you need. They want to give you things that are usually fucking questionable. Okay, so I get this whole thing where these pedo guys, friends 20 years
Yeah.
on
Yeah.
the
You're
island,
watering. Excuse
drinking.
me. You are muddying the conversation here by bringing in
No,
unrelated
but
topic
wait.
matters. Can you
I'm
stop
trying
that?
not to do that.
Yeah. Yeah.
What
Don't
I'm
do
saying
that
is,
because you'll end up getting muted. So stop
no,
that
just,
immediately.
no,
Right.
but
Just keep it
I'm going
related to
somewhere with it.
keep it related to what we're talking about. We've got the
It kind
gist
of does.
of what
It
you're
does,
saying.
but just hear me out. There's a
Yeah.
reason it relates entirely. So if we take this to now, right, and say, okay, shit, I just lost my train of thought. Fuck.
Mind your French.
Yeah. These alien disclosures, regardless if they're true or not, there's a reason they're dispensing these things. And I'm not sure why. First off, I think, yeah, sure, it might be to cover up the Epstein disclosures, okay, because they want to cover some stuff up.
Let's not go down that road, but okay.
But secondly, why else would they do this? There's
Okay,
usually a
can I
reason
answer
for
now?
it. Now,
I'm now
So let
going
me
to
get this
answer.
straight.
You
You've
don't
dropped
know a lot.
into a flat Earth channel and you want to know why alien stuff is getting blasted all over the television. I'm sorry, I'm not a producer at Channel 7. I don't know.
Yeah.
Yeah, but there's. I thought you guys might know about Blue Book and Blue Beam and some of these
Well,
old things.
Well,
it's
yeah,
highly
yeah.
probable there's a few people that have looked into some of these other ideas that have been
Mm,
floating around for a long time, but it's not normally discussed in here. They tend to just
wow.
talk about the shape of the earth in here and people putting forward their claims, so on and so forth.
Right.
Ah,
So,
cool.
so what you're putting forward, sir, is that it's just another assumption. That's all it is. It's not anything concrete. They want to give us aliens because that's another little agenda that they might be putting forward in the very near future or the distant future. But it's a waste of time for us because there's no proof of aliens here on Earth. Thank you. All right. So we don't waste our time with it at this point. What we do know is that those moon landings were a hoax. Artemis also a hoax. We're not going to be going to space anytime soon or any distant future. It's not a place we can go to. It's not a place we can go to. Do you understand that? Thank you. Stop hoping.
For me, it's not, dude. I don't really want to go there. It's a place full of radiation. It doesn't really matter if it's real or not. Not for me, at least. Like,
Yeah,
I mean, I don't want to
supposed
go to an
radiation.
empty place that freezes and is it like sucks. I mean, what am I gonna do there?
Yeah,
This
yeah,
is
we
kind
don't.
of a
Yeah, we
weird
can't do that.
question.
The thing is, we can't do that. That's the thing.
Yeah,
We
but
cannot
I
do
don't
that.
even want to go. It's fine, man. It's like,
Yeah. Okay. Cool.
A
Then
weird
the less we
question for
speak
you.
of it, the less we speak of it, the better, really. Because I only talk
How
about this stuff because other people bring it up. I generally, with my knowledge, don't talk about the vacuum of space and space travel. It's only when globers come in and they start talking about satellites, that's when we have to start talking. Generally, I don't talk about it. It's not a place we can go to. Don't waste my time with that.
the Van Allen radiation belt? I feel like you have to believe in a spherical globe in order to believe that that exists.
Thank you. Thank you. Exactly. It evokes a globe, you see. Right. That's why if what they're telling us is true, in that the belts are there, then they would have been killed instantly. Instant debilitating levels of death or death levels. Sorry. That's exactly what it. So if they had gone, but we know they didn't go because their astronauts are still alive. Okay, and there we are. So
So
yeah,
then you believe that the moon landings were real?
I know the moon landings were a hoax because if they
So
had
then you
gone,
believe in the Van
hang
Allen
on a second,
radiation
you're not letting
belt?
me finish. You're not letting me finish because if they had gone, they would have been killed. Simple as that. They would not have returned.
But then they didn't go, and so then
Correct.
therefore the radiation belt exists, and that the Earth
Not
is flat.
necessarily so.
No,
Not necessarily so. Yeah. Just that they didn't go. Is what we're saying, and they
full
didn't go
stop.
because they
Not
can't go.
because of any of your radiation belts or any of that jazz.
Oh,
It's a violation of the second law of
well,
thermodynamics.
thermodynamics. Yes, that's right. So it's just not possible to go. It's impossible. You see, the second law of thermodynamics shuts it down completely. It's the end when you hear that. Shouldn't be talking anymore about it because you can't overcome that. But if you want to entertain and slip past the second law of thermodynamics somehow, you're still going to be met with death through those radiation belts. So it's just impossible. And equipment will die as well.
But you
So,
believe they exist.
no, I don't believe they exist. Thank you. I haven't proven that they exist.
End of
So obviously,
discussion.
yeah, I don't believe they exist. I can't prove that they exist. All I know is NASA isn't going into that region. From what they give us, the information they put on the table proves that they cannot go there.
Let me read this for myself. The second law of thermodynamics states that total entropy disorder of an isolated system can never decrease over time and is constantly only if all processes are reversible, which means as above, so below, basically. That's what I'm reading it as.
Right. So there we are. Okay, there's no way they could have gone. The equipment doesn't fare well in that kind of environment. If it were to break the second law of thermodynamics, it would not fare well. So we know they didn't go. Okay.
Yo, Jim.
Yeah.
How are you?
Oh, I'm very well. Thank you very much.
How many times have you had to answer that question about the rockets on the space?
Oh, many times. I enjoy it because I like to dismantle their ideas and get them to become aware that it's not possible to take rockets to space.
No.
So over the years, many times, hundreds of times, thousands, over the last 14, no, a bit more than that, 25 years. Long time, isn't it? Long time. Yeah.
Not one good like rebuttal from the Globers.
No, they do try, but we're just totally destroying them with the facts and the reality of those facts and the ramifications of those facts. Yeah, no, they can't hold a candle to us. We're at the level where we're reverse engineering everything they do now. That's what we do. Our scrutinization is one of reverse engineering it all because we know they can't do it. So let's take a look at what they've been doing.
Yeah.
Yes. The science behind the fakery. Yeah, go ahead. That's why some people get very, very emotionally hurt when you tell them this, but that's down to them. They've invested so much into it that they become emotionally unstable. Sorry. One of the biggest learning curve for me is I didn't realize the importance of air, and the lack of air is the one I should say, the lack of air in our lives and what it can do. That's vacuums. That was a massive learning curve for me in recent years. Because I never knew that outgassing was a thing until I looked it up. Yeah, and I thought, wow. And I actually witnessed cans of film smoking. That's the outgassing. I thought, wow, that's what a vacuum can do. Amazing. And in some cases of boat building and speedboats and that, and what else? Crafts that run on the water, they put them in vacuums where they want to get bonds to adhere to each other and to apply it to wood and that and the materials. They put them in a vacuum so that the material, that bond, is drawn through the wood, so that it really does make a strong adhesive bond. Didn't know they did that, but they do that as well. They use vacuums for that. Interesting. If you're going to keep burping and that, you need to mute your mic because it's coming across rather disgusting on this nice clean server that we've got here. Yeah. So the vacuums are very powerful, and they're utilized in all kinds of industry. I just mentioned one, shipbuilding. Well, boats in particular, boats. Yeah, very interesting indeed. Yep, someone's got a hiccup there.
Sorry.
Y'all should send a challenge to Neil deGrasse Tyson.
Yeah, what would this challenge be?
On flat Earth.
Yeah, we've done that already, and he pulled out at the last minute. He was invited to come to Discord to discuss it, and then he was forewarned not to go there, and so he pulled out. He was going to debate Eric Dubay, and
He'll
there you
never.
go.
He ran
He'll,
away?
he'll never accept that ever. He knows the Earth is flat.
Yeah,
Ain't no way, bro. He ran away, bro.
yeah. He was told. Apparently, he was informed. Obviously, he was informed not to do that because he would have lost.
Damn. That's crazy.
Yeah, good for us because it's because of us that they're panicking now. The powers that shouldn't be with all their lies. Yeah, they have to react to our expose. When we expose something to them, they react. Yes.
Just think if it was actually a ball, they would come in here in about 2.5 minutes and prove the Earth is a ball, and none of us would be here.
That's
So,
right. It's very true. They would have drowned us with all the facts that we missed. Yeah. Thus embarrassing us. But no, the embarrassment is on their side, not coming here.
yeah, here we are 15, 20 years later. Still here. Looking
Yeah.
for ball evidence.
Clearly, if we've been here for 11 years doing this, clearly there's no globe, right? So what are we doing here? We're continue to inform the truth. That's all. So it's one of counseling in some cases. But we're here, and we're going to be here for as long as the Discord is up. We'll be here. And just because the Discord is not up doesn't stop us. Books are being published. One's out there now called Welcome to the Flat Earth. It's out there. Quantum Eraser's book with his colleagues. They've done a nice book there. Go and have a look at it. Nathan Oakley is in the process of having his book released now. So there we go. There's 2 books have come out this year. Well, one book is out. The other book is in the process of being published as we speak. So there you go. All right. All roads leads to flat Earth. I think is the Nathan Oakley's title. If I'm correct, I hope. That's the title he said he was going to go with. That's got great potential because it's like it's Nathan Oakley's journey. That's what that's about. His journey through flat Earth and the characters he has met along the way. Yeah. Yes, and during the 11 years, we've encountered scientists, physicists, teachers, professors, and they've all lost. They've all failed to prove their globe to themselves, yet alone to us. All right, I'm going to go off and get some rice snacks. I shall be back. Stay tuned.
That's crazy, man. So I guess Mr. Tyson's a fraud, huh?
I mean, he's black. That should be enough for you.
Hey
Whoa.
yo, hey yo.
But he's definitely a fraud. But I don't think color has absolutely anything to do with it. It's kind of
Isn't Jim black?
kind of a shitty comment.
I don't think any color has anything to do with that. Yeah, like a fucking Jew, dude.
What was that you were mumbling about? Your mama?
What? You talking to me?
Are you a baller?
Hello?
Am I a baller? Somebody asked.
Yeah, you can read.
What does that mean? What's a baller?
Do you believe the Earth is a ball?
I don't really know or care. I just like listening to the debate. What's up, guys?
All right. Where did most of your people go? Hello? If someone would please, I'm actually asking in all intellectual honesty about how flat earth society, flat earth philosophy takes into account the Coriolis effect with an open mind. I am not here. I've never been outside the Earth's atmosphere. I don't know what the Earth looks like. Most of my understanding of space and science comes from a dogmatism, which is that I believe whatever my teachers tell me in school. I am not saying I am right. I am just saying I want to understand what the flat Earth perspective is on the Coriolis effect. That's it. Thank you.
Sorry, I heard some of that. Were you talking to anybody?
Just anybody in the void, anybody at all. It doesn't matter who
Right.
responds.
Yeah, you're asking about Coriolis, right?
That's correct, sir. Yes, thank you.
So, do you have a proof that Coriolis is a universal force, or a constant, if you like, a phenomena?
Well, there is a constant for Earth, but there is also a constant for every planet.
So hold on, if I go into my bathroom right now in Australia and I flush the toilet, you'll be able to tell me what's going to happen, right, before I do it. So I want
Well,
you to give me your prediction first.
it actually depends on what kind of jet comes out. If the jet points in a certain direction, it's going to follow that direction. In
Well,
fact,
this is called the
yeah.
Australian Aroma Deluxe Double Flush Mode, half flush for the yellow, full flush for the brown, and it dumps basically straight into the back of that porcelain beauty, and then it hits the rim in such a way that the water travels around all the way at the front, so it's spilling off like an interesting fountain, and we'll see which way it spins.
That's exactly my
All right,
point.
I think for like half a second there, for half a second, I swear it went anti-clockwise. But that's only as accurate as me telling you that the Earth is a ball.
Interesting.
So that test didn't really work. Do you have a more conclusive proof of Coriolis effect?
Shooting rounds downrange at over 300 meters. I know that when we get
So
to the southern hemisphere, we
like
instead of shooting left, we have to shoot right.
what?
Instead of shooting left, when we go to the southern hemisphere, we have to shoot right.
So your target is on the right, and you're aiming a gun at it, and
That's
then you
correct.
realize you're in the wrong hemisphere, the other way.
Well, that could actually be a way to find out which hemisphere you're in, yeah. But I'm just saying, whenever I do shooting competitions in the southern hemisphere,
I just want to understand what you want me to picture here. There's a correction path for the bullet where it
yes.
pulls to the left or the right of the target based on the hemisphere. Can you show me that on video?
I don't have a video readily available, but
like a cool plot, or like an Angelina Jolie movie where she's like teaching this guy to become a secret assassin that curves bullets, but
yeah,
it's
like
not
the
really.
Kingsman. Like the Kingsman, yeah. Like I don't know, they curve bullets or whatever. I mean, I don't do
Well,
this.
look,
I shoot for competition. I shoot for sport. I'm a
okay, so
sportsman shooter.
you're asking.
Wait, I don't mean to disrupt.
The opinion
is actually exactly why I came here. Have any of you been to the vegan Discord? That's actually perfectly on point.
I have not. I've not. Tell us about it.
I was going to say that this is in the English Discord, which this 24/7 Flat Earth, some half of the time is in the English Discord. the vegan Discord.
You hear that, guys? They know you're in another Discord.
No. They say this. This is not a secret. Look, to me, I've been in that vegan Discord. Look, and I'm like very vegan sympathetic. Like I actually was vegan for a little bit.
Hey.
I'm not like a militant carnivore, and I've
So
never
am
gone
I.
it. I've been in there a few times just to ask genuine questions. I'm not like anti-vegan, but they'll mute you and scream at you when you walk and you go in without, you get a few words out. You try to ask a question or say something. You're not even trying to make an argument or trying to, confront them. And
Yeah.
I
Well, it's
just
the
was
same.
curious how to me, it felt very similar to this flat Earth Discord. I'm curious if the flat
Exactly.
earthers have
And
been
Oh my
there.
that's
god.
exactly what I wanted to tell
Fine,
you.
fantastic.
Exactly. Because the flat earthers, they just have
Fantastic.
a YouTube profitability channel running. They're making money off of this. They don't actually care if you're here for intellectual honesty or not. This is a dogmatic ideology. Hey, if you're going to be the mod, you're not doing a good job. I should have been muted and banned a long time ago. I'm telling you how it is.
Listen, you asked a question. I didn't even get to answer the question.
You
Here's
did
my
get to
answer
answer
to
my
the actual question.
question.
No,
Because
hold
I
on.
know you cannot answer the Coriolis effect. Anybody who studies physics understands that the Coriolis effect cannot be understood with flat Earth theory.
It's not
Just
real.
look it up
That's the answer.
yourself.
Why don't
No,
you
it's not that it's
squeeze
not real.
in
You can
with
measure
your
this.
words, email?
Something that is not real, you can't measure. Like Barney. Barney being a real
I told
existent
you it's
dinosaur,
gonna be-
you cannot measure. But the Coriolis
I
effect,
told
you
you
can very easily measure. It's a very easy thing anybody can do at home. What causes a Coriolis effect?
Talk about how bullets move, so show me some of that.
Pushes the momentum of the pendulum forward like that. Oh, is that not the Earth rotating on its axis? Is that not the Coriolis effect? If it is not, then answer me, what is this?
Literally, I was happily lagging through everything you said, and I
Of
just
course you
came
were,
back
yeah.
in.
Wonderful.
This
Well, you know
one.
what? Like, you're not worth my drunkenness. I'm 5 beers down. You're not worth it. You're not worth 5
Yep.
beers. You're not even worth a 6-pack. You're worth nothing.
My-
Have a good night, my friend. Your life is
I drink.
literally worthless. All right?
I
Have a
drink
good one.
beer. I'm sure he said something totally mind blowing about Coriolis, but can't control when my internet is dropping out. We got the credibility police on the line. But yeah, I mean, Coriolis, nice story. Can set up a bunch of things that make it seem apparent. Is it a detectable constant anywhere? No, it's not. Game over.
But you do acknowledge you're disputing the general consensus definition and view of what Coriolis effect is, right?
I'm disputing that it's displayable.
Well, the general consensus would be that it is displayable.
Well, there's lots of consensuses out there, like the Earth being a ball and that ball causing the Coriolis effect, but I don't have to accept group-based fallacy notions. Or consensus-based fallacy, if you like. Wait, is that the way you say it? I can't remember the way that you say the official term for that. Everybody is saying that, so I have to say
If I said those words verbatim in response to saying don't put a fork into an outlet, reasonably, you would still think I'm crazy.
Yeah, but you're not talking about actions that have known consequences. You're saying
No, but
that
but this is a known
tall.
thing. That's what I'm saying. Known based on consensus.
This is what you're
If you've never
saying.
stuck
There's a
your finger,
flaw.
if you've never stuck a fork into an outlet before, you would not. You'd have to rely on everyone else to know that. So this
I've
is where
been
this is
able.
why you seem equally crazy. That's my point. For that, I gotta go.
All right. Gotta have the Coriolis effect. If they don't, they cry. This Earth's the ball thing, just leaving little hints everywhere, like the Coriolis effect. You know, it's just how science works, I guess. Nowhere observable, like curvature. Just physics hints, I guess.
You guys figured out that Coriolis effect equation yet? Do you guys know what the fuck the Coriolis effect is? If you can send me that gentleman from New Zealand last time, I'd love to discuss the Coriolis effect with him. I'm just saying. You know, like let me tell you this, because you guys are of an open audience that is open-minded to different thinking, and for that I congratulate you. Have you ever tried disassociation? Like falling in a dream-like state, half conscious, half not, and basically just traveling anywhere? Have you tried to travel around the world? Maybe to the moon? You'll notice when you're in this dream-like state, these things are not flat. They're basically three-dimensional orbital bodies. It's interesting.
Real ass bitch give a fuck about a nigga?
I'm home. Hello. It's always exactly where I needed to be. Oh, I wish you had the time. Hello? Is anybody alive? Oh.
Where are all my flat Earth people?
In the flat Earth?
Yeah, I miss coming in
I
here.
want to talk about the curvature.
I just want to see. Wait. I can't tell if this YouTube thingy is streaming.
Hello? Hey.
Yo, the Earth is flat, bro. Bro, is the Earth flat, bro?
Uh,